All right, well, good morning, everyone. I hope everyone is well caffeinated for today and awake, because it's been, I can't believe it's Wednesday and it's already been quite the week. So this is a session about hybrid and multi-cloud desktops. My name's Sean Massey. I work for VMware. I'm a staff multi-cloud architect in our multi-cloud strategy and architecture team. And I kind of sit in that space between our multi-cloud products and our end-user computing products. I'm a VCDX from Wisconsin, and contact info, blog, etc. is up there on the screen. So with all things desktops and cloud, there's a lot of talk about licensing, and there's been a lot of changes in this space, both from the VMware side and from other parties that are involved in this. So I'm not going to talk anything about licensing, all right? There's a lot of other sessions that like our official, breakout sessions where people will talk about that. So I don't want to bore you. Plus, I hate being a sales guy at these things. But the other big thing with licensing is Microsoft, and I'm not going to touch that with a 10-foot pole. There's a whole bunch of people you can talk to who are experts in Microsoft licensing, and if you ask 3 of them, you'll get 6 different answers. So those are the people you probably want to talk to. So to get started, right, what do we mean by hybrid desktops and multi-cloud desktops and multi-cloud horizon? So it's like anything else when we're talking about hybrid and multi-cloud, right? Hybrid is you have your on-premises footprint and you're extending to, the cloud. Either one cloud or multiple clouds. And multi-cloud is across multiple clouds. Now, in the Horizon context and then the VMware context, that typically means, you have your on-prem vSphere environments, and you have one or more cloud-based VMware SDDCs, whether it's VMware Cloud on Azure or VMware Cloud on AWS, or our partners services like Azure VMware Solution or Google Cloud VMware Engine. But there are a couple of other things now where we are starting to do things with Horizon 8 and native clouds as well. But as we think about this, right, we're talking about extending Horizon 8 to the cloud. Well, aren't these the same as like multi-site on-premises Horizon environments? Well, kind of. There's a lot of similarities here, right? There's a lot of the same problems that we have because we're just taking Horizon and moving it to another site. But there's some key constraints and differences that we need to consider when we talk about doing Horizon in the cloud versus Horizon on-prem. And the first thing is that operational models here are different, right? When we are working on-prem, we own the full stack. We have to maintain everything from the hardware on up to the desktop. But as we move to different clouds and cloud-based SDDCs and partner-based solutions, those bottom layers become somebody else's responsibility. We don't have to maintain vSphere. We don't have to troubleshoot the hardware. We're paying somebody else to do that for us. So now we as operators can focus on the top ends of that stack. Now, this varies by cloud, right? Some partners will manage everything except the desktop for you. Some solutions will just manage the hardware and the SDDC, and then there's Oracle, which, they deploy the SDDC for you, but then it becomes your responsibility afterwards. So you can choose the level of management that best suits you and your business, and so you can focus on what's most important, which is making sure that your end users have access to their applications. Now, the second thing is networking, right? Networking is always a challenge with the cloud because the cloud itself has different networking models. The network itself is a shared service between you and other tenants. So the biggest thing with Horizon on a cloud-based SDDC is NSX. And that NSX T0 that sits at the edge of your SDDC is going to be the bottleneck because it is a software appliance right? It's sized for what a typical workload is, but desktops aren't necessarily a typical workload. And the reason for that is twofold. One, everything that your users are going to be doing in their desktop has to transit out that T0. So if they're accessing file servers, if they're accessing applications, if they're trying to go back on-prem for something, all that traffic has to flow through there. But that's also where all their protocol traffic comes through. So when those users are accessing their desktop, when they're looking, when they're interfacing with it, they're seeing the screen, that's also being scraped and sent through the T0 back to their endpoint. So you have all this traffic going through one point. Now, it's not necessarily different from on-prem because you still have your core routers, you still have your core firewalls that all the traffic flows through. But that NSX edge is not dedicated hardware, right? Your dedicated firewalls and routers can do, millions of flows per second and millions of packets per second and analyze and do all their networking magic with it. Well, NSX can do that too, and it does a great job of it, but it's a lot smaller, right? And it's sharing hardware resources with all your other workloads because it's sitting in the same SDDC. When we talk about hybrid and multi-site, there's one other constraint that gets layered on top of this, though, and that's protocol traffic hairpinning. So with Horizon and Cloud Pod architecture, which is our main method of doing site-to-site connectivity or site-to-site pairing between Horizon environments, if my user connects to like a global load balancer and it directs them to one site, they're going to hit the UAG on that site, authenticate, but then if their desktop is in another site, their whole traffic flow is going to be sent back out the T0 and through. So now that one user has two traffic flows through that T0. They're doing twice the number of packets per second that they would be doing if their desktop was here, on top of all the other traffic that's going to be flowing through that for applications and file servers and things like that. So this can significantly cut the number of desktops we can support in a cloud-based SDDC. Now, that's if they're hitting one cloud and going to another or going back on-prem. It's not necessarily the same if they're landing on-prem and going to the cloud because our routers typically on-prem can typically handle that traffic flow. Now, there's one other thing we need to consider with networking, and that's, well, they're going to take their cut of money on all traffic heading out, right? You can get all your data in for free, but you have to pay to get it back, or you have to pay to get it somewhere else. So there's outbound networking charges for any traffic that leaves that cloud or that SDDC. So you have to factor that into your design. And this is an older graphic, but it kind of illustrates the concept for VMware Cloud on AWS. I'll be honest, I don't know if these prices are still accurate or if they've changed since this graphic was made in 2018, but I pick it to illustrate the concept here, right? Everything coming in is free. Everything going out or going cross-region or going cross-AZ, you're paying per gigabyte for. So when you start looking at doing desktop services in the cloud and supporting the things that need to make the desktop work, like file servers and replicating files, you have to take this into consideration. Because one of the things that kills cloud projects the most is unexpected costs, and network is a big driver of that. Right? How many people does anybody have any experience where their CFO gets the cloud bill and goes, this is like 3 times higher than we expect? And a lot of that's driven by networking costs, things that weren't planned for or weren't budgeted for. So what does a multi-site or multi-cloud Horizon reference architecture look like? So before I talk about that, I just want to level set on our typical Horizon reference architecture components. And we do something called the block and pod design. The block and pod design is where we have a management block, which is this bottom layer here, of our connection servers, our vCenter, our database servers, and anything that's really going to support the Horizon deployment. This is all the management stack. Then we have what we call a resource block. The resource block is where we're going to run our desktops or our published app servers. And this makes for a very scalable architecture. So if we want to expand our Horizon environment beyond what one vCenter could support, or we want to have desktops in one and published apps in another, we can just scale this out by adding additional resource blocks that all connect back to the connection servers and UAGs in this management block. Now, we also have an integrated design where all of this runs in a single resource block, where we have our management with our connection servers running with our desktops or our published app servers and our vCenter. And this is kind of an integrated design, typically seen with something like VMware Cloud Foundation, or in really small environments where, you know, a couple hundred desktops or very special edge use cases. Well, we can translate these designs to the cloud. And that integrated model maps up nicely with what we call our all-in SDDC model. The all-in SDDC model is our cloud-based SDDC, all of our management components, and all of our desktops running inside the same environment. And it maps up pretty cleanly to that on-premises model. We also have a federated model. Now, the federated model is very similar to the traditional block and pod architecture because we are now making our management block the native public cloud service. So for AWS, as an example, this would be putting all of our management components in EC2. For Azure, this would be putting everything in Azure VM, and Google would be in Google Compute Engine, right? So we're able to make this our management block, and then we scale by adding additional SDDCs as we need them. So we can avoid some of that hairpinning that we talked about earlier, because now all that traffic coming into the desktop is coming through whatever our native cloud service is, and then going through the backbone to that cloud-based SDDC. Now, we have one other way we can do a federated model, and that's what we call remote vCenter and remote agents. So we have the ability to take like an on-premises Horizon environment and connect it to a remote vCenter in another location. And then we can provision against that SDDC in that remote location. So we can extend our on-prem environment without having to deploy a whole second Horizon pod. Now, this does have some networking requirements. You have to have a fast, low latency connection. And by low latency, I mean less than 120 milliseconds round trip. So it needs to be fairly local. You're not going to be doing this, you know, across an ocean to an SDDC in Europe or in like Australia, as an example. But all you have to do, right, when you go to add a vCenter, you just select the type of vCenter you're using and the URL or the URL to it, and it's that simple to just to connect a remote vCenter, and it works fairly well. And then you just get another resource block, even if it's remote to your location. So just to kind of summarize, right, the two deployment architectures that we have, the federated model is where we put all our management components in a native cloud platform, right? All of our desktops and RDSH servers are located in our cloud-based SDDC, the cloud-based VMware environment. And we can scale that using multiple SDDCs. Now this, because we're putting all our management in a cloud environment, we can scale this. We could scale this to be fairly large. Now the drawback of this is that you need to have native cloud platform knowledge, right? So if you're doing it in Azure, you need to have people who know Azure. If you're doing it in Google, you have to have people who know Google so they can get all the firewall rules and networking and all the constructs set up correctly. Now this compares to the all-in SDDC model that I mentioned. The all-in SDDC model puts everything in the SDDC. Our pod boundary becomes that boundary of the SDDC. And this is small to medium scale. Typically no more than 1,500 desktops, although that will depend on your workload and the particular cloud. And you don't need as much cloud platform knowledge because you're not consuming native cloud resources to set this up. So high level, when we do Horizon in the cloud and we start factoring in all of our services, this is kind of what it looks like, right? You know, we have our Horizon environment, whether it's all in SDDC or deployed in the native public cloud. We have things like Active Directory, our file servers, things that we have to be able to replicate and connect from on-prem to the cloud. So we also recently started introducing a new deployment model for Horizon 8 in Amazon. And that's with support for Horizon on Amazon Workspaces and Amazon EC2. There's an article up on TechZone for this that walks through all of what you can do. This fits our federated architecture in a lot of ways, but it also gives you support for things that you can't get today, like GPUs. And there's some Microsoft licensing things that go along with Workspaces, which I promised I would not talk about. The drawbacks to this approach, though, today are you're deploying to a native public cloud platform, so there's no provisioning management, there's no power on management, right? You have to do all this manually and then add it back into Horizon. But you do get the ability to do like remote agents, so you can still deploy in EC2, and then if you have a connection to Azure or Google or whatever cloud or back on-prem, you can still connect that and manage it all from a cloud-based location. Just keep in mind, though, that you are still being charged for any network traffic leaving Amazon. Yeah. So, and then we have KBs that talk about feature parity and what's supported for Horizon on all of our public clouds. These KBs are updated fairly regularly as the platform and our Horizon capabilities change. So if you are looking at one or more public clouds, it is definitely a good idea to check these on a regular basis. So having talked about reference architectures and everything like that, we can't just focus on the Horizon pieces. Success for any desktop project in a hybrid or multi-cloud or even multi-site deployment depends on a lot more than just having a good Horizon architecture. Because when I go back a couple slides, we have all of these pieces here that Horizon relies on, like Active Directory and our file servers that we need to design for. So let's start first with Active Directory, right? This is probably one of the biggest things because without Active Directory, Horizon doesn't work, right? Horizon relies extensively on this, not just for authentication of users, but also for provisioning desktops. You have to have Active Directory there so it can actually create the desktops that users log into, because it's going to create computer accounts for them and make sure that they're joined to the domain and everything's working properly. So the best practice and what I recommend to customers and partners is you should have a full-fledged writable domain controller near that Horizon environment. And by near, I mean in that same cloud region, availability zone, whatever, right? Read-only domain controllers are problematic because if it can't reach back to a writable one, users can't authenticate. Computers can't join the domain. If you don't have one nearby and your network goes down, your environment is effectively down. And there's a lot of other complex things you can do with this, like having a cloud-native Active Directory service that you set up a trust with, or do multiple trusts. But that has a lot of complexity. And for some organizations that aren't used to that, it adds additional management overhead. So what I recommend, try to keep your Active Directory topology simple, keep your domain controllers nearby, and make sure AD sites and services. This is another thing, right? As you add new sites to Active Directory, you have to set up site links, you have to set up replication. You need to make sure that those are set up, and that way the desktops and the users know where to find the nearest domain controller to authenticate. So that also has some performance implications for things like group policy and login times. So as you can see, right, Active Directory plays a huge role in this. Now, when you talk to security people, and this might not be as true now as it was 5 years ago, but there's still a lot of people who hear domain controller in the cloud and panic. It's like, I can't do that. We can't put a domain controller there. It's the keys to the kingdom. If somebody gets it, they have full access to the environment. Well, that becomes a trade-off then, right? There are ways to secure domain controllers in the cloud. There are other ways to accomplish what you would need to accomplish to deploy Horizon in a cloud scenario. But if security people come in and say, no, we're not going to do this, or we have concerns about this, you have to start talking about the other impacts to the environment, right? Availability becomes a big one, right? I can make this secure, but the availability goes down. And availability is key. You need to have that domain controller available. And it also affects performance. Because if my domain controller is on the far end of a WAN link, whether it's a 100 meg or a 10 gig link, that's still latency. My desktops have to check in with that domain controller. They have to download group policies. My login time just at least doubled by doing that. Manageability also becomes a concern here, because I mentioned, right, there's cloud-based Active Directory solutions that are managed for you. You can set up separate domains. But then that means you have to deal with trusts and cross-forest group policy processing and making sure that referrals are set up correctly so that users can find the correct domain controller. Database, this one's less of a concern in the cloud, just because for most things, you don't actually need a database unless you're doing app volumes. You don't need a database for Horizon, although it helps for the event database. And there's a lot of cloud-based services you can tap into to have a database solution. File servers are the other big thing, though, that you need to consider. Your Windows file server is critical, especially if you're doing profile management and you're capturing that profile data with a dynamic environment manager or another tool. You have to have file servers near the environment, but then you have a whole bunch of options and a whole bunch of choices, right? Where do I put my file servers? Do I do Windows in the SDDC? Do I do Windows in the native cloud service? Do I do some sort of cloud native service? Am I using something like Pure Storage on-prem, and can I use their virtual appliance? So those all factor into your choices, and those all impact cost. Cost being the biggest thing in your design considerations. Now, you also have to consider things like the size of your data set, the rate of data change, because that's going to determine how much data gets replicated back and forth. And again, that goes back to cost. But you also have to consider, where am I going to place that data? What impact is it going to have on my user performance, or my user experience and performance? So key takeaway here, because I know we're running up on time, you can do Horizon across multiple clouds. You can stretch from on-prem to the cloud, and you can do it by and you can deliver a good user experience by doing this. You just have to keep in mind everything around Horizon in order to deliver that good experience. Finally, we have a bunch of reference architectures up on TechZone. The QR code takes you to our reference architecture page. And I want to make Al happy by finishing a minute early, so I want to say thank you for coming. If you have questions, I'll be over here getting unmiked. So thank you.
Good morning, everyone. My name is Matt Langeth. I am a staff technical adoption manager at VMware, focused on our end user computing product set, specifically Horizon out there in the field. This session, VMTN 2816LV, covering our Horizon Cloud service on Azure. So if you're here for AI or ARIA operations, wrong session. But if you're here for today for Horizon Cloud on Azure, thank you for joining us here this morning. So this is perhaps the most important slide in the deck. This is a QR code that goes out to a blog post. And while I can't share this specific deck, hint, hint, wink, wink, there is a copy available out on the blog post. And why is that important? Well, this deck contains reference links to our knowledge-based articles, TechZone documentation, and other reference architecture that is important for your Horizon Cloud on Azure adoption journey. As the product is also evolving, I'm updating the blog post as well. So as we're having new information that comes out there about the product, the blog post will get updated and the deck will be as well. So perhaps a link that you want to bookmark and have. So a little bit about my background. Again, I'm an EUC-focused technical adoption manager. For the last year and a half, I've been working with some of our largest Horizon Cloud on Azure customers. Between the two that I'm primarily working with, we have over 10,000 desktops deployed out there in multiple Azure regions. So this deck is, as you say, a kind of a best practices of what we've learned as far as support and deploying the product and whatnot that I'm here to be able to share with you today. So we talked a little bit about the background. I want to be able to share some HCOA resources that are out there, where Horizon Cloud on Azure fits within the Horizon Cloud product portfolio, some cloud considerations. So regardless of what hyperscaler you might be moving your desktops to, whether that's primary or using it for HA or disaster recovery scenarios, bigger picture, right? What you need to consider when moving desktops from on-premises out to a hyperscaler. Then we'll talk about some differences between the V1 and V2 versions of the product. Again, with HCOA, there is a fundamental difference in architecture between the first generation and second generation of the product that you need to be aware of. We'll talk about why you would want to consider deploying version 1 versus version 2, and then some of the migration options that you have if you're a current V1 customer and what that would look like to move your estate over to the next generation of the platform, and also talking about some of the timelines to go along with that. Talk about some of the reporting considerations that you need to take into consideration if you're a current V1 customer, and we'll cover some of the ways to optimize your support experience when using HCOA. So let's talk about some of the resources that are out there for this particular product. First of all, there's a demo available in two different forms, really three. We have a hands-on lab walkthrough that is free, absolutely available. Register an email address out there, and you can interact with either version 1 or version 2 of the product. Walk through, see how it works, look at the reporting interface and whatnot, and again, that's linked here. There's also a 60-day trial that is available. So I call this BYOA, Bring Your Own Azure Service. Okay, so if you want to take it to the next level and you want to do that proof of concept where you want to test out some of your images, or how does this work as far as deploying and seeing how your existing applications would work with a remote desktop that's delivered via Azure, this would be a means to do so. Again, 60-day trial that's out there, and then we also have the ability to convert that trial over to a production instance, if you would. Also want to call out our deployment guide. Some of us, I was talking with some customers here this morning of what are the technical considerations? Our reference architecture. This links out to a full-blown walkthrough and reference architecture that's out there on TechZone. And then we also have technical deep dives that are available within the TechZone section of the Horizon portfolio on the EUC TechZone. And then if you consume information maybe perhaps better in a video form, we have the VMware End User Computing YouTube channel that has several series of HCOA as far as walkthroughs and setup guides and deployments and even additional capacity, or how the product might work if you have an on-premises deployment and want to do a hybrid environment where you would have entitlements for desktops both on-premises and in the cloud. Walkthroughs there. Again, this is all linked out, and if you would download a copy of this PDF, you'd be able to have these as references. So, excuse me, briefly here. So let's talk about where HCOA, and again, I'll use that acronym, so Horizon Cloud on Azure, fits within the Horizon Cloud product portfolio. I will say right away, we could have done a better job with our naming conventions here. Okay, this is a little confusing, but I want to call it out because even internally, sometimes we, let's just say, get the names confused. So there is Horizon on Azure VMware Solution. Say that 5 times fast, right? Horizon on Azure VMware Solution. Sometimes we'll call this Horizon on AVS. This is our PaaS, or Platform as a Service, or IaaS, Infrastructure as a Service offering. So this is where you're still managing the traditional on-premises Horizon stack. So your connection servers, your UAGs, right? Your app volumes managers, DEM if you're particularly using that, you are responsible for managing those particular operational elements. What VMware and Azure takes care of in this solution is the back-end core hardware infrastructure and the life cycling of vSphere, okay? But this is important to call out that these will be vSphere-based desktops. So all of the advantages that we would have with vSphere-based desktops, ESXi, VM fork technology for instant clones and whatnot. The offering that we're going to focus in on today is Horizon Cloud Service on Azure, right? HCOA, right? This is our DaaS platform, DaaS being the acronym Desktop as a Service. So in this particular instance, the only thing that you are managing is your desktop images, okay? Microsoft takes care of the infrastructure as far as the hypervisor, and VMware is managing on your behalf the broker, the UAGs, the display protocol, the DEM managers, and the app volume managers as well. It's important to call out that this is an Azure-based desktop, right? That's the key differences between these two solutions. Azure-based, as far as their hypervisor, versus Horizon on Azure VMware Solution, where it's ESXi. So if you have needs for things like instant clones, right, you would be considering Horizon on Azure VMware Solution. If you're looking to do HCOA and instant clones as part of your deployment, you might want to take into consideration maybe having more desktop deployed so that you can have that burst capacity available. So let's talk about bigger cloud considerations. Again, this is stepping away from Azure in particular, but if you're removing any type of on-premises workload over to a cloud, some things to keep in mind. So let's talk about image rationalization. So one of my colleagues, Hans Bader, has said that if you're taking your existing on-premises desktop image and moving it over to one of these hyperscalers, you're doing it wrong. I could not agree more. This is the time, as admins, to take the time to do a proper image rationalization to find out what your CPU, memory, and storage needs are. Because in some instances where we deploy a desktop deployment, right? We spend hundreds of thousands of dollars on a cluster infrastructure, and we try to cram as many desktops as we possibly can, right? And we don't necessarily think about those fixed costs past the initial purchase. With Azure-based desktops, you're being billed for each of those individual elements. And as your deployment starts to scale, those costs can increase exponentially. So it's very, very important to do the proper rationalization as far as your image sizing. I will touch on some of the savings that can be out there that we ran into with a particular customer in a moment. You also have to consider what you're using for your profile management, right? And how that's going to be carried over into a hypervisor or a hyperscaler environment. Is your current deployment compatible with a hybrid environment, right? What are you going to be using for storage? How are you going to be doing replication between on-premises and that cloud, right? All items to keep in mind. I call out Windows 11 here, is many organizations are looking to move their estate to either Windows 11 as a whole or perhaps Windows 11 multi-session. Is this the time to consider that, right? Perhaps other than using Windows 10, in this limited deployment, you could use Windows 11 here to use that as an acceleration pathway to start your Windows 11 adoption for your organization. Windows 11 in both version 1 and version 2 of HCOA is fully compatible. We'll touch on a little bit of the details though with that, with some callouts there. And then of course we want to talk about your HA and DR strategy, right? Often customers want to have multiple Azure zones deployed with these desktops. But remember, and it's important to call out here, these desktops are just a means to get to that application, right? In some instances, if you can deliver the app alone, you would do so. The call out here is, if you don't have HA and DR for that particular application, what's the point of having multiple Azure zones deployed, right? So we could have it in an example, desktops in US Central and US East, but if those desktops are going to an enterprise application that's in a single data center, and that data center goes down, is it really worth the cost of having that availability between those two zones? Items to call out and to think about and have discussions with your executives about. And then of course, you need to think about how app volumes and of course apps on demand ultimately play into this strategy. Going back to our first part with image rationalization, anything that we can do to shrink that desktop OS base image results in a cost savings. So if we can start to rather than bake the application into the desktop image and deliver it via auth volumes, there is potentially huge cost savings there. So let's move on to some cloud considerations that are more Azure focused. So of course we want to make sure that the region that you're deploying HCOA into or that you're considering has availability. If you follow this link out there, we're kind of vague. We say HCOA is available in most Azure regions. So the big ones that are out there, of course, over in EMEA, US Central, US West, and whatnot. But if you have that particular use case where you're trying to do a one-off deployment, always check with your VMware EUC resource to make sure HCOA is available there. We also want to talk about data and application locality. This is a giant one, right? We often see where customers want to put these desktops as close to the user as possible. That's wonderful. However, I'll go back to my previous point of it's about the applications. These are a means to get access to the applications. So if the application is in a US data center, but the desktops are in a foreign Azure zone, you're kicking the latency problem down the road, right? So a big thing to keep into consideration. And then I'm sure I see some heads out there shaking in the audience. It makes all of that troubleshooting that much more difficult, right? We also want to talk about cross-region replication. So if you're doing multiple Azure zones, You want to make sure that there is cross-region replication for back-end things like file services to take into consideration. And of course, taking into the overall picture of IP address space and network routes as far as how these users are going to be gaining access to the environment. We also want to consider what you're using for your identity provider. Excuse me. Right now, as far as an identity provider, there is two means of doing so that are compatible. You can use a hybrid deployment where you would connect an on-premises domain controller and have a traditional IDP there that you would have through Active Directory, or you could use native user-based authentication via Azure. I had called out Windows 11 compatibility, but if your organization is using certain versions of either Windows 10 or Windows 11 that, let's say, have been approved via your InfoSec, you have to deploy certain versions of either version V1 or V2 to be compatible with that particular Windows iteration. So think of like 21H2, right, for out there for Windows 10. There is only certain versions of HCOA that are compatible with Windows 10 or Windows 11. The link here takes you to the entire matrix that's called out. And then quickly switching over to the business side, this is a great time to bring in your cloud operations team, okay? And what do I mean by that? Well, sometimes traditional Horizon operators, this is their first big project where they've worked with your organization's cloud operations team, right? They may have done some Luna deployments, but this could be the first real engagement, so to say. So they're gonna have operational questions, right? Network security gateways, VNets, how that all plays into their Azure deployment. And especially, regardless of V1 or V2, we're going to be deploying elements into your Azure tenant. And the minute they hear that, the radar goes off, right? It's from both the cloud ops and the InfoSec team. So the sooner that you can get them engaged in this overall deployment, the better. Let's talk about cost savings here, okay? So I'm linking out to the Azure price calculator. If you take the exact same desktop deployment, so let's say 2 vCPU, 4 gig of RAM, maybe let's say 40 gig base OS disk, and you move that through different Azure regions, whether that's even within the US or over to EMEA or APJ, the cost can differ dramatically. So it's important as part of your overall strategy, not only with data and application locality and where they are with the users, but also to take into those cost differentiation comparisons with Azure zones. Let me give you an example here too with the desktop machine profile. I have a particular customer that has 2,000 persistent desktops deployed. Yes, I know, persistent, but the use case is out there, okay? It's justified. They have a 256 gig base OS disk. If we take that disk and we cut it in half at their discount, which is one of the highest I've ever seen as far as an Azure discount to them, the cost savings annually is over $100,000 a year just in the base OS disk. So again, this kind of plays into that image rationalization and which applications you're baking into the image versus what you can deliver via app volumes. It all adds up. Also, it's been my experience, Azure makes their money by, if the machine is running, it's charging a bill. So power management plays into this very, very critically. We have the ability to turn the machines off at user log off via idle time, and we can also set these settings at the pool level. There's a great article here that we'll call out that Rick Turlip did with our technical marketing team to detail all of those power management sessions. I also want to call out another great session here. I'd referenced Hans before, that he dives into all of these cost management strategies tomorrow afternoon. EUSB 1379. If you're not here tomorrow afternoon, this session will probably be recorded. And again, it's one to call out. Great session on cost management for the hyperscalers. So let's talk about deployment deliberations. I'm going to do a quick time check here. So with V1 versus V2, right? First of all, V1, you must request. You absolutely must request. So by default, you're going to get version 2 of the product. The big difference here, if you have endpoints that still require PC over IP, you must deploy version 1. So if you have those Teradicis that might be out there, only in version 1 is PC over IP supported, okay? Currently, also, if you want to do a hybrid deployment, so you have traditional on-premises desktop deployed, and you're looking at HCOA for burst capacity, and you want to entitle those users to both on-premises and these HCOA desktops, you have to deploy version 1. That's coming in V2 very, very shortly, but it's a current limitation. You also have to take into consideration where we're at in our timeline with deprecation of version 1, and we'll touch on that in just a minute. Okay? In version 2, again, blast only. Falls in line where we're at with the entire Horizon product portfolio, where blast will be our display protocol of choice. And there's also important here to call out that the user login sign-on workflow is a little bit different right now for version 2. So we're directing, as part of the sign-on process, all users to go to cloud.vmwarehorizon.com, and then they'll enter a domain name. So why is this important? Well, one, you might have to do some user training with that. And two, if you're using thin clients, some thin clients produce some errors with this logon workflow. A lot of the manufacturers that are out there are updating their BIOS and firmware to come around this hurdle. But again, where you're at with your endpoint management and life cycling thin clients, I know we all try to get out there and make sure that they're as current as possible, but especially with those bigger fleets, sometimes that's difficult to do. We're going to support custom domain names for that login process here shortly, but again, if you're considering a V2, it's one there to call out. And we're not quite there with feature parity yet with V1 to V2. So things like proxy support. So if your InfoSec team doesn't allow direct access out to the internet from your Azure tenant, we have proxy support in V1, but not in V2 yet. And perhaps if you're a federal customer and need FedRAMP compatibility, that's not out there as well. There's an internal VMware document that you can reference with your VMware EUC resource that will compare where we're at with feature parity, and this is rapidly evolving. It's again why we kind of go back to this blog post idea, because we're very, very quickly getting to feature parity between V1 and V2. Okay, I also want to call out here where we're at with this timeline to version 2. I'll use the terms version 2, next gen, and Titan interchangeably here. They all refer to the same product. Titan was the internal code name. But recently, we announced 2 key dates with version 1. Okay? The first one is 31 October. So if you're an existing V1 customer, after the 31st of October, you will not be able to deploy additional V1 pods. There is an exemption process to this, but by default, you will not be able to deploy additional pod capacity for V1. The second is 31 January of next year, where we want to be able to have all of our existing V1 customers over to V2. Again, there's an exemption process here, but by default, we're drawing a line in the sand to get customers over to that next generation platform. There is the exemption process called out here, and also our public knowledge base article that details these transitions. We'll talk about migration options. So if you're a current customer for V1, we'll do a quick chime check here, gentlemen. 2 minutes, so quick here. So you have the self-service option where you can go through, and as far as the automation, go through an entire automated deployment migration from V1 to V2. There is lots of qualifications with this. The qualification document is linked out there. It requires the latest build of V1, so you do not need to redeploy your agents. Okay, the agents automatically swing between version 1 and version 2. And the last step of the process is a confirmation. So you're allowed to check to make sure that the deployment is okay. And if it's not, you can roll back to V1. That documentation linked below, as well as the workflow detail. You can also do this as a greenfield deployment. So if you have an existing V1, you can spin up a new Azure tenant with V2, and you can point them to the same Workspace ONE access instance, so you can have a user that's entitled to a version 1 desktop and a version 2 desktop with the same Workspace ONE access instance. So that can give you some migration options there. If you're an existing V1 customer for CMS reporting, so CMS Cloud Management Service, it's important to call out that we have deprecated this reporting and we have moved over to Workspace ONE Intelligence. Okay, so if you haven't gone into the console lately or haven't done some reporting, this was deprecated 30 June of this year. You must migrate over to Workspace ONE Intelligence. As part of your licensing, you get a Workspace ONE Intelligence License Standard Edition for free. If you're starting out net new with V2, you don't have to worry about this migration. Good to go. And quickly, I want to talk about support, okay? So just like we would have with a UEM environment, perhaps you want to deploy a UAT here, right? There's nothing stopping you from doing that as far as a development environment that you would have with additional capacity. Spin up a tenant, and you can use that for life cycling of both checking those upgrade processes and doing testing as far as individual OS updates and whatnot. Another really important one here to call out as far as your support experience is HAR logs. HAR is an acronym, HTTP Access Request. Every one of the major browsers has this ability to capture HAR logs. If you see an error in the Horizon Cloud Control Plane console, one of the first things support will ask you to do is capture the HAR logs. This link here will take you to a knowledge base article that shows you, regardless of browser, how to capture those logs. If you include them with your support ticket to begin with, you're already ahead of the game, right? You're not in that back and forth between support. So capture the HAR logs if you see something that's in an error, all right? We also want to call out release notes between version 1 and version 2. If you do some Google searching there, sometimes you can get confused of where they're at. And then the service status page is somewhat confusing of where it's at because it's linked within our Workspace ONE status page. The link to where we're at as far as the Horizon Cloud Control Plane is linked here in this deck as well. So again, we covered that quick agenda. We talked about what HCOA resources are out there, how it fits in the Horizon Cloud product portfolio, some cloud considerations as far as cost, items to cover between V1 and V2, why you might want to do version 1 versus version 2, how you would migrate if you're a current existing customer, some reporting considerations, and some best support that it's out there. Want to call out the next session that's coming up. If you're interested in HCOA, a great tech deep dive up here at 10:15 with Rick Turlip and Graham Gordon, okay? One to definitely call out. And finally, I'll leave that QR code up there that links out to that blog post. If you didn't answer your question today, please reach out onto the artist that's formerly known as Twitter or the LinkedIn, my LinkedIn profile. Happy to answer questions that are out there. Thank you, folks. Appreciate the time this morning, and have a great, great Explore.
All right, hey, welcome to VMware Skyline, the Race to Zero. I'm Matt Putoff, I'm a Staff Technical Adoption Manager for VMware. Thank you for visiting us at Explore, and thank you to VBrownBag for having us here. So I'm going to take you through a quick introduction into Skyline, and then we're going to kind of jump in and say, hey, we installed it, we turned it on, now we got all this stuff. How do we start dealing with this stuff? So just before we start here, who has Skyline in their environment right now? Awesome. Who's using it every day? Awesome, okay, so maybe ahead of the curve here. So basically, race to zero, how the race begins, we'll get into kind of just the interface, and we'll jump down through some findings and what my experience in with my customers on how we kind of started tackling findings and getting it out of Skyline and kind of the next steps to get that finding number down to zero, right? So you guys are all familiar with the interface here. Actually probably has changed a little bit since this last snapshot, but we're going to focus on the findings panel here, right? How we go out, we have our different types of finding types, and then we choose troubleshooting. Generally, that's what I recommend customers to go to first, right? Go through your troubleshooting stuff that's gonna, hey, if it happens or if it might happen, that's the stuff that we want to avoid in terms of outages and stuff like that. And as you guys know, generally, when you go into the findings and you have your critical ones, and then you drill in, you can see your objects. You have that incident, and what's the leadership's the next question is after the problem is, so how big of a deal is this? What's the impact radius, right? So you can go right into Skyline, pull down that finding, provide that list, export it out in a nice CSV, and you can provide that to your leadership and/or problem management teams. With the troubleshooting ones, where do we start? Always look for the disk failure, full, down, lost, right? Look at those, see if those apply to you, and make sure those are the ones that you kind of want to address at a first to kind of close them out, because those are the ones that will cause the problems. And then what to look for after this, look for the VCF, right? Those are the former VVDs. Those are all your hardening configuration stuff, thresholds, versions, and then we move down into the life cycle and drivers and all that stuff from a configuration standpoint. Make sure those findings that have a high number of objects, those are always good ones to get taken care of, because obviously that's a large portion of your environment. And then I always like the risk if not taken once you dive into those findings. If it's just a cosmetic fix, if it's something that's functional or configuration. And then getting started, I always recommend people to go out here and check out the catalog, right? Subscribe to those Skyline release notes on a monthly basis, right? They always have the new findings that come out, the new hot KBs articles that GSS is putting in there, the new VMSAs. Sorry, can't say that this morning. Those are all good ones to know that they're in there, because you're going to get asked that question, right? The VMSA comes out, security team comes out, says, hey, VMware just put this out. How does that affect us? I don't know, give me 30 seconds and I'll let you know, right? So you could provide those lists out there too. Helps you with the upgrades, right? Hey, I want to upgrade my vCenter. Again, you can probably see how dated the 6.7 vCenter here is. Where are my incompatibilities? Oh yeah, we still have that NSXT or V environment that's still out there. Yeah, that might be a problem. So it kind of provides that pathway, and you can use this to build your proactive SRs, and put out those plans to GSS, and they can approve that for you. And then to quickly run through this, right? This is how we keep on running the race. I always say, don't be afraid to jump in there. You can hide findings, but make sure you always go back to them, right? Keep your focus into a particular environment. Don't try to tackle and boil the ocean all at once. I'm sure some of you have very large environments where you get into remediation of thousands of hosts as compared to multiple clusters or anything like that. Know your environment, know what's important and what's not, because there's a lot of findings in here that some of you guys will look at and say, okay, that really doesn't apply to me. I'm not worried about that. That's some other group's problem. And hide those, but make sure you always go back to them, because you never know when those will come back and kind of nip you in the butt. And then my favorite saying, to be good at lifecycle management, you need to actually do lifecycle management, right? Start small and work out from there. And then kind of your next steps is you bring your Skyline into your operations tools through ARIA operations. And if you haven't looked, the product team has put out a whole Skyline Insights where you can leverage APIs to pull the findings information out into all kinds of different tools. So you can find a lot of those tools here. The QR code will bring you out to a GitHub README file that has all the how to get started, the API tools, a bunch of links out there. So check those out. And then as part of the ARIA group here, if you click the code, fill out the survey, you can get some ARIA swag there as well. What's that? Yep. Shoot.
Is it offered as an on-prem offering?
Yes. Okay. Oh no. Yeah. I'll get to you here in a second. So I'm going to go off stage here, and we have Sunny from the product team over here. We can answer some questions that you guys have.
Hey, welcome to my session. I'm Caio Oliveira, Principal Multi-Cloud Architect. I'm part of the VMware Multi-Cloud Architecture and Strategy team. Normally, what I do on my day-to-day is help customers going towards the multi-cloud path. So I help them with the architecture, pretty much. So here, talking today about Azure VMware solution, right? So it will be some slides, so I will try to get as much as I can, right? There's a lot of information. So Azure VMware solution, for people that don't know, is a partnership between VMware and Microsoft, and we try to bring the best of both worlds, right? So we run our infrastructure, so our well-known SDDC on top of Azure infrastructure, right? So you have zero refactoring when you're migrating your workloads or running your workloads to the cloud, right? So you can use the same skills that your teams, as partners, as customers, are used to do in their data center. And of course, you get all the cloud economics, all the benefits with lower TCO comparing to the traditional on-prem data centers, right? So, good thing as well. So there's some commercial models. Azure VMware solution is part of a VMware Cloud Universal, right? The idea here is not to explore that, but pretty much is a way for you to use the credits all over our offerings. What is that? I think the same thing that you have today in your data center. So you have vSphere, you can have NSX, you can have other products. Now you have the SDDC on top of Azure infrastructure, right? On top of Azure infrastructure, you're going to have the same components and our loved vCenter on top of it. The benefits as well, you're going to have access to all the Azure services. So all workloads that will be on top of AVS, Azure VMware solution, can rely or can use those applications as well, right? Pretty much as all the other offerings that we have, AVS, the main use cases are application modernization. The main one for us, we tend see around 60 to 70% of the time as the primary use case, is cloud migrations, right? So when you have a way to migrate from your traditional data center, or you're expanding your data center as well. So data center extension is also a big case. VDI, right? So running VDIs on AVS is also a big use case, and disaster recovery as well. So going more technically to talk about AVS, right? So AVS is pretty much available in the majority of the Azure regions, so all across the globe. So 29 regions plus GovCloud. So we have AVS available. As well, a lot of certifications here, ISO, HITRUST, CSA. So everything is there. And for you to get known to the current certifications, there are some links in the deck that you can use. At the moment, AVS has 3 different host types, right? So all those 3 host types differ in CPUs, in memory, as well in storage, right? Networking is pretty much the same. We have 2 dual 25 gig ports, right? Here will depend on the workloads and also the scalability that you need for your environment. Of course, there are different price costs here, and also the price differ region from region. What's good as well, we have vCenter Strategic Cluster for AVS, so you can have 2 sites, and the witness node will be in a different AZ. So you have 3 different AZs. So if you lose an AZ, the other AZ we use. This is actually really good for special mission critical applications that you need to rely on a structure like that. Those are the current products and their license. So for AVS, we have vSphere 7 Update 3, right? vCenter Standard, vSphere Enterprise Plus, and vSun Enterprise. For NSX, we run on AVS currently the NSX 3.2.2 Advanced, and you have as add-on included the HCS Enterprise, and you can have as well as an add-on the SRM 853, 8503, right? everything on that. So all the platforms updated. You have a link here that you can look at better, right? Here is really interesting, right? So how you connect your AVS using Azure terminologies. Azure call it private cloud. So when I talk about AVS private cloud or SDDC, it's pretty much the same thing, right? So here you have the ability to what? Connect your AVS NSXT network segments where all the workloads will land. You have a way to connect to Azure infrastructure, and of course, with that and relying or even internet via VPN or using Azure direct connectivity, that's called Express Route. You have a way to also connect to your data center. Here, you create what they call Express Route using the global reach. So the router that is backing AVS will connect to the router on Azure that will allow you to connect to or Azure native networks or your data center as well, right? One important thing, HCX Enterprise is included in the AVS subscription, right? So people don't know, HCX is the migration tool that we have, really reliable, really easy for you to migrate your workloads to the cloud, right? Here, there are some different features and components. So if you have only the advanced license, you're gonna have pretty much like, you can migrate as a bulk, or live migration. Live migration or vMotion, you do one by one, right? When you go bulk migration, you can do more in parallel, but you need to shut down and power up the VMs when they do the migration, right? In the enterprise, you have the combination of both, right? So is what we call replication-assisted vMotion, which is a good tool as well. And there are other interesting things, especially if you are looking for migrating more stuff and you have mobility group, traffic engineer, that you're gonna leverage the HCX Enterprise version. There's a ton of information on how to migrate to HCX, so guides as well. There's also a HCX best practice, multi-cloud best practice guide. A little bit biased here because I wrote it together with the BU, but there's a lot of information there, especially if you are looking for cloud-to-cloud migrations and not only on-prem to cloud migrations, right? Regarding ARIA products, which are the ones that are supported with AVS, we have operations, so operations cloud or even like operations that you can leverage installing on-prem, starting on the version 826. Operations for logs, operation for networks, and automation, all are supported versions on AVS. So if you have, for example, your ARIA automation, so you have your templates, you're running in your on-prem. If you want to deploy then on AVS, it's supported and something that our customers are using. I mentioned one of the big use cases that we have currently is running VDI on top of AVS, right? You have actually two options, right? You have what we call Horizon on AVS, which only the SDDC portion will be managed by AWS. You have to run all the Horizon infrastructure, right? So everything related to installation, upgrading, everything will be on you. But if you want a more SaaS model, a DaaS model, what we call, that we're gonna leverage, that we're gonna use on top of native Azure, but we're gonna run the Horizon Cloud. So you're gonna be only creating the VDI, so you don't need to think about like upgrading the Horizon Cloud. Different models here, but the idea is pretty much the same. Talking about that, always when you go to the cloud, you have the shared responsibility matrix, right? When there are different parts of the environment that will be your responsibility or Microsoft's responsibility. Here is really important. All the support, sales, and operation will be run by Microsoft. If something needs to VMware to be engaged, Microsoft will directly engage with us, right? So here's pretty much all regarding physical infrastructure, security, hardware failures, the installation of all the components, NSX, vCenter, HCX. Those will be Microsoft's responsibility, right? Your responsibility will be what you normally do. You create the VMs, you install the applications, you secure them, you create the firewall rules, right? You install the guest OS, you protect the guest OS, install any third-party solutions. Those will be the responsibilities, right? And, wow, I concluded well in time. So this here, you have a lot of information in not only our TechZone page, but also Microsoft page. There are a lot of white papers, a lot of guides that you can leverage to install AVS. I will be here if someone have more questions, and appreciate and thank you for joining my session.
Good afternoon, folks. My name is Mike Nelson. I'm going to be talking a little bit about bringing vCenter into Azure Arc with PowerShell and PowerCLI. So to kick off, we're going to say I talked to ChatGPT, of course, like you're supposed to nowadays, and said, why would I want to do this? Why would I want to host my vCenter, you know, in Microsoft Arc, in Azure Arc? Well, it came back with all this stuff. And I'm not really interested in all this stuff because it's just the stuff that, you know, people write in books and it doesn't make sense. So I asked the original OG GPT. And my deck just went crazy. I asked the original, there he is. Not sure what happened there. Hey, whoa, whoa.
Whoa!
I reclaimed my time. No. That's crazy.
Something is driving the keyboard crazy here.
You want this? Is it this?
It's that.
Okay. Talking to the original OG GPT, and oh, here we go. So now I got to back up over all this. And pretty much they just came back and said, hey, why would you want to do this? Because we want everything inside of Azure. And VMware and Microsoft are best friends now. So you want to put it up there, right? This is what we're really looking at when you talk about putting vCenter inside of Azure Arc. You're looking at first down here at the management endpoint, your VMs, okay, your vCenter server, resource pools, all that kind of fun stuff. Coming over here into the Kubernetes cluster, because that's what you're actually putting that vCenter into is a cluster. And that uses something called a resource bridge. Resource bridge is like a gateway. Think of it as gateway. It's required in order to have that functionality. Now, down here, you're actually getting down to the point where, you know, it's going to be inside of Arc. That means it's going to be manageable inside of Azure and inside of Arc. So you can manage the vCenter and you can manage the VMs that the vCenter has. Okay? So there are some requirements here. You take a look at the requirements. There's a couple that I really want to point out. The first one is that you need a bunch of IPv4 addresses. All right? Now, that's going to be mainly the DHCP range. That's going to be on your on-prem, all right? Because you have to have that on-prem range in order for the resource bridge to work up into Arc. Cluster resource pool. I'm not exactly sure why they give you this requirement of 16 gig and 4 vCPUs, because there's no such thing as a vCPU for the bridge. I don't quite get that, but you need a cluster pool. I've done it with 8 gig, okay, and 2 vCPU. It's not a big deal. Azure, you need a subscription, and you need to make sure you have the AVS preview enabled. Along with read, all inventory, deploy, update VM and permissions. Of course, for the demonstration, I used someone who had all the permissions. So these are the features that are registrations that are required for your Azure subscription. So you need to go through and you need to actually enter these, okay? You have the ability to do it through the UI. You can go into the Azure Active Directory, you can go into preview and you can select these, but it's just easy to run it from the command line. So you're gonna run these commands. You're also gonna do these because you have to wait until they actually all are enabled, and then you can actually take a look and make sure you have Azure Arc for AVS enabled. It's actually there. Once that's done, then you can actually build the resource bridge. Okay, this is really kind of important. You have to do this. So this is a demonstration. I'm going to walk through the demonstration here. I'm looking at my AZ version. And when I look at the AZ version, I want to make sure I'm at the right version, the latest. I'm going to look at all my accounts. You want to make sure you're in the right Azure account before you do this. So I'm picking an Azure account that I am in. And basically what I'm going to do is I'm going to run this PowerShell script. Now, I'm going to open up the PowerShell script. You can see this script is created by Azure for you. You input a bunch of parameters. It will create this entire script for you, okay, to create the bridge. As you can see, it's going through and it creates the resource groups, names everything for you, takes care of all that. So here I go. I'm going to actually run this script. It's a long script. It takes a while to run. So I sped it up a little bit. As you can see, it starts to ask questions right away. Are you behind a proxy? Okay. Then it starts getting into, I want you to notice, it has to use 64-bit Python on whatever you're using to set this up. Just so you know, if it's not there, it's going to install it. Same thing with Azure CLI. You have to make sure you have Azure CLI. If you don't have it, the script's going to install it for you. From there, okay, it's actually going to go. You can see I actually, sped this up. It's going to start cycling here in a second and going through everything that it's going to build. Eventually, it's going to get to a point where it'll start asking you questions again, specifically around what is the IP or FQDN of your vCenter, okay, how to credentials to access it, and what are the IPs that you're going to give it. As you can see here, you need to confirm the login to Azure CLI, so Azure CLI can connect to your subscription up in Azure. I've already done this, so I'm going to hit no here. Eventually, it's going to say N. There we go. And now it's going to go through, and it's going to start setting everything up. And it'll go through, and it'll explain everything that it's doing. Now, of course, this is sped up, but you're going to be able to see this, and you're going to be able to take this as a record of what was created if you need that from a governance and security standpoint. Here, it's actually asking for the vCenter FQDN and the username. Once I input that, it's going to ask for the password. And from there, it's going to start looking at your actual inventory. Okay, where in the data center? What is the VM network that we need to be connected to? Then it's going to start asking for the appliance, the DHCP, and the static IPs. This is all running through the script. This is all happening via PowerShell and PowerCLI. Once this is all done, it gets to the actual IP information that's put in. The bridge, okay, this is the DNS resolution for the bridge. The bridge has to be able to resolve the vCenter, okay? It has to be resolvable by Azure. Azure has to know how to resolve to the bridge. That's why you're going to have some kind of DNS entry or host entry or something to identify that bridge. This is where you actually start to give it the IP addresses for the actual VM that's going to be running the bridge itself. And then it's going to ask you what resource pool. You created that resource pool in vCenter. It's reading it and saying what resource pool do you want to put it in, and then the data store, and then the actual folder. You have to have it inside of a folder as well as part of the requirements. I just picked the Discovered Virtual Machines folder. And then you give it the actual configuration for the appliance cluster. This is all spelled out in the documentation. I mean, it's very simple to follow. They actually walk you through it step by step. And here we go. It's actually going to build it. So you can see it's going through and building everything. It's actually building the VM for the appliance. It's putting it up in Arc and putting inside the cluster inside of vCenter so it can talk. And once the bridge is up and running, it's installing the cluster extension for Kubernetes. And then from there, I probably should have sped this up a little more. But from there, once it gets actually to the cluster extension, it should get ready to actually, there we go. It's going to give you everything in JSON format, how it actually worked out with the how the extension was installed. Good for record. Same thing there. All of this is recordable. vCenter FQDN or IP, it's asking for it a second time. Because why? Because it spun it up, the resource bridge up, and it has to reconnect. Okay, it doesn't cache that security information. It doesn't cache the username and password. Once we get the password in here, and gotta confirm it, and then confirm the details. So this is actually just going to go through and it's going to confirm. It's going to take the script and say, make sure everything was set up the way it was supposed to. It's going to show you that everything was set up the way it was supposed to. And then once it's actually up and running, come on. Here we go. So continue onboarding to complete the ARC. You have to enable your resources, view your vCenter resources in the Azure portal. This is where we would actually hop over to the portal and actually be able to see the inside of here. Okay. We go into servers, Azure Arc. Under Arc servers, we actually have an option for VMware vCenters. And there's our Arc vServer that we just built. Inside of here, you can see everything pretty much that you can see inside of vCenter with limitations. I mean, you can see the virtual machines, resource pools, networks, data stores, so on and so forth. Now I'm connecting to the actual vCenter. There we go. Ooh, down to the wire. Come on. You get to the password in. Come on, here we go. Once we log into the vCenter, you're actually going to be able to see the appliance and be able to control it from there. So inside of DC, once you're in there, in cluster 1, I think I have it, you actually have the AZ Arc pool. That's the actual pool for it, and the appliance is inside of that pool. It's going to launch a remote console, and you'll be able to see everything that you can do with the remote console. But currently, I am out of time, I believe. How much time have I got? Okay. Yeah, okay. I didn't get the chicken, so I wasn't sure. Yeah, so you actually see in here that inside you'll be able to check everything out from a Azure Arc standpoint. You can actually see the Kubernetes, how the Kubernetes probes are started, the servers are started, all that kind of fun stuff. So if you have any questions about this, I'll be around. I've got a couple more sessions here today, and feel free to stop up and ask. Thank you very much.
Welcome everyone, and thank you for joining my session on building a multi-cloud with Cloud Director Service. So I'm just curious of a show of hands. I know we don't have a ton of people in yet, but is anyone using Cloud Director today or Cloud Director Service? All right, good. I see a lot of hands. Thank you. My name is Joseph Polkar. I'm a staff multi-cloud solutions architect. I'm on the multi-cloud strategy and architecture team. I'm specifically on the architecture side, so we deal a lot with customers and partners, and in particular with Cloud Director Service. That's my background, is really with Cloud Director. Previously I worked with defense contracts and different service providers, so that's my background really in Cloud Director. All right, so the very first step to building a multi-cloud is the VMware software-defined data center. So most of you are probably familiar with this. We've partnered with a lot of the hyperscalers to deploy our solution on the hyperscalers. So this is taking the software you already know, vSphere, NSX, vSAN, and it's putting that on a hyperscaler so you can take advantage of all of the benefits of running on a hyperscaler. Of course, they have global infrastructure, so the benefits are pretty obvious there, but you also get direct access to a lot of the native services. So if you're just running a VMware cloud on AWS, for example, you'd get access to AWS services directly. And this is really the foundation or the building block to running Cloud Director Service, and this is part of the reason why Cloud Director Service came out, is because the original version of Cloud Director that you would run on-prem is really only intended to manage on-prem infrastructure. So this is solving that. All right, so we have Cloud Director Service. So what is Cloud Director Service? It's just a SaaS version of Cloud Director. So if you're running Cloud Director on-prem and you log into Cloud Director Service, you would have no idea that you're logged into CDS, as we refer to it as, versus an on-prem Cloud Director. It looks pretty much the exact same, but it allows partners to basically grow in an asset-light model. Right? You don't have to have all that infrastructure on-prem if you don't want to go with that, but you still have the option of running on-prem. So you can have endpoints on-prem or in the cloud with Cloud Director Service. Now there's really two use cases to using Cloud Director Service. The first of which would be for a provider or an MSP. And this is probably the most common use case because most of the time providers were the ones using the original Cloud Director under the VCPP program, or now CSP program. So that's kind of the overview of the provider realm. Then there's also the enterprise realm, right? So traditionally, enterprises would run just a single data center, right? So you'd have vSphere installed and whatnot. But in certain circumstances with VMware Cloud on AWS or Azure VMware Solution, maybe it doesn't make sense to have a whole SDDC deployed just for a single tenant. So that's where Cloud Director Service comes in. An enterprise can carve up resources from a single SDDC or potentially multiple SDDCs, and you get more efficient use of your resources. And of course, there's a lower cost for each business unit. So there's the enterprise use case and the service provider use case. Now, one of the key differences also is what's available to a service provider or MSP. Today, we support VMC is supported for service providers, as well as Oracle as of Friday, I learned. Traditionally, or originally, that was only available for enterprise customers. AVS currently is only supported for enterprise customers as it stands. So that's kind of the overview. And then Google Cloud is the other one. Google Cloud VMware Engine is also supported for both enterprise and service providers. All right, so the difference with Cloud Director Service as opposed to running on-prem is they've kind of redesigned it to run in a Kubernetes cluster. It now runs in a multi-zone Kubernetes cluster, and the storage is actually backed by S3. So the physical location of where it's running is in AWS, but it's a VMware managed service. It's a SaaS service that you can basically deploy instances of within about 15 minutes. So it really doesn't take long to deploy. And for anyone that's managed Cloud Director on-prem, you know it can be kind of a hassle to deploy. You know, you've got your 3 nodes that make up the Cloud Director the Cloud Director on-prem. A lot of times there's challenges with like managing the database, things like that. If you run into any issues, I see someone laughing here. So you don't have to deal with any of that with Cloud Director Service. It's managed for you. If you have an issue, you just open up a ticket with VMware and they'll get it resolved for you. So it takes a lot of that burden off and you get just basically to use the service and service your tenants. All right, so let's take a look at the endpoints. I know I've already called out some of these, but we have VMware Cloud on AWS, Azure VMware Solution, Google Cloud VMware Engine, Oracle Cloud VMware Solution, and of course on-prem. So you have that option of connecting an on-prem data center as well. All of these can be connected to a single pane of glass, right? So this is a single instance of Cloud Director Service managing all of these SDDCs. And you can see the benefits of that. You're not having to log into every different portal to manage the different resources. This is made possible through an SSL reverse proxy. This proxy is generated in the VMware Cloud Services console, so where you would manage your Cloud Director Service instance, which I'll hopefully show you a demo of here in a bit. And you would generate an OVA, deploy that in the data center, and that establishes connectivity. All you need is outbound connectivity to like 3 or 4 URLs, and that's it. It establishes that connection for you. You can also pair other Cloud Director instances. If you already had an on-prem instance, you can pair that with a Cloud Director service, or perhaps multiple Cloud Director service instances. You can pair those using multi-site pairing. So this makes it so that your provider admins can log into one place to manage all of those resources, and the tenants get to reap those benefits and determine where their workloads live. All right, so let's take a look at just kind of an overview of Cloud Director Service. Of course, you're starting with the infrastructure, all of your SDDCs at the bottom here. Those are carved up into pools called provider VDCs. So provider VDCs don't span more than one vCenter. So you would typically have at least one provider VDC per vCenter. You could also split it up into different tiers of resources or different compute types. Like in this example, I have like bronze, silver, gold. You know, you could do that as well, but you'd need at least one provider VDC per SDDC. And then on top of that, you can carve out tenant pools, which are the org VDCs. So if you're familiar with Cloud Director, it's the very same thing that you know, traditional Cloud Director offers. All right, and then of course at the very top we have organization. So this is the unit that has the user accounts. This is what tenants are going to log into. They get their own portal, the tenant portal, and they can manage all of the resources from that organization. All right, so availability in regions. Right now, there's a number of regions. The key point to remember is just making sure that your SDDC is within 150 milliseconds. That's the requirement on-prem for Cloud Director, and the same thing applies for CDS. Your SDDC needs to have that low latency. If you get over 150 milliseconds, so for example, if I deploy an instance in the US and I'm trying to connect an SDDC that's in South America, that latency may be too much. We have tried some overseas and it'll work, but you get to the point where vCenter will start disconnecting and things like that. So just be mindful of the latency. All right, and there are a number of integrations: vCDA, Object Storage Extension, Container Service Extension, and VMware Data Solutions. App Launchpad, really this is now being replaced by, I believe, the Content Hub. So this is going to change a little bit, but all of these extensions also work with Cloud Director Service. All right, I do have a demo. I don't know if we'll make it through all the way. I'm running low on time, but we'll start it. So we're logged into the the VMware Cloud Services console. We're going to launch the Cloud Director Service instance here, or open up the portal for it. And we have one instance deployed here. You get kind of an overview. If you had multiple instances, obviously we'd have multiple boxes here for that. I'm just going to go through what it looks like to create an instance. It's super easy. You just put in a name, you select your region, and then it's going to give you an option of what versions are available. Typically there's the latest version available. In this case we've got 10.5. as of the recording, and then the previous version of 10.4. So you have that ability to select your version. And then sometimes there's like a standard and early access. Of course, I would typically go with standard if this is going to be a production environment. Now, if we go over to integrations, we can see the cloud proxies that we've deployed. You can also integrate with Log Insight. And then if we head over to subscriptions, this is where you could create a 1 or a 3-year subscription, for example, or you could use it on demand. That's where you could create that subscription. And then an activity log across all of your instances. So if you have multiple CDS instances, you can select the region and see the activity log here. Now I'm going to go back to the Cloud Director Service page, and I'm going to look at the details of this. So this is actually going to open up kind of a dashboard. This gives you an overview of the metrics. So of course, if you had multiple SDDCs connected, you would get all those resources showing up here. In this case, we have 5 SDDCs connected, as you could see. There's a support tab. You'll want this if you are opening up tickets, logs, and then maintenance is pretty cool. You can actually schedule when your maintenance is going to occur, so you have some control over that. That way, your instance isn't just being upgraded at random times. So you can see, select the maintenance window there. And then add-ons, right now I believe there's only just the auto scale, but as additional add-ons get added, this is kind of where you go to enable those. So looking at the actions on what we can perform here, I want to call out first the associate a VMC SDDC. This process is a little more streamlined because it's VMware Cloud on AWS. And then there's the ability to generate an OVA. This would be for every other SDDC or on-prem. That's that proxy that you're deploying, right? You would deploy that. After you deploy the proxy, you would associate it using that associate data center option there. So now I believe we're just going to open up this instance. All right, I'm being told I've got 1 minute left, so we'll see what we can get to. Hopefully it can at least show you the vCenters that are connected. So we're logging into Cloud Director. This is using single sign-on with the Cloud Services console. And I'm just going to show you the infrastructure and the vCenters that are connected here. And this is the really cool part where you can actually see we have SDDCs connected from Google, Azure, and Oracle, I believe, and we've got 2 VMC SDDCs. So I'm going to zoom in here in just a second and show that. So this is what it would look like to manage all of those. And then from that point, everything with Cloud Director is going to be the same as you'd expect with on-prem. So I'm going to go ahead and stop the slide there. If you're interested in testing this out, there's actually a free trial that you can do. So that link right there is to the free trial. Anyone can do that. Just click on that, fill out a form, and test it out. If you have any questions, I'll stick around after the session, but thank you for your time.
All right, well, good morning, everyone. Thanks for joining. This is probably the most interestingly named session in the catalog because we're actually, well, it's Minecraft, right? Who would have thought you'd come to VMware Explore and it's like, oh, there's a session about Minecraft. Well, it's kind of about Minecraft, but not quite, and I'll tell you why in a second. So first, I just want to introduce myself. My name's Sean Massey. I'm a staff multi-cloud architect in the VMware multi-cloud strategy and architecture team. Normally, I work kind of in that space between our multi-cloud solutions and our end-user computing solutions. VCDX and contact information down there in the bottom. So I'm going to start with the question, right? Like, why do we build VM templates, right? As a sysadmin or a VI admin, right? Why do we use that feature where we can go into vCenter and right-click and go deploy from template? So there's a couple of reasons for this, right? We want to speed up our deployments, right? We want to provide a level of consistency, and we don't want to sit there or have our sysadmins sit there all the time with a Windows ISO or a Linux ISO manually installing it, which then ends up with us not getting the first two benefits. Because doing anything manually is slow and it's error prone, and you don't get the same results one time after another. And in a lot of organizations I've worked with, a lot of organizations I've worked for or with, they've built templates by hand. So the problem with this is that when you build them by hand, you're not maintaining them on a regular basis, right? Because you built it once. You don't want to have to open it up again. You don't want to have to manually install Windows updates. And over time, you get problems with drift, right? What you get in the template is not what your standard should be. You may have, well, it might be a little bit better now that Microsoft has gone down to like one patch per month. That's just like this giant blob. But it still takes forever to download and install, even if you have like a WSUS server. And then if you start deploying additional third-party components, they might not be there because you don't update your templates for them. So you get this consistency problem over time. Now, if we think about the public cloud, this isn't the experience we get. When you go into Amazon or into Azure or whatnot, there's a catalog for you. You could just pick the image you want. Even our VMware Cloud Provider Program partners who are using CDS and VCD have these catalogs of things that you can just select and deploy. Now, the thing about these is these are built or rebuilt on a regular basis, in some cases daily. And if you look at the Azure catalog or the AWS catalog, some of them may have frameworks installed with them, right? They may have .NET or SQL Server or other components that you might use. Now, these might not fit your enterprise environment, or they might not have everything your enterprise needs, but you can create your own templates from them as well and add your own stuff to them. And in the end, all your application or sysadmins need to do is push a button, and they're 90% of the way to where they need to be. So I can hear it already, right? What does this have to do with Minecraft, right? How do I tie this back to that? So there's three things about Minecraft that kind of make it like an enterprise application. Now, first off, it has an SLA, and for anyone who has kids, when your Minecraft isn't working, you hear about it, and you hear about it quickly. I've had times where I've had calls and I'm halfway across the country going, you need to fix this now. The kids are driving me nuts. Second, it requires some arcane knowledge to actually get it up and running and configured. Some things are in some text-based config files, some things are done through a remote console, and some things are configured in JSON, right? It's like who was developing that feature that day and what they liked, and that's how it ended up in it. And I know more than a few enterprise applications that are that way. And finally, it requires Java. Like every other big enterprise app, Java is a dependency. Now, I know some people are like, well, what about Bedrock? But if you're using something that's not Windows-based, you probably need Java Edition, so you need Java. And unfortunately, yeah. So this kind of became a project for me because in my home lab, right, there's a bunch of things I want to do, and in the end, it really became a dumping ground for Minecraft servers for my kids. And like, my kids are obsessed with Minecraft. It's like the one game they play all the time. And when they got into this during COVID as a way to kill time, I decided that I wanted to build servers for them because they were using some older machines that, you know, could die any day. I didn't want to have to deal with backing up their worlds and migrating it to a new machine if they had problems. So putting it on a dedicated VM was a great way to maintain that. It also means if they don't do their chores or listen or you know, the things that we ask, it's very easy to take it away. And in theory, it allows my kids to cooperatively play, but you probably already know how that goes. But the problem with having servers is that they can be a pain to maintain, right? Because now I'm introducing an enterprise problem into my home network, and in some cases, I'm turning myself into a cloud provider. Because I was being asked to build a lot of Minecraft servers. They'd see a YouTube video and go, oh, we want to try that world seed, or we want to do this thing that they're doing and whatnot. So it became kind of a chore. So I decided I wanted a way to automate this and, in theory, make it a little bit more self-service, right? I didn't want to be doing this by hand every time they were asking for something. And I wanted kind of a cloud-like experience where I can just go in there and deploy it and, you know, not have to touch a CLI to configure things. But I also wanted this to be self-maintaining, right? There are a lot of Minecraft updates. There's like multiple patches per year. There's multiple releases per year. There's Linux updates. God knows there's a ton of Java updates. Right, so I didn't want to have to be touching that and maintaining that for every new server. Now, there are other ways to do this, right? There's a Docker container, there's Kubernetes. I really wasn't ready for that in 2020. I didn't want to learn that at the time. And there were other orchestration tools I could have used, but again, there was a time thing. I didn't want to learn it, right? I admit I was being lazy in one sense and not lazy in another. The eventual goal was to give my kids something that they could go in theory, to vCenter and just deploy with no additional orchestration, no additional config management tools. But there's an additional challenge here. The Minecraft EULA actually says I can't redistribute it. So I have to somehow bake that into this, whatever I do, where it would download it automatically. Well, that was great in theory. But I'm not going to give a 13-year-old access to vCenter to deploy things. So I just really wanted to make this easier for myself. Now, maybe someday I'll have Cloud Director in my home lab, and then I'll let them do it. But that's not anywhere near happening right now. So I went through and I started this whole project, and I was able to get to an end result. And I'm going to talk a little bit about what I learned first before I actually show you kind of what the outcome was. Now, when coming up with an automation project for building templates, the right tooling is essential. There's a lot of options out there. There's a lot of different ways to script things. There's a lot of, if you're working with Microsoft products, there's things like MDT. But I chose Packer. HashiCorp's Packer tool. No. Being from Wisconsin, I have to call out, I did not pick this Packer. Sit down, Mike. But I picked Packer because, in the end, it's multi-platform, right? I can run the tool on Linux or Windows or Mac. I can support multiple cloud endpoints. So whatever I wanted to do, the tool was flexible enough to do it and test from both my dev environment and in some sort of semi-production environment. And it's multiple OS. So I could work with Windows, I could work with Linux, right? I'm an EUC guy by trade, so every second Tuesday of the month, there's a good chance I might want to do something like this for my Windows templates as well. It's all text-based, right? Originally JSON, now there's a domain-specific language that gets used for the config files. And because it's all text-based, it works really well with source control. That also means there's a lot of examples out there, but this is kind of a double-edged sword, and this is something I struggled with, and I'll come back to that point in a little bit. What's also nice about Packer is it lets me orchestrate everything in one tool, right? I don't need to tie together multiple tools to build this workflow to get my end result. I do it all in one. So my VM hardware configs, my OS install, I can create in-guest scripts to install my applications and do my configurations. I can even do things post-provisioning. So I can create my OVA file, inject all my properties, and I can do all this and use variables to create multiple builds and multiple deployment models. So I ended up using Packer for everything. Linux, anything I do Linux-based, I end up building a Packer template for. Windows Server and Windows Desktop. So I'm going to talk about how I actually use this for Minecraft in particular, because I put Minecraft in the name, I might as well focus on that. So one of my colleagues, Timo Sigliani, has a GitHub repo that he published that has Debian templates. And I started with Debian. Well, I didn't start with Debian. I moved to Debian, partially because Timo had done the hard work, right? I'm building on the shoulders of others here. That will handle the base Debian install. And I apologize, I did not include a link to that repo in here or a QR code to that, but I will get that published out on LinkedIn and elsewhere. Once I have Debian installed, I have scripts that will go through, configure Debian for the way I want it, and install all my prerequisites. So I need some PowerShell for this. I need Java for this. I need to set up all my folder structures and permissions and stage the things I need to do so when I power it on for the first time, it's all there and runs. And then if I have scheduled tasks or cron jobs that I want to run, I want to get those set up as well. So things like nightly update checks and things like that. So these become real self-maintaining appliances. All get set up in this Packer job. Then I export it to OVF. And in a post-processor step, I create an OVA file and I inject all my OVF properties. Now, over time, I was able to build this into a Jenkins pipeline, so now it just really becomes a one-button push operation that takes about 45 minutes to complete. So I mentioned Debian wasn't the first place I started. I did actually start this using Photon, but over time, Java dependencies became an issue, right? I mean, who hasn't heard Java dependencies as an issue for enterprise apps before, right? Unheard of, never, right? So what did I learn with Packer? So what's really nice is because I had base templates to start with and I was able to modify what somebody else worked with, I was able to easily take those and turn them into, well, not easily, but extending them into customized application templates was less of a challenge because I already had a base OS that worked. All I was doing was extending it. The second thing that I learned is I was only limited really by two things: what I couldn't script and what the lawyers told me I couldn't do. And then the Packer post-processor is such an amazing tool because it gives you a lot of flexibility. I was able to, go beyond just adding OVA files to my post-process, or turning it into an OVA file and adding the properties as a post-processor step to actually uploading it to a content library. So it really became a hands-off workflow by using that post-processor and learning how to have it execute scripts against various endpoints, right? So it's really an all-in-one orchestration tool. Now, I mentioned earlier the examples and samples aren't very approachable, and they were kind of a double-edged sword, right? Because there's a lot of them out there, but they were hard to consume. The reason for this is because the the samples that are out there, especially the newer ones that focus on the HashiCorp HCL language that they use now, are entirely variable driven, right? You will pull up some of these in GitHub and you're really not seeing what it's doing because it's just references to variables that are in other files. Now, this isn't necessarily a bad thing. It gives you a lot of flexibility, but it's really intimidating to learn. And there aren't a lot of good examples that show, oh, here's how I start by hard coding things in and then extend it to different variable files. So I struggled a lot with that early on, especially when I started converting my older templates to the newer format and getting things entered correctly. So when you start working with Packer, you really need to experiment. You need to take your time and start by hard coding things and then moving things out into different variable files. Because there's a lot you can do there. There's a lot of flexibility you can gain, but it's a struggle. Now, the next thing is OVF properties are absolutely amazing. So the QR code here goes to a blog post by William Lamb. He has a lot of content on using Packer to build OVF templates and OVA templates and using them for virtual appliances. This is just one of his posts on it. He's got links in there to a whole series of things that walk through how to use Packer to install Photon, how to create your OVF application properties, how to inject them, etc. So OVF properties, they're key value pairs that are defined outside of the VM. They're defined during deployment time, but they're accessible inside the VM using VMware tools. So VMware tools can run a command and it can retrieve all these values that you can then process to configure anything in the system, really. Now, typically, these are used for things like your passwords, right? Your root password, your sysadmin password, your SSH keys, networking details. But they can also be extended to focus on application properties. I'm going to show you an example of that here. So when you define your OVF properties and to inject into an OVA file, it's an XML file. And we can create multiple properties. We can group properties into specific menu areas and define what they are. We say what type it is, whether, is it Boolean, is it string, is it a number? And we can say whether or not there is a default value to it. So we can do this for anything that we want to configure in our appliance, in our application. So coming back to the topic of Minecraft, how do I use this? So I have my OVF properties. It defines everything I want to configure. Now, when I start up the VM for the first time, it's going to install Minecraft automatically based on the version I define. It's going to pull it down, get everything configured. Then I'm going to pull in all my OVF properties that I want to configure. It's going to store them in variables on the machine. And then for each item, I'm basically going to iterate through it. And for this one, all I'm basically doing is using the sed command to do a find replace inside the properties or the files that I want to update. But the really nice thing is this can be updated and configured for anything you want to do. If you have applications, for instance, that you're frequently deploying and maintaining, you could do something like this. You could build a virtual appliance that configures those applications. Now, I apologize, this is very much an eye chart, so for those of you in the back, I hope you brought your opera glasses. But this is just kind of showing, right? The first is how I retrieve those variables. I'm using the VMware tools command to get to get all my guest info, and then grep for a certain thing, and storing it as a variable. The second side is showing how I'm using sed to find that item in my server properties file and change it based on what that variable is. So what this gets me is a fully configured Minecraft server before my kids even realize it's deployed, right? Without having to touch anything or go into a file or touch a command line. Now, when you set those OVF properties, you can also view these in vCenter. Under the configuration tab, there's a vApp options. It's all the way at the bottom of that menu, and you can see all of those properties from vCenter and what you configured them as. So how do you make this your own, right? Well, first thing, right, like anything we do in IT that we want to automate, we have to think about our desired outcome, right? My desired outcome was to be lazy and give my kids something at the same time, right? For an enterprise environment, it might be making things easier for developers or templatizing things that you're doing in your environment or trying to become an internal cloud provider. Then you got to think about your workflow and document it, right? Any automation project starts with documentation. You have to know what you're going to do and have that down on paper so you can script it. And then you need to script, and as I was doing this, test frequently, and then test again, and then wait till it breaks and test again. Now, I realize some of this talked about some things that I have coded. I do not have a public GitHub repo for this, unfortunately. There will be one, but I have to burn it down and start over because at some point in the history of this project, I had credentials in some of the files that have now since been pulled out and moved into variables and aren't stored there. But unfortunately, it's in the history, so yeah, that would be a bad thing, right? So there will be a public GitHub repo coming for this, and it will be up on my blog at some point in the future. So with that, thank you for coming. If you have questions, comments, I will be over on the side somewhere, wherever Alistair tells me to go, back there. But thank you for coming, and I hope this was helpful.
Good afternoon, everybody. My name is Mike Nelson. I am a technical evangelist at Pure Storage, and I am here to talk about using and managing Microsoft Azure for the VMware admin. Now, I started giving this presentation back, believe it or not, back in 2017. And it's gone through a bunch of revisions and things like that, but the basics really haven't changed. So I'm going to walk you through actually, what you should be looking for, different services that you can use inside of Azure if you're not familiar with it. And there probably aren't some folks that are, if you're kind of sitting in an area where you're, are just doing VMware admin, you need exposure into those other things. So why do you need to know this? Because it's really about expanding your horizons, if you will. Not only that, but somebody might come along and say, hey, we need you to take care of this for us. We need to move these VMs into Azure, or we need this service, okay? We've subscribed to a service up in Azure, and it deals with virtualization, and that's in your job title, so we want you to do it. A lot of different reasons for it. So, anyone knows a lot about dolphins? You're kind of like, why is he showing dolphins on the screen? Well, there's a good reason, because I don't know if you knew this, but it's fascinating. Dolphins actually only sleep. They have two hemispheres in their brain. Only one hemisphere sleeps at a time. So a dolphin is always awake, okay? One hemisphere is sleeping, the other one is awake. Now, what that leads to is that a dolphin communicates by clicks, okay, and sonar. Now, what they say is that they can do clicks and sonar at the same time. One hemisphere is doing clicks, the other one is doing sonar. They're actually carrying on two different conversations at the same time. That is incredible. Now think as human beings if we could do that. A lot of us can't even keep one conversation going at the same time, right? So as administrators, take a look at what you do today. If that's what you do as a storage administrator, a VMware administrator, you've got more people that want to actually have you do multiple things at the same time. It's that whole multitasking thing, right? But multitasking, you can, context switch, context switch, context switch, and it gets really confusing. And you got to do that when you're actually looking at public cloud and what you've been doing on-prem for so many years. So if you take a look at Azure as it is, I don't know if you're familiar with it. So if Azure right now has about 60 different regions, okay? Over 200 plus data centers located throughout the world. So it's a big, bad, beautiful world of Azure, right? AWS is still the leader. They still have a little bit more, but Microsoft's right there. So if you're taking a look at it from a standpoint of where can I put the stuff that I'm working on, you've got a lot of possibilities. Cloud models. Now, when you take a look at cloud models, it's because you want to take a look at what you're actually responsible for. A lot of folks will say, hey, I don't have to do this. Microsoft's going to take care of that. All right? I don't want Microsoft to take care of this. I want to take care of that. Okay? But it's clearly defined what the cloud models are, what you're responsible for, and what Microsoft is responsible for. Now, if you take a look at what the new AVS service does, that kind of skews it a little bit, okay? So Microsoft and VMware have kind of changed the rules a little bit around the cloud model in that pretext of AVS, but it's not really that much. There's another presentation that I can stop at the VMware booth and ask them about it, but it really follows this line. Now, if you find this kind of confusing, you're kind of like, yeah, I'm not really sure where it fits. Let's take a look at it from a pizza perspective. All right? So when you look at it from a pizza perspective, these are all the things that you're responsible for with the soda and the table and the electric, the gas, the oven, and this is what the actual pizza place is responsible for. The gas, the oven, the fire, the pizza dough, the tomato sauce, the toppings, okay? If it's delivered or it's dined out, if it's made at home or it's take and bake. So think of it that way. There are certain things that you are responsible for and other things that they are responsible for. And there it goes. So the core of Microsoft Azure has to do when you're looking at accounts. Now, we're all familiar with vCenter, right? vCenter, you have the vCenter, you have a data center, you have your clusters, you have your resource pools, you have folders, you have all that kind of stuff in an organizational standpoint. Inside of Azure, you're looking at it from an Azure tenant. Okay, it starts out as an Azure tenant or account. Now, you can get this free account for yourself, or maybe your organization already has an account that you work under. All right? From there, we take a look at it from an actual subscription. An Azure account can have multiple subscriptions. You may just be using one subscription that your organization has like tens or hundreds of. okay? And that's just how Azure, Microsoft gets paid, basically. Either you're going to pay by, a credit card, or it's pay as you go, or, however it's worked out with your company. From there, we start looking into what we call the directory. Now, the directory is just like, think of it, everybody know what Active Directory is, right? I mean, you should by now. And what we've done up in Azure is something called Azure Active Directory, AAD. You'll hear that referenced a lot. Same thing in here. A directory is always inside of a subscription, which is always inside of a tenant. So from a directory standpoint, that contains all of your objects. Inside of that directory, like I said, all the objects, but you also have something called resource groups, or RGs. Resource groups contain all of those objects, but it puts it in a logical format, a logical area. So you think, hey, I need my VMs for my database folks to be inside of this RG. And I've named it database RG. Okay, so logically, you can organize these objects. Now, there are restrictions on the number of objects and things like that. I'm not going to get into that because they haven't given me enough time. But you need to, if you go and investigate this, you'll find out that there are certain things you can put in there, there's certain things you can't put in there, and there's a limit on the number of things. Now you can see it fill in. The number of things would be like the VMs, maybe some SQL databases. You're looking at NSG, which is network security groups, things like that, even networking. So let's take a look at how you get into Azure. How many folks actually use Azure today? All right, so you're probably getting in one way, I'll bet. Maybe two, okay? I didn't know if you knew this, but there are like a bunch of different ways you can get in. Almost a dozen if you want to count them all, okay? So let's take a look at a couple of them. First, you're going to go into Azure, into a browser, and you can see, you can just click on and get a free subscription, right? That'll get you in. You can take a look at it. You get $100 a month, I think it is, something like that. But the obvious place to start is called the portal. So the Azure portal is the UI. You can see right here, I'm looking around. This is your home page. You can see all the options that are available to you down here, but this is just a sampling. It's not all of them, okay? You actually can go to like all services and you can see more services that are available to you. Literally, there's over almost now like 6,000 services that are available to you inside of Azure. Okay, once you get in, there's the subscriptions I was talking about. You can take a look at those. You can move things around. So this is kind of like your little flyout area. You can move things around and put them in order however you want. We click on subscriptions. This is where you take a look at how actual subscription that you have and what the capabilities are, how they're billed, so on and so forth. We take a look at this again. We're going to drop down and we're going to look at the dashboard. Now, dashboards you can create. Dashboards can be pre-made. They can be shared amongst people. You can add a bunch of widgets. You can, put graphs, make it look all pretty, all that kind of fun stuff. But that's the reason of having dashboards. From here, we'll take a look at the all services. This is where every service that you have available to you, and even ones that you don't, that you can pay for, you can search. So here I'm just searching for VM. Right there, VMware vCenters. You can actually go in and add vCenters to Azure. There's free services, right? So free services would be great for you to try it out. If you haven't used Azure, you can go ahead and spin up some free VMs. The Azure VMware solution, okay, if you haven't looked at that, the AVS solution is really cool. From there, yeah, see, I clicked that little star there, it moved it into here, which is our favorites, right? So from here, I'm actually going to go up. Now I'm going to use something called Cloud Shell. If you've ever heard of Cloud Shell is actually a CLI that allows you to access Azure resources. I'm accessing it right from the portal. If you notice, there was a little icon on the upper there. I clicked it, it opens up another window, and it starts a PowerShell session. Inside of this PowerShell session are over 50 applications that are preloaded for you. That include things like PowerShell AZ CLI. It includes things like Node.js, MySQL command line, all kinds of things. Here it's actually, I'm right here, I'm doing like a get process. So this is running inside of a Linux container, all right? And the reason why it's running inside of a Linux container is because you can switch it between PowerShell and Bash. So if you are a Linux person, you were raised on Linux and you know Bash better than PowerShell, you can switch it right over to Bash and use that as well. It even has a built-in editor that looks like VS Code a little bit. Not much, but it does kind of a little bit. that you can actually edit files. But you're like, man, that's so small, right? Well, you can actually go, and then watch how I put it here, is shell.azure.com. You go to shell.azure.com, it opens up a full window for Cloud Shell. All right, so you have the full capability of the window where you can execute everything just right from there. And you can see here, I've actually got a shell. Now I can go ahead and do whatever I need to do, but it's a lot clearer. It still has the same options that are available there, okay, including the editor, which is a lot bigger now, so you can go in and edit files as you see fit. And then I'm going to come back over here eventually, and I'm going to switch to Bash. So it's just as simple as that. It says, hey, you sure you want to switch to Bash? Go ahead. We'll switch over to a Bash prompt. Now, if you're a Linux person, you're like, cool, I know exactly what I'm doing here, right? And you run it, and you can see it's a full Linux system. So those are how many ways so far? 1, 2, maybe 3. Okay, maybe 4, because you got Bash in there as well. Bash, PowerShell, right? All right. You also have the ability to do it inside of VS Code. VS Code, if you use that, you actually have an extension called, the first one is Azure Account. So if you connect to Azure Account inside of VS Code, you load that extension, and then you get this little icon that's right down here. You got a whole bunch of Azure stuff, by the way, extension-wise you can add. But you get this little icon down here. And I'm sorry if you can't see it over there. And then once you get there, it shows you the API management resources, and it wants you to sign into Azure. So you're gonna log into Azure so it can see those resources, what I'm doing here. So I close the browser page, I go back into VS Code, I bring the window back up here, and as you can see, it's showing my resources that are available, all right, and it's showing my workspaces. So in Azure Labs, you can see all the services that I have available to me, okay, just like you would see in the portal, but you're seeing it inside of VS Code, all right, so it makes it a lot easier. If you're doing scripts or whatever, you can do it right inside of here and communicate directly with Azure. From this standpoint, I'm actually going to look at, static web apps. The workspaces, this is where you actually look at storage accounts. Now, what's cool is you can run an emulator right here. So you don't even have to use the storage inside of Azure. You just want to emulate the storage so you can find out how much it's going to cost. It has a built-in blob emulator, a built-in storage emulator that you can use to try it out. This right here, the API, I'm getting the errors because I'm not connected with a person that has API credentials. But you can do API management there as well. Here's where I'm actually looking at the storage account. This is my Cloud Shell account. I'm going in and I'm looking at what is actually using storage. So I go to File Shares. There's my Cloud Shell, okay? And I look at Cloud Console. This is the actual IMG file, the image file of that Cloud Console that you saw me working in. It's just a Linux container. That's all it is. Go ahead and click, you can create a virtual machine right inside of VS Code. I just click virtual machine. It's going to ask me, what is the name you want to call that? I'm just going to call it test VM. And then it wants to enter a passphrase for connection. Obviously, because of SSH, it wants a passphrase. You can switch it over to certificates, but it wants to do this first. And they must match. And then you pick a region to put it into. Now, notice it didn't tell me what kind of OS to use. And the reason is because this is going by default. By default, believe it or not, Microsoft will put Ubuntu Linux before they'll put a Windows OS. All right? So this automatically will install a Ubuntu Linux machine. One of the reasons for that is licensing. Okay? Ubuntu doesn't cost anything to license, but Microsoft, server or workstation, that costs a license. So you can see here I have no virtual machines right now. The Azure VMware solution, you can actually create those machines. This is right here. Let me pop back into, excuse me. Where am I going here? I should be going into, notifications. It'll tell you that it's actually building something when it gets to it. I should be going back to VS Code. Take a look. There we go. It's creating the virtual machine test VM. It's creating the network. It gives you the entire status right down here. Now, obviously, you can see I sped it up because it takes a little bit to do that. And eventually here you'll see the full output. Okay, it created the virtual machine. It succeeded, right? And it'll actually say right there, do you want to view the output? This tells you everything that it did, and then it actually tells you, okay, what the SSH config is so you can add your certificate and things like that. It's very helpful information. So once it's actually created, I go back into the portal and I can see that VM, and then I can work with that VM from this standpoint. Here I'll just do a refresh and you'll see my test VM there now. And you can see that the test VM is up and running, and it gives you all the information about it, and you can go ahead and you can do that. Now, another way to access a mobile app, believe it or not. Android and iOS, you can access your entire Azure inventory inside of a mobile app, and you can see all the activity, the metrics that are going on, your networking, all that kind of fun stuff. As you can see, I'm scrolling through a lot of the metrics. This is all happening on a phone. Now, obviously, at an iPad and stuff, it would look a lot better, right? Especially when you come up and you start taking a look at, like, you know, even the rules that you're looking at. You start looking at networking statistics and things like that. That's all really cool stuff. I mean, all in the palm of your hand in case you get on call. You got to look up a machine. It's right there. From here, you can take a look at disks. You can look at alerts. You can do all that kind of fun stuff. Now, what's cool is, look what's back. Cloud Shell. You can run Cloud Shell on iOS. Look at that, it's bringing up a shell. And this is running on iOS, so I can actually sit there in my little tiny screen and I can go like this and try and, you know, type all the things I want to do inside of Cloud Shell. Even virtual keyboard. From here, I'm going to do, you know, get process. Once I actually click, there we go. And it gives me the same output. All right? Just like we could do through the web interface. So I don't know how many that is now. We're up to maybe 6 or 7, maybe coming up here. All right, so a little bit more I want to talk about on Cloud Shell. And there's something called Azure CLI. So Cloud Shell was one of them. Azure CLI is the actual de facto default that Microsoft uses to communicate with what they call the Graph API. The Graph API governs all of Azure, okay? Every object that you can see in Azure is governed by the Graph API. Now, you can use Azure CLI to actually do more things than you can do inside of the portal. Why is that? Because an API has actually progressed faster than a UI. It takes a while to put a button in a UI. It takes a while to figure out where that widget's going to go, where it's going to sit, where it's going to move, and things like that. So using command line tools is a lot faster, okay, and a lot quicker to results. So we take a look at this. I'm clicking, there we go. So we take a look at, we're going to actually install modules. I'm set a Cloud Shell, and I want to install a module. What if you want to use VMware Power CLI? You can install Power CLI inside of your Cloud Shell. You have a 5 gig image. That 5 gig image can hold a lot. And as you can see here, I'm installing the entire Power CLI, which is a big package, by the way. I'm installing the entire thing inside of Cloud Shell. So every time I go into Cloud Shell, I will have the access to Power CLI, which is really advantageous for, you know, doing work with the VMware VMs. So right here, I can show you that it actually did install just by doing a connect VI server to show you that it actually is a commandlet that's available there. And then we also have the VR server, the VMC, VCS. And then you get the full output, right? You get the whole yellow, I don't know what they call it, the banner, if you will. I list the modules out, but then you get the whole banner thing from VMware saying, welcome to Power CLI, you got to do this, do that, that thing. So that's how you would actually install that inside. Now, Cloud Shell is actually downloadable as a container. So if you wanted to, you could actually download that container and run Cloud Shell locally. So what's the advantageous of this? Dark sites, right? Anything that would have a hard time connecting to the internet, anything that would, you know, you want to talk CLI, you can actually download it as a Docker container, run it on a local laptop. It's a very small footprint, and you can run all your commands directly from there. Here you can actually see the problem is, look how big that sucker is. The container is a lot bigger. Why? Because if you look at it from an Azure point of view, Azure spins it up as a container, right? Inside of a Kubernetes cluster. The cluster is hosting other source resources inside of it. And that container that you're going to download is just a single container. It has to have all of the resources in a single container. All right, so that's why it's so much bigger than what you would actually use if you're using the cloud, Cloud Shell in the cloud. This actually tells you how to install the Azure PowerShell commandlets. Azure has its own PowerShell commandlets along with Azure CLI. That's all available on Microsoft Learn. I'm not sure why I'm going through this. Okay. Using Postman. So if anybody wants to talk direct APIs to Azure, you can do that as well using API clients such as Postman. A lot of folks are kind of, they don't like to do that, but then there are some folks that want to do a lot of automation and a lot of trigger automations and things like that. Then you would talk directly to the Graph API via third-party tools, such as that. It also has the Graph Explorer. So if you want to try something out in Graph, you can actually go to an Explorer interface, and it's think of it as like a playground, as a sandbox. You can actually test out API calls to Azure. So you can run, it even gives you examples, okay? But you can run direct API calls and get results. Okay? So networking. Networking is really important, right? So from a networking standpoint, you have something called virtual networks. We're going to go down, and you can see right here under virtual networks. Click there. When you create a virtual network, there's a couple different kinds, right? You have an internal network that actually talks machine to machine. You also have networks that can talk on-prem up into Azure, which are sometimes VPNs or express routes. But that's all defined inside of the virtual networks portion of Azure. Here you can take a look at Azure Firewall, private endpoints, all that other kind of stuff. But when you're dealing with networks, you have to know how to actually connect it back to on-prem if you're going to be managing like vCenter or anything like that. It has to be a connection. It has to be a point-to-point connection via VPN or express route, something like that. You can actually get visualizations of your virtual networks when you're working in them. Take a look at your address space, your subnets, all that kind of stuff. It really kind of helps you out understand logically how things are connected. Just like you can do in vCenter today. You take a look at the way that things are logically connected via subnets and things like that. You can do the same thing in Azure. Actually, I think Azure is actually a little bit better at visualizing the whole thing than what VMware does. You can even assign your own DNS servers, which is kind of important when you're working with services that require specialized DNS. You don't have to use Azure's DNS. Now, peering would allow you to take one virtual network and peer it to another. So those two virtual networks can share resources. They can talk to each other. Otherwise, by default, networks can't see each other. All right, so when you set up a VM on a virtual network here and a VM on a virtual network here, they can't talk to each other. Not unless you specifically tell them that they're able to do that. One way you do that is by peering those networks together. And this is where I get into the express route circuits. If you don't, I don't know if you know if your company has an express route or not. Maybe you would, but usually that's handled on the networking side, and it's just a direct connection right into Azure Data Center. It's really kind of cool because you have like really low latency and stuff like that. And then you have your VPN connections, which you can set up. You can set it up to your home if you like. I have a VPN, point-to-point VPN connection out of my home directly into Azure. And that just makes it one big network for me, and I can do whatever I need to do up there. Think about this from the standpoint of VMware. You can do the same thing. If you had VMware running, machines running up in there, you had a point-to-point VPN, vCenter would be able to see that VM. Storage. Take a look at storage. Storage has a whole bunch of different things that have to do with, different tiers, hot, cold, really hot. All kinds of things, but basically you're dealing with different kinds of storage, blob storage, file storage, and you're not dealing with data stores, okay? So the logic of a data store really kind of goes out the window with Azure. Azure's looking at it more from a standpoint of just being like a file system, okay? Or being a mass storage device that you can attach to a VM or to a service. All right, it doesn't really care, it doesn't want you to care about the back end and how it's all engineered and things like that. It just wants you to be able to point and click and use things efficiently. You can see all the metrics and things like that, all about your storage. Take a look at the capabilities. You can actually do crazy things like create static websites on your storage and do lifecycle management, have it actually go through and change different types. And then you can actually open an Explorer. So if you have storage, you can click on Open an Explorer and it opens it up in Explorer. You can actually see your storage like in an Explorer view, which is really kind of cool if you're like moving files around and stuff. And then this opens up Storage Explorer, which is an add-on which allows you to visualize all the storage that's available to you. New version, blah, blah, blah. And eventually this will come up and show you. There we go. You can see all of the storage, all your disks. If you have any Cosmos DB, Data Lake, all that kind of fun stuff. All right, so monitoring. Real quick, I have only about a minute left. I'm going to go through this. Azure Monitor and Advisor will actually go through and allow you to monitor and advise you on things that you need to do inside of Azure. Now, is this important to you? It very well could be, because you may have to control costs. You may be responsible for saying, hey, we need to control the costs around what's being done in Azure. Right? So Azure Monitor is really kind of cool. It gives you all this information about alerting, just like anything else. Anything goes wrong, you can be alerted on it. You're able to do change analysis, what actually happened, who changed it, when they changed it, and all that, which is really cool. Consumption. Extra point, extra credit. What movie is this from? Okay. Christmas Vacation. All right. Cost management and budgeting. That's really kind of important, right? Because how much money are you going to spend? How much money is before you spend, and your boss gets an invoice from Microsoft and he's like, whoa, what's this all about? You really have to understand cost, okay? It has a full cost management solution for you. So Microsoft and VMware, this is the last slide. As you can see, keep your friends close, keep your enemies even closer. Anybody know what that's from? Mad Magazine, all right, Spy versus Spy. The two resources they have, Azure Arc for VMware vCenter and VMs, and the Azure VMware Services, which is really cool. I advise you to check it out. It works really sweet. And that is it for me. Thank you very much.
Hello everyone, this is Girish Manmadkar from VMware Cloud Provider Program, CSP, as product management. My colleague will join me soon. I'm going to talk about optimize VMware Cloud Foundations for the cloud providers or cloud solution provider to make sure that they are able to optimize their CapEx and OpEx. So what's the agenda looks like? Definitely looking at VCF has two architectures. One is a consolidated architecture and another one is a standard architecture. So we wanted to focus on the minimum portion of it. So we'll just focus on consolidated architecture. What are the business advantages that you as a cloud provider will have if you look at this particular option? What are the various recommendations and how do we make it productionalize this particular deployment for your customers? At the same time, when we talk about it, we want to make sure that you as a provider understands what are the things are in scope and things are out of scope from a deployment perspective. And again, this is like a technical guidance. We want to make sure that use this information to run in non-production, but if you want to run production workloads on this architecture, you have some small process to go through an approval so that when it becomes a support issue, you have a VMware GSS supporting your environment without any issues. With that said, I think let us have a look the architecture looks like. Typically, we start with 4 nodes, which becomes sometimes too much for a smaller customer or mid-market customer. So we want to start with a smaller footprint, which is minimum 3 node. Since it's a vSAN, we want to make sure that you are able to start with the 3 node clusters kind of configurations. Then on top of that, you are able to deploy various components which are optional if you want to deploy, usage meter, cloud director, and login site, which are basically optional components. But again, depending on the server configuration, compute capacity, as well as available memory at your hand for running the customer workloads, will determine that if you have those enough capacity to run these additional components with the 3 node configurations. And available resources will be utilized in terms of allocating a resource pool for customer workloads. So within 3 host configurations, you are managing the environment as a management cluster with vCenter, NSX, and vSAN, and control managed by SDDC Manager, which will be utilized for performing a lot of lifecycle automation options or workflows. The business advantages, definitely it brings a lot of efficiencies in terms of OpEx, eliminate waste, the resources are utilized appropriately for your running customer workloads and also cost to the customer. Also, it gives you an ability to use out-of-the-box automation. What that automation is basically giving you an ability to perform lifecycle management of the entire stack seamlessly. Since it's a VCF, time to market is what is important. We want to make sure that bring up process to bring up the environment quickly based on automation is what is required. You as a provider or you as a customer want to make sure that you are able to deliver required compute storage back to your business as quickly as possible. So that's time to market. Again, you start small with 3 hosts, but it doesn't stop you scaling out. You can add a host by host and grow as per your requirement. So your CapEx and OpEx are optimized. You start small and then you add a host as you need a capacity demands for your business to grow. And definitely, it's a dedicated private cloud experience for your customer. The 3 hosts or additional hosts that you are making and scalability into the environment becomes dedicated private cloud for your customer. And again, when you are doing that, you are meeting your ESG goal as well. If you are VP of IT or if you are VP of your company, kind of trying to prove the ESG numbers, this is the way that you can start small and adhere to your ESG goals and compliances as well. So, from a recommendations point of view, as I said, Bring Up is a process which will build the entire stack. It is based on Cloud Builder. Most of the providers that I have seen, they will use automation, maybe an Ansible, maybe Terraform. That kind of calls all the Cloud Builder APIs. But if you wanted to start with a smaller footprint and you don't have time to do the automation, you can still use graphical user interface and then basically complete the process of bring up based on automation. While performing an upgrade, we want to make sure that you really understand while you are performing the lifecycle automation tasks, especially for vSphere or NSX, transport node upgrades, the server will be rebooted. So if you have 3 hosts and if one server is rebooted, you are running innovate 2 hosts. Do you have enough capacity? So what our recommendation is to make sure that to avoid any downtime, you definitely add a swing host. So swing host is a temporary host added, so it becomes 4 hosts, so that when the server number 1, 2, 3 are being rebooted one after other, there is still capacity and no downtime to your customer's workload is maintained to deliver your SLAs actually. Again, swing capacity, as I said, when you are looking at the swing capacity, make sure that you have your host of equal or larger capacity so that your vSAN, where it rebalances as a cluster, it rebalances really well and it doesn't have any issues with your customer workloads, right? And availability, we want to make sure that before you perform lifecycle automation tasks, we strongly recommend to take a backup, could be an image level backup or could be a file level backup to avoid any data loss. Again, sometimes things do go wrong in terms of having some NIC driver problem or whatever it is, right? So to avoid that, take a backup before you start any of this lifecycle automation process so that your customer workloads are and the data is protected. So out of scope, from this testing when we did it, we want to make sure that we minimize the third-party products or additional VMware solutions in this small architecture. So definitely, we realize suite of products like Network Insight, automation, VMware Tanzu, which requires edge type of clusters to be deployed. All those things were out of the scope. But again, depending on the host capacity, you may be eligible to deploy this and still be able to do right justice for your customers' workload without any issues. So these are the things that we were not able to test because we had limited resources, and we want to make sure that we give that guidance to you, right? How do we do it, right? So the steps are involved like in a 3-host configuration. Cloud Builder is an automation tool used to deploy the bring up process or complete the bring up process. As a part of that, some files where you will go and edit it, restart your VCF bring up process, and then basically execute it, and it will bring up your entire SDD stack with the 3 hosts. It won't complain that I'm missing a host or something like that. So we are making sure that with this setup, the bring up process will finish with 3 hosts. And then, while you are performing lifecycle automation, this process is well documented in the VMware Cloud Foundation documentation as well. But want to make sure that you understand that if you are adding a swing host as a temporary host, you don't want to touch it. You don't want to upgrade that host because that is temporarily there. That way you can minimize your overall lifecycle automation process as well. Because after the LCM work is done across all the 3 hosts, you are going to go and decommission this host and it's going to go to your pool, right? So that's why we are recommending you to skip this host. So LCM process will ignore that host and will not perform any upgrades, maybe an ESXi host upgrade or maybe NSX upgrade seamlessly. And with that said, I think if you have a question, definitely I'm here. I would be happy to answer. But this gives you an ability to start small and grow. It's a kind of land and expand type of capability with your customers. And also utilize the automations delivered by VMware Cloud Foundation. And as you probably have seen yesterday, like, private AI foundation, this becomes a part of that process. So you start with this foundation and then scale up and go into the next level of AI ML type of workloads that you can run on this platform. With that said, thank you very much. I really appreciate your time.
I'm like, what? They're not recording them. That's fucked up.
I was bummed to end up over there instead of here just to at least have gotten some. You know what's even better, dude? I still have a fucking recording from doing VMware, man.
Really?
Zane's shit, because he was in the sponsored session, popped up like 2 days after the event was over. So Jim Jones and Falco joined us as the new FSA for stuff in Germany.
Yeah.
They put on the big stage, dude. They had like 500 people registered for the event, so they went where they had like the main keynote. There's nothing.
No
Like,
shit.
they had 4 cameras doing fucking live streaming in 4K when they were doing the keynote, and like y'all couldn't capture one recording. Mine, they're like, well, we'll go double check. We're 99% sure we have a recording, but we also haven't decided if we're going to actually make it available.
That's fucked up.
So like, there were like 16 sessions that they recorded, and now after they told us they were recording, they're like, well, we might just make these. They were exclusive. You had to be there. And I'm like, well, then send me a fucking copy.
Oh shit.
Shenanigans.
Ooh, they got my mic on. You don't have to, really. All right.
I slept great last night, but I'm still
You rock. Nope. Tell him to go choke his chicken.
45 seconds.
All right. Okay. Good afternoon, everybody. Thank you for joining me. My name is Mike Nelson. I'm a tech evangelist with Pure Storage. And I know this is lunchtime, so thank you for joining me. And this is, we're going to talk about GitHub for newbies in 12 minutes, believe it or not. I'm going to see if this is actually going to work. So, does anybody know what this is? Oh, wait, what is it? Octocat? Yeah, if you know that, you shouldn't even be here. Okay, now, it's actually, what is Octocat though? What is it? It's a cat and an octopus, right? Yeah, that's the original logo for GitHub. So if you know what this is, then you don't need to be here. But this is actually taken from a Canadian animated TV show. That's how they actually came up with this this logo. I mean the mascot. All right, there we go. So can we do this in 12 minutes? Absolutely not. There's no way you can learn GitHub and Git in 12 minutes, but I'm going to try my best. I really am. So extra credit to anybody who knows what movie this is from. What's that? The Fifth Element. Excellent. Awesome, dude. That's right. That's great. Trying to consume all this information in 12 minutes, good luck to you. So GitHub, what is it? GitHub is really a code hosting platform for version control and collaboration. Basically, it's a really great place to put your code and to share your code with other people, right? It lets you and others work together on projects from anywhere, all right? Is it free? Absolutely, yes, it's free. Do you want to use other services that are premium, like Copilot and things like that? Well, then you got to pay, right? But the core of it is absolutely free, which is really cool. And who owns GitHub now? Microsoft, that's right. So, they want your money eventually. Okay, so at the core of GitHub is something called Git, All right. Anybody? I'm not going to ask this question because I don't think anybody knows where the actual term Git came from. But if you do, that's awesome, because Git is actually a British slang for an unpleasant person. That's kind of weird, right? Well, the person who created this whole thing actually did it because he feels that he names projects after himself, and he thinks he's an unpleasant person. So that's why he called it Git. And there are a couple of different variations that have come out since then of what Git really means, but that's basically how it came about. But Git is the version control system, VCS, if you're not familiar with that acronym is, that behind GitHub. So you have GitHub, which is a portal UI, and you have Git, which is a command line. It's API fast and it's built into IDEs. IDEs are the integrated development environments, right? An IDE could be VS Code. It could be Visual Studio. It could be, Sublime. It could be, and just about you name it. You can have it as an IDE. But Git is built in as a version control. Now it works specifically for GitHub. It does work with other version control systems, but it was made for GitHub. Okay, do you need to learn it? Not really, okay? If you're gonna use the portal, you really don't need to know Git, okay? It takes care of everything for you, from the version control, everything, the commits, the merges, stuff like that. You don't need to know Git. If you want to get into the meat and potatoes of it and understand how you can do everything from the command line, then yes, you need to learn Git, okay? The GitHub, if you think about it, GitHub portal kind of like abstracts that away from you, all right? And it makes it easier to use. So the important stuff, repositories. I'm going to go through these now. The repositories is a place for code. That's what they call a repo, all right? When you take a look at forks, forks is, you think your fork, you're taking a fork and you're eating something. Well, basically a fork is when you make your own copy of existing code. So say somebody you know or a vendor has code up there, you can click on fork, which is an option in the UI, and you can make your own copy in your own repository, in your own little space, and you can work with it there. Issues, exactly what it says. Bugs, enhancements, questions, you name it. That's an issue to you, and it's an issue to the developer, then that's where these get put, where these get put. Pull request, or otherwise short name PRs. Pull request is where I say, I want to add my code to your project, or I want to modify the code in this project. I'm going to do a pull request, okay, to the original project and say, yeah, I want to add it. This is what I want to add and why I want to add it, or why I want to change it, or why I want to delete it, or whatever I want to do. All right, that's called a PR. And from a PR, you get things called merges and commits. All right, so when a PR goes through and says, I want to add my code to your project because I think it's awesome and I want to add my stuff, you can actually do that, and then what the author does, or one of the author delegates, will do what's called a merge. They'll take your code and they'll merge it with their original code. And they'll be like, yeah, now this person's stuff is in there, and we've added this functionality, or we fixed this bug, or we did something, okay? And when they do the merge, they merge it together, they have to commit it. That means they're putting it down and they're saying, okay, this is a release. This is it, final, boom, we're committing, right? But commits are reversible. So if you had to, you can always reverse it. Everything in GitHub is pretty much reversible, except deleting, things. If you delete a repository, you can't reverse that. Delete your username, you can't reverse that. But in code, it's always reversible. Branches. There's safe containers to test code before moving to prod. Think of it as test dev into prod, okay? A branch would be called test dev. A prod branch would be called main, okay? And you'd be able to move things from test dev into main. Pretty simple. And then permissions. You have granular permissions on the repository and on different things that you can do inside of GitHub that allow you to tell, a helper what they're able to do. If they're able to write, read, all that kind of fun stuff. All right? So there are a couple tools that you can use to work directly with GitHub. We have the Git, which is a CLI we talked about. We have the GitHub Desktop. You can download a tool called GitHub Desktop, and that allows you to actually use it locally on your machine, where you can interact with GitHub without having to use the portal. Your favorite IDE, Visual Studio Code, Git's got, I don't know, probably half a dozen plus, probably a dozen plus of different things you can do inside of Git. your favorite SDK, if you use PowerShell, if you use Python, you use Ansible, you use Terraform, whatever you use, Go, Ruby, they all have integrations into Git, all right? They've all been modeled that way. And then you always have the UI to fall back on. So let's take a look at that. This is where I am. This is where you actually, when you sign up for a new account, you're going to be inside of GitHub. This is kind of the layout you get, kind of the dashboard, if you will, view of it. All right, so I'm going to be moving around. The first thing I'm going to do is I'm going to go up into that user area. The user area is where you can set all of your settings, feature previews, all that kind of stuff, your email, account, all that kind of fun stuff, right? All the housekeeping stuff, if you will. So it even tells you if you want GitHub free or if you want to set up a plan, a payment, so on and so forth. This is where you can, all the different things that you can do for your profile. So we're going to go back. You always remember you can hit Octocat to go back. All right. So once you're in here, you can try Copilot. I encourage everyone to try Copilot. You can change, add features that they have available, all that kind of fun stuff. So what we're going to do is we're actually going to go in and we're going to create a repository. That's the first thing you want to do is create a repository. We're going to go in there and you can name it anything you like. Okay. And as long as it's not used within the same repository or within the same account. All right. So you can name it whatever you like. This is demo code. You can make it public. You can make it private. You can add a README file, kind of helps you understand, gives you a documentation about what it's doing. And you can choose a license like Apache or whatever. Use something called gitignore, which ignores files, specific files that you point out. I don't want anybody to know about these files. And then we actually go in and take a look at the different things you can do. You have the code, you have issues like I talked about, the PRs. You have actions, which I won't get into, I don't have time. It's called GitHub Actions. Projects, wiki, security, insights, all that kind of fun stuff. So it gives you a complete environment that you can collaborate on with code. All right, it's actually pretty cool. When you get into actual settings, insights, you can see a lot of stuff about that. When you get into settings, that's where that's all set, right? So you can say, I want issues. I don't want wikis. I want to preserve. I want to add discussions, okay? If I add discussions, I go up to the top, look, now I've got discussions. All right, so you can have conversations with the people that are contributing code. Okay? From this point, we're going to take a look at the code. You have these files right here, a license file and a README file. I can actually go in and I can edit that directly inside of the UI. So that little pencil or pen, I can actually go in and I can edit this file. So if I go in and edit this file, add it, I go up there and I say commit change. All right, so if I commit the change, that's saying, hey, okay, commit the change, tell me why you did it, what the description is, and whether or not you want to put it into the prod branch or some other branch. All right? Once you do that, you can actually see if I go up here and refresh and look at the code, you can see it added, it took that. All right? So why was I able to do that without doing a pull request and all that? Because I'm the owner, and I can do that. I can edit directly. I'm an admin on this, right? If you're not an admin, you have to go through the whole thing of doing a PR. If I want to add a new branch, I'm going to go out and add a new branch, call it demo, create a new branch, simple as that. Now I can have my code in another container that doesn't affect prod. So I can do whatever I want without affecting prod. All right? And go, okay. So this is pretty much it, what I can get through. If you ever want to download something from a repo, you can create a new file, upload files, but that little code button there, if I could speed this up, I would. That little code button, you can actually tell it, I want to open it in GitHub Desktop, or I want to download it as a zip file. Okay, so you can download that entire code right to your local machine and use it however you like, if the owner allows you to do that. Okay, those are the permissions on the repo. Okay? So, thank you very much. I'm out of time, and if you have any questions, I'll be right over there.
Yeah. Hi everyone, thank you for your time. I know it's lunchtime, but thanks for your presence here. I'm going to go through some deployment options for Foundation for cloud provider, cloud service provider. It gives an ability to, really have various look at capex and opex. So let us roll into it. Just to quickly give you a background about what VMware Cloud Foundation is, in few slides, it's basically standard architecture, validated architecture based on simplified way of scaling the environment. You can start small, you can grow as you need by adding host by host based on automation, which also does life cycle of the entire stack, comprises of vSAN, vSphere, NSX at the core with some additional components as you move forward. So essentially, if you look at Cloud Foundation components, they are all proven products: vSphere, vVols, NSX, uh, all other optional cloud controls, or or Tanzu or vRealize automation. They are a part of overall Cloud Foundation footprint, where you can deploy the core components as a management cluster and then manage it through SDDC Manager. And as you move forward toward your multi-cloud strategy, you have a cloud console, and then additionally, you have an option to deploy Tanzu Kubernetes clusters as well as various area operations based on vRealize lifecycle automation. So in short, if you look at it, you start with management domain, which typically starts with 4 nodes, and definitely it brings up your management cluster, which is basically comprises of SDDC Manager, vCenter Server, NSX managers, and then it gives an ability to deploy the customer workloads or your business workloads either into the management domain by using resource pools, or also gives an ability to deploy the workload domains. Workload domains can be for a tenant A or tenant B, essentially giving you an ability to carve out or slice your various infrastructure components to deploy a tenant-specific workloads into the Cloud Foundation environment successfully. Let us have a look on the deployment options, what it is that we can do. From a single site or stretch or multi-site or even edge site deployments, Cloud Foundation will allow you to deploy definitely on one site. You can start with one management cluster and you can grow and you can definitely go into the standard architecture, which is basically an ability to deploy workload domains. Each workload domain will have their own vCenter servers, and then you have minimum 3 hosts to start with. Also, if you wanted to have a stretch cluster deployment, you have an ability to do a vSAN stretch cluster for your workload domains by stretching management as well. So from a DR perspective or from resiliency perspective, you can have your DR set up very easily with the automation that delivered by Cloud Foundation. Again, the deployment option number 3 could be in a single site. You can have a multiple workload domains, or you can have one big workload domains. Each workload domain can scale up to 64 hosts, which is basically a vSAN specific maximums that you can achieve. And each vCenter server can have up to more than 1024 hosts managed. So you can have multiple clusters within the workload domain as well. And again, site option number 4 is multi-region. If you have different availability zones, you can definitely deploy VCF and then basically have your NSX load balancer basically managing where you want to deploy workloads depending on the logic that you built it into your load balancer, or from the region where it is coming, a VM will be deployed. And I have a customers deploying VCF per country. So I got about a customer running VCF in 10 countries. Each countries have their own set of VCF running in, and then basically managed through cloud management portal to deploy a workload at a given particular customer site in a given country seamlessly. So with that said, I think with VCF 5.0, you probably have heard about having an isolated workload domain. So what you see is a single SSO domain that we started with, and you can grow up to 14 workload domains because all those workload domains, vCenter servers were in an enhanced link mode. But with VCF 5, we are able to really give you an ability to isolate them. You can have 14 workload domains in a link mode, but you have an option when you're creating a workload domain to have its own SSO domain. And then you can scale up to 24 or 25 workload domains essentially. So each customer has their customer 1.local, customer 2.local type of SSO workload domain that can be deployed for each customer. And if you really wanted to go totally isolated, you can do so that each and every customer will get their own SSOs. It could be your different units within your company, like accounts or HR or maybe sales. You can have workload domain defined, and then you can attach their own SSO domain to ensure that you know from where it is coming and who it belongs to. And it helps also you to do a show back to your customers as well. So this is a new feature that was launched officially in VCF 5, kind of allows you to really go wide and scale your architecture beyond 14 workload domains. You can go up to 25 and up to 1,000 hosts. Again, these are typically soft limits. If you have a need to scale beyond that, we will work with you to make sure that you have no performance issues, because there's only one SDDC manager, and that SDDC manager database has to make sure that it can manage and deliver the performance when you are creating a workload domain, when you are performing an upgrade or LCM functions or workloads onto that particular workload domain. So we can work with you. So coming back to how it looks, you must have heard about VMware Cloud Editions, right? This is the way that you can think about as a cloud provider. If you are to deploy various workload domains, you can do so. So you can kind of refine your dedicated private cloud architecture with new way of delivering it. So each customer is essentially one workload domain. So they are getting a dedicated host for them as a dedicated private cloud. But the entire management is centralized as a provider. It's a cost to the provider to run the business. Customer is happy because they are getting an isolated environment just to run their workloads. In fact, since I'm running customers' workload domains, vCenter server, NSX servers, or NSX manager into the management workload domain, I am giving more capacity for customers' workload domains or workloads to run in their own capacity. So you are providing more capacity to your customers easily. Let us do a double click on what it really means. So it's the elasticity that brings to the table from a provider point of view as well as from customer's point of view. So if you look at this, it's more like I have workload domain 1 with multiple workload domains or multiple clusters, easily manageable from my cloud provider services perspective. What I have on the top in the green is a cloud director, which allows me to have that multi-tenancy very seamlessly, very easily, giving me an ability to really deliver something like virtual private cloud for each customer. Again, if customer wants to scale out, either you can scale out by creating a different cluster or creating a workload domain dedicated for that customer. If there is a third customer comes in, I can create a workload domain, a cluster for that customer and allocate to them to use it. For me as a provider, cloud director remains same. There is no change for me. So that's an additional advantage that you can have as a provider to deliver single tenant cloud in a multi-cloud fashion actually. And that can be scalable very, very easily from provider's point of view. So again, kind of giving you the scalability numbers with VCF 5. My management stack can grow because I have maybe 24 workload domains that I want to manage. I have various additional other components running into the management cluster for my customers' workloads. Like for example, edge clusters. They are going to run into my management cluster, but actual workloads will be running onto each workload domain. So that I have to scale my environment and go up to 24 isolated workload domains and maximum up to 1,000 hosts. This is what we have tested successfully, and that's what we are putting it as a maximum. And if you want to scale beyond that, definitely we are there to help you. Giving more color on architecture level, like as a provider platform, typically if you have a need of sovereign cloud, so sovereign cloud architecture kind of fits onto this foundation and easily scalable to maybe a developer ready cloud or maybe DR or migration type of use cases that you can execute on top of this with the help of cloud provider architecture or a design that we have. So as a provider, what are the key benefits? For example, scalable architecture, easy onboarding, making sure that I have a way to reduce the sprawl of VCF. In the previous releases, there were like sprawl of my VCF clusters running for each customer. I can take care of that and be operationally efficient in this particular new architecture as a provider. In conclusion, it definitely brings a lot of flexibility and also gives you scalability and reduce your operational headaches on managing those multiple VCF environments. Instead of that, you can have one management plane and deploy it for all your customers with a single management plane, reducing OpEx as well. So it's a unified experience. Elasticity is there, highly available and multi-cloud ready. And also now, as you heard yesterday, this is the platform that you can deliver to get your customers ready or get your business ready for running Gen AI type of application very, very easily. With that said, I'm out of time. Thank you very much for your time. I appreciate it. Enjoy the show. Thank you.
Good afternoon, everybody. Welcome to this session. My name is Mike Nelson. I am a tech evangelist for Pure Storage. I'm going to be talking about infrastructure as code in 11 minutes and 59 seconds. Why isn't it 12 minutes? Because Al won't give us the full 12 minutes. He only gives us actually like less than that. Yeah. All right, so what is IAC, right? Infrastructure as code. If you haven't worked with it already, it's the practice of managing and provisioning infrastructure through software and automated processes. At least that's what the dictionary says. Basically what you're doing is you're taking hardware and you're managing it through software. All right, so you're taking things and you're doing everything through software. It's infrastructure as code. All right. So codifying infrastructure. A lot of folks will say, how can you actually codify infrastructure? Because there's bare metal, there's physical switches you have to plug in, and you have to do things with cabling and all that kind of stuff. Yeah, you can't codify that unless you're using what? Software defined, right? So using NSX, you don't need those actual connections, right? You just do virtual connections. But at some point, you still have to use cable. There's still a physical aspect to it. What this is trying to do from an IAC standpoint is make it as easy as possible and as replicatable as possible. Replicatable is a word, I think it is, as possible that you can actually do this through software. You can manage and build infrastructure through software. So the declaration models of IAC, it creates identical infrastructure every time it's applied. Every time you apply it, it'll create the same thing, no matter what, unless you change the code that's actually doing the applying. Okay? So it's going to create identical every single time. It's both creative and destructive. All right? So we have IAC that can actually create things, and we have IAC that can actually destroy things. All right? So creation and destruction. It's imperative and declarative. Now, if you don't know what imperative and declarative is, we'll talk about that in a second. And then necessary to reproduce identical configurations of infrastructure by code. That's exactly what it is. It's required to actually reproduce that identical configuration. So we talk about imperative versus declarative, because this is really an important point of IAC, is imperative is always what to do, declarative is what is wanted. All right. Now I admit 100% transparent. I stole these slides from somebody else because they were like really cool and I wanted to use them. But you forward imperative, when you talk about going to an actual pizza parlor, you have to go forward 1 mile, turn right, forward 2 miles, turn left. You're basically going through GPS, right? But if you're doing declarative, all you want to do is go to the pizza. Go get pizza. All right. So you don't have to go through all these steps. You just say, I want to go get pizza. All right. And the rest works itself out. We take a little bit deeper, is imperative is going to say the starting point matters. It's difficult to audit. It's difficult to detect drift. No version control, not repeatable, so on and so forth. When you're talking about declarative, the starting point doesn't matter. It doesn't matter where you start because you've already declared it. It's already there. Okay? The engine determines how to get to the destination. You don't determine how to do it. Okay? The thing that's creating the infrastructure as code determines how to get there. Okay, and idempotent property and idempotent. Anybody know what idempotent is? Okay, mutable, immutable. All right, means it can be idempotent, can be deleted, not deleted. Repeatable in a pipeline, really critical when you're talking about CI/CD pipelines and being able to create things that go through a full automation process. IAC is the same way. IAC can be a complete pipeline process where you don't even touch it. You don't even have to trigger it. It's triggered by something else, creates the infrastructure, and you just watch it go. That's it. Can be version control, can validate and detect drift, which is really huge in data centers today, because drift is something that happens all the time. You get configuration drift where one thing gets a little bit different than the other. You have a network card that's running this version of the driver, and all of a sudden you have another, got a Windows OS update or something that put a different version driver for that network card and it changed something. That's configuration drift. Okay, so examples of frameworks you can use. There's Terraform, SaltStack, Bicep, which is used to be Azure Resource Manager. All these kinds of things. Anybody, Ansible has been pretty popular. Terraform is really popular. You have Puppet, Chef. The other one down there, Kubernetes. You can actually do IAC with Kubernetes. I don't know if you knew that, but you can. You can also use Docker because Docker reproduces the same container every time. It doesn't change the container. Whatever's in the container is opened at the same time. So when you open a container, you have what you have. You spin up the same container, you're going to have the exact same thing. That's infrastructure as code. And then you have something called Pulumi, which is, kind of like the same thing as Terraform. And of course, you have scripts. You can do this all via scripts. You can do it via PowerShell scripts, via Python, your own scripting. You can do that. Look at SRM, what it used to be. If anybody remembers the old SRM, everything you had to do was via a script. You were reproducing everything via a script. That was infrastructure as code, believe it or not. That's what it was. In its infancy, but it was. Where am I? There we go. So the challenges we have are human error in setup. Obviously, you can always fat finger something. Something's going to happen. You have configuration, drift, and shift. So I talked about drift, but does anybody know what shifting is? When you have configuration shift, you get a stack of servers from HPE or Dell or whoever. Is everything identical in every one of those servers in that bare metal? Everything identical? Okay, everything's identical. Okay, now we're going to put the OS on. Is everything still identical in every one of those? That's what they call configuration shift. Okay? Duplication of errors. If something errors, okay, in your IAC, it's going to error every single time. All right? It's not going to stop erroring. It's going to continue to error. And then technical debt. Actually, people learning how IAC works and how to create IAC, how to create the scripts, how to use the frameworks. There's a lot of technical debt there. Some of those frameworks are easier to learn than others. I'll be honest with you. Terraform is incredibly easy to learn. Ansible takes a little bit more, but once you get the hang of it, it's really kind of cool. SaltStack, you better take the time with that one, So, depends on what you pick. Do and do not. Do not document. IAC, believe it or not, this goes against everything I believe in. But IAC is not meant to be documented. The code is supposed to be documented. So the code is supposed to be self-explanatory. It should tell you exactly what it's going to do. You shouldn't have to write a separate Word doc that tells everything that the code's going to do. That's not what it's for. Do not make configs complex. Do version control, absolutely. Do reusable and modular code. Reuse code you will, in anything, okay? Do not reinvent the wheel. And do remain in and sustain compliance. That's really kind of important to folks who work in government, finance, all that kind of fun stuff. All right. And I'm almost out of time, but here I'm actually going to go through and take a look at something in Terraform. Maybe some of you use Terraform, so you know what I'm looking at here. The main.tf is where you actually describe what's going to be built by Terraform. So in here you can see I'm actually creating a simple Ubuntu VM, and I'm getting at all the variables that have come from a variable file, or I'm actually designating here, like the IP range, the subnet, things like that, SSH, all that kind of stuff. But this code does not change. Every time it's run, it's going to build the same thing, unless you go in and change it. So that's why you do version control, because version 1 will do this, version 2 will do this, version 3 will do this, version 4 will do that. All right, so when we actually run this thing, and I sped this up obviously because it takes a while to do this, I can do a Terraform init. It's going to go through and it's going to download the providers it needs to actually perform the scripts, which it does here. You're going to do something, now I'm going to do a Terraform, I'm going to be like, I want to apply this. No, wrong. Do a plan first. Terraform plan will show you exactly what it's going to do. It'll even output it for you for compliance reasons so you can see what happens. All right, so make sure you do a Terraform plan first. Tell you everything it's going to do. Now you can actually go up and do, once I clear the screen here, you can actually see it, do a Terraform apply. Terraform apply is going to do the same thing plan did. It's going to tell you everything it's going to do, but then it's going to ask you, do you really want to do this? And you're going to say yes or no. Okay, and then it's going to go through and create whatever you want. All right. I should have sped this up a little bit faster. All right, so once it's actually applied complete, it's built the VM. It actually tells you that it built it, and it gives you the public IP address and the resource group name, so you know how to actually connect to it. I do an AZ VM list, and it'll actually show me that VM that was created. As you can see here, it's using the same thing, the RG winning Joey, up here, the RG winning join resource group, and there's a Ubuntu server. So it created that. Now if I run that script again, it's going to create the exact same configuration, all right, that it created previously. Now what I'll do is I'll run something called a destroy. A destroy will go through and it'll look at something called a state file. There's a Terraform state file. That state file records, okay, what was actually done and when it did the apply. All right, so it's going through and it's comparing what is in that state file to what actually exists and making sure that nothing has changed. There's no configuration drift, there's no configuration shift. All right, and if it says everything's cool, then it'll actually go through and it'll come up and it'll say, do you really want to destroy this? And eventually you get to that point. Come on. You see it's actually going through and looking at everything, okay? Here, do you really want to destroy it? There's no undo here, folks, all right? So you say yes, and it'll go through and just start tearing everything down step by step. Now, in IAC, there should be absolutely no errors in this, okay? So when you do destroy, it is destroying exactly what you did before. If you see errors in this, then you got a problem with the code, okay? It should be fixing it for you, but there is a possibility that something happened to that state file. State files are shareable. Other people can use state files. They can mess with your state files. They can change your state files. Be very careful about that. Here's in VS Code, you can actually see these are the TF state files. This is the one that actually tells you what's going on, or it knows what's going on. There's also a TF state backup. It makes it automatically, so there's always a backup there, okay? And this is the main TF again. This is showing you that I'm doing something a little bit different using Pure Storage, the Open Connect. I'm actually doing with storage now. Most of the time we're doing with VMs, right? Or we're doing this with infrastructure, bare metal. Okay, you can do this with storage. You can do this with networking. At Pure Storage, we actually, I was part of the team that created this where you can actually go through and do infrastructure as code with storage. So if you want the exact same storage allocated every single time, you can use our Terraform and you can do this. Now this isn't a vendor thing, all right, so I'm not telling you to do that, but there are a lot of other vendors that do it as well. From a networking aspect, I know Arista has some great stuff out there. So there's a bunch of other folks that do it. So I built the storage, even with iSCSI IDs and everything else, and now in a volume, and now I'm destroying it. And that's it. Thank you very much. I appreciate it. If you have any questions, I'll be right over there.
Right. I assume you guys can hear me in the back. Am I loud enough or you want me to be more louder? Good? Good enough? All right, good. Okay. All right. So the session for today is virtual volumes. I'm sure you must have gone to these sessions, right? Pure has some of those, and then you have other storage vendors where they talk about vVols, right? Viva vVols. And they talk about how vVols are great and how it's beautiful and how that helps any application, business critical application, do most of the day two operations, right? So from my background, I've been an Oracle DBA for 26 years, joined VMware 2012. I'm pre-sales, I'm post-sales, I'm ex-PSO, services, GSS, jack of all trades, master of none, right? This is exactly what I am, right? So what happens is with vVols, we'll talk about BCDR, scalability, and some performance number, whatever I can manage to squeeze in 30 minutes. And if I'm not, I'm going to start talking faster. I'm from India. This is basically what we do. This is what we Indians do, right? We talk fast, right? All right. So that's the agenda for today's discussion here. You have challenges to running Oracle workloads. You know, what challenges vVol solves, right? And I'm going to talk about that classic RDM versus VMDK. Trust me, how many people had that RDM versus VMDK holy war going on and how vVol solves that, right? Talk about some of the use cases, backup and restore, cloning, right? Noisy neighbor. I'll talk about a case study that we did where we ran Oracle workloads, vVol versus VMFS, and where we saw performance improvements. And then if you guys have any further questions, feel free, come, hunt me down, search for me. I'll be there at the expo floor. More than happy to have a discussion. There is a drawing at 4:45 for a pair of good sneakers. It's beautiful. You don't like it, just give me the ticket. I'll take it, right? I love free stuff, right? Good. All right. This is what vVol is, right? So I'm not going to go much deep into it, but from a high level perspective, you have your protocol. How many people have actually heard of vVol? Or familiar? So okay, I'm preaching to the choir here. You have the PE, protocol endpoint. You have the VASA. You have the storage container. Great. Beautiful. So I can move on. With NVMe over Fabric, right? You have Jason Massey and you have Cody Osterman from Pure Storage doing that awesome presentation, right? With the NVMe over Fabric, you have the VPE, your virtual PE. So you don't need to have that physical PE attached to every ESXi servers, right? I know I'm waiting for it. I know you guys are waiting for it. So let's stay tuned. And challenges. This is where I want to come to. Challenges of running Oracle workloads, right? See, what happens is not every database is born alike. Every DB has different levels of criticality. Every database is born different, right? What happens is, and of course, nobody here in the audience will stand up and say, well, my database hasn't changed shape or size for the last 10, 15 years. It's been at 2 terabytes. Please, then that's not a database. That's an Excel sheet. That's a Word document. Then this is not the session for that, right? Databases will increase in size. The rate of change depends from DB to DB. What happens then is, it's a matter of scale, right? When you have the Oracle ways of backing an Oracle database up, probably 5 years ago, it won't work now for you because it's gonna break as per Hooke's law, right? Then what do? At some point of time, you need to start talking about VMware way of replicating it or taking a backup or the storage way of doing it, right? So those are some challenges here. From let's say a backup restore use case, correct? When we start talking about an application way of taking a backup, you have your Oracle RMAN, your hot backup, so on and so forth. That works like a charm, right? But like I spoke about the scale, at some point of time, they will take a long time, right? Ideally, you guys being VMware guys, you just want to go to the web client, right click, take a VMware snapshot, clone, and lo presto, I'm done, right? That's where you want to do it. But all of us, we know with VMware snapshot, where you have snapshot of a snapshot of a snapshot of a snapshot, you go to delete it to coalesce it, it takes a long time. Yes? But then, what's the fastest way of doing it? Storage base, correct? But everything in the world has pros and cons. With storage base, I get his database, her database, your database. I don't want any, I just want my database. I can't do that. So, people say, don't worry, I solve the problem. 1 RDM per database, I'll solve it. Great. Oh, so now you're back to the RDM versus vVol issue, right? Where you run out of SCSI limit once you go to 1024. So there is no real cure to it. The cure to it is virtual volumes. But what happens is with vVol, you have that VM level granularity or a VMDK level granularity, but you get the look and feel of a RDM. Things that we have been loving in the past before, right? RDM, physical devices. So speed of storage with the flexibility of doing these operations on a VM or even on a VMDK level. And I'll give you use cases as to why you want to do it on a VMDK level, right? For example, you have a virtual machine with 3 databases, right? Open question to anybody. You have a virtual machine with 3 VMDKs. I just need to snapshot 1 database on 1 VMDK and I need to back it up and I need to clone it. How will you do it? Oh, VMKFS tools, Power CLI, take a virtual machine snapshot, take a clone, go and delete it. You see all the stuff I'm doing around here? Okay, I'm not going to do that. I'm just going to use the plugin from a storage vendor. I'm going to point it to that VMDK. I'm going to boom, take a snapshot, take a clone, attach it, I'm done. I'm off to the movies. See how life becomes simple when you have virtual volumes doing it for you. Because at the end of the day, vVol is nothing but a well-orchestrated system of RDMs. Let me tell that again. vVol is nothing but a orchestrated system of RDMs. It is nothing but an RDM, right? As an RDM, as a LUN, if the LUN ID is 256, with the virtual volumes, you have the PE, and if the PE LUN ID is 1, it's 1:256. That's all to it. So an RDM can become a vVol can become an RDM, but it's that bridge between your VMDK and RDM, right? So let's look at some of the challenges. Okay, how many people have faced this war? VMDK versus RDM. Your Oracle DB has come back to you and say, just give me RDMs. You know what VMDK is? Performance is so bad, right? I just ran my test. Yes, probably 10, 15 years ago, right? Pre-ESX 3.5 days. 3.5, 4.0, 5.0. And that's the reason why I put these old documents there, right? Because we already solved the problem saying performance difference is only 1%. And there is no reason for me to do the same performance testing on ESXi, right? U2 or U1. I don't have to do it. I've already proved it. The performance difference is low. So I have now taken care of the biggest elephant in the room. I'm not talking about me. I'm talking about the biggest elephant in the room. That's your performance, right? So given the fact that there is no performance difference, let's talk about some use cases. Why people use RDM? Well, Oracle RAC requires RDM. Who told you? Who told you Oracle RAC requires RDM? Oracle RAC doesn't require RDM. Reason being, if you were running 9i, Oracle 9i on VCS or HP Service Guard, right? Or AIX, what's that from IBM? HACMP, right? Yes, you then need, because those cluster where they require to send SCSI 3 persistent reservation to the disk. If you fall into the category, probably you need RDM. If you're not, then no. My friends, you don't need RDM, right? Because Oracle Clusterware does not do SCSI 3 persistent reservation. It does something called a stone it. Stone the other node in the head. That's what Oracle does. So, if I don't need SCSI 3 persistent reservation, why do I need RDMs for Oracle databases or Oracle RAC? Well, Microsoft Cluster requires it, but we eliminated that, right? With Cluster VMDKs, we solved the problem. So, why do I need RDM? Well, NPIV, sure. I don't know how many in the audience does NPIV, but if you are still doing NPIV, good luck with you, right? You guys can use RDM. All I'm trying to get to is you don't need RDMs, right? Third, noisy neighbor. RDMs eliminate noisy neighbor. I agree. RDM eliminates noisy neighbor. VMDK does not. It does have problems, but how about vVols? Doesn't vVol eliminate your noisy neighbor? Because vVol at the end of the day is a volume, is a volume, is a volume. Is a LUN, is a LUN, is a LUN. vVol eliminates the problem. Great. Second, I start talking about granularity of operation, right? I just gave you a use case here where I'm able to say I just need to take a snapshot of a VMDK or a virtual machine, clone it, and bring it back in a couple of minutes. So I get the level of granularity when I use vVol, right? Third, number of devices. And how many people have faced this problem of 256, 512, 1024 SCSI limit? How many people? Everybody, probably everybody, right? With vVol, you don't have the problem. With vVol, SCSI vVol, the limit is 4,000 per ESXi servers. NVMe vVol, 1,000. Really, would you go beyond 4,000 devices? Probably may in a couple of years, right? But isn't that much better than 1024? So case in point being, you guys don't need RDMs. Welcome to the vVol world, right? And I'll tell you how vVol solves your problems. Let's talk about Oracle backup. And again, wherever you see this word Oracle or database, you can just take Oracle out and put SQL. It just works. Maybe the commands are different, but the methodology is still the same. If you guys are running SAP, do the same thing here, right? I'm just using Oracle as an example to show how vVol makes your day-to-day operations easy. Again, you don't have to read the verbiage in the bottom of the slide. I'm sure the slides will be given out to you guys, but just think, you have two virtual machines. You have a database server running on the left-hand side, right? The left virtual machine. You have a media server, right? Call it a media server running on the right-hand side. All I need to do is take a snapshot of one of the VMDKs from that source virtual machine, which has its databases hosted on that. I need to clone it and attach it to the target virtual machine because I need to back it up using NetBackup, Zerto, or whatever you have, right? Help me solve this issue. How would I do that? And this is exactly how I would do. I would just use the plugin from that storage vendor in question. I would point it to the VMDK. So this example was done using Pure. So I'm going to talk in the perspective. I just used the Pure plugin, pointed it to the virtual machine, and said I need VMDK number 4, or I need VMDK number 3, and take a snapshot. It said okay, snapshot taken. And the next screen I would go to, essentially I said, can I clone from the snapshot? Sure. So I made a vVol clone of that VMDK, which essentially has vVol as the underlying storage. I then attach the cloned vVol to the target virtual machine. I'm done. I can then back it up using whatever backup mechanism, right? If you have to do the same thing using RDMs, tell me what you guys would do, right? You would go to the storage GUI, take a snapshot, clone it, and then attach it to the virtual machine. You lose one SCSI ID, correct? You lose one SCSI position. Imagine if you have to do it for all the virtual machines. Say, here you go. You start losing all the SCSI IDs. Well, I could do that using VMDK. Oh, good luck with that, right? Try using VMKFS tools, Power CLI. It just takes a long time. Can I do it? Yes, I can, right? Should I be doing it? No, you don't want to do it because it takes a lot of time. What makes my life easy? vVol, right? Again, this is more of an Oracle thingy here. All I'm trying to say is once you attach that clone VMDK to the target server, you scan the bus, it would just appear as a /dev/sdd1, sde1, sdf1. Your ASM devices, ASM stands for the Automatic Storage Management from Oracle, essentially just a raw device that appears. Bring up your Oracle database on the target server. You have your database running. Low presto, you can do whatever you want to do with that, right? So database backup and restore becomes very easy with vVols. If I don't use a plugin, let's say if I don't use the Pure plugin, can I do it without the Pure plugin or any other plugin from any other storage vendor? Absolutely. But there are some certain manual steps that you have to do that, right? But again, vVol really helps you with any of the day 2 operations. Okay. I am going to talk about the rack virtual machine, right? Hang on. If I have to do the same thing for Oracle rack, right? The current restriction with Oracle rack, I don't know how many people are running Oracle rack on VMware. Anyone? Yep. VMDKs, multi-writer? Probably. So if you guys are using VMDKs with multi-writer, the current restriction is you cannot take a snapshot, right? Engineering is working to fix it, but as of now, you can't take snapshots, CVD, clones, storage vMotion, HCX, vSphere replication, KB article 1034165, right? Or if you're on vSAN, it's 2121181, right? I have those KB articles memorized. So those are the restrictions that you have, right? But with vVols, what you can then do is, at the end of the day, it's just a vVol under the cover. You can use the GUI, the storage GUI, to clone it up, right? The same way as you do with RDMs. The reason why I keep coming back to RDMs, I want you guys, if you guys are using RDMs, to get off RDMs. No more RDMs. RDMs is not your new best friend. vVols is your new best friend, okay? All right. If I have to do the restore, this is exactly how I would do the restore. I have a clone of the virtual machine. I'm just going to clone it back and I'm done, right? So this becomes easy. This is where I need to come to. How many people support their Oracle DBS when they have to do database cloning? I'm sure you guys must be doing it, right? The Oracle DBS come to you and say, I need a clone of the virtual machine. I need a clone of this 2 terabyte, 10 terabyte, 20 terabyte. Please do it. And this guy says, okay, sure, I'll do it. He starts doing a snapshot. The clone runs for an hour. The Oracle DBA comes back after his or her lunch. Says, you're still doing it? Is it still going on? Oh man, I wish I had used RDMs. And you're like, oh, I don't want to give you RDMs because I run out of SCSI limit, right? That's the challenge we have here. What if we had a vVol? What if we had a vVol, right? When you had a vVol, because remember, when you have a VMDK, underneath the VMDK cover, right? Whether if it's VMFS, whether it's iSCSI, whether it's NFS, whether it's block, FC, NVMe or Fabric, RDMA, TCP, I really don't care, right? Whether it's vVol, a VMDK is a VMDK is a VMDK. So whatever you want to do with the VMDK is still, you can do it, right? vVol helps you. Because what happens is when you take a snapshot of the VMDK, you have a snapshot of the VMDK or you have the clone of the VMDK, attach it. So you are now able to avoid that RDM evil, and I can definitely say that out loud, RDM evil, and you can then move from RDMs over to vVol. So let me just show you this one, right? Same, I'm going to use the same 2 virtual machines, the source and the target, correct? Ignore whatever I've written in the bottom here. This is mostly verbiage for the Oracle guys, right? But my work or my essence, my exercise of the day is I need to take snapshot or clone of 2 VMDKs which has vVol under the cover, attach it to a target virtual machine, correct? That's pretty much what I would do. I would take a VMDK level snapshot of the 2 VMDKs in question or 4 VMDKs in question, pick and choose what you want to do, attach it to the source or attach it to the target virtual machines, and lo presto, I'm done, right? And I don't know, I don't want to bore you guys with Oracle details, but Oracle has this concept called container databases. How many people have heard of CDBs, container database or pluggable databases, right? See what happens, think of it. I'll give you an example, right? You have a virtual machine with, let's say, 3 databases. If I have to translate that to the Oracle world, those 3 virtual machines or the 3 databases within that one virtual machine, those 3 DBs are what are known as PDBs, pluggable databases. The virtual machine is a container database, right? Your DBA may come back to you and say, man, I just want to just take a backup of one of the PDBs in that CDB, and then you go scratching your head and like, I probably can give him the entire virtual machine. The guy can then go and drop what he or she wants to do, right? That's one way to do it. It works. It just takes a long time. The second way to do it is for you to go and ask him, tell me the VMDKs you want me to copy, and I'll copy that for you, right? So using the plugin, you go basically and say, take a snapshot, take a clone, attach it to the target, virtual machine. He or she is now your new best friend, right? So it solves a lot of these day 2 issues here, right? I'm going to skip over this one, noisy neighbor, right? Same thing up with noisy neighbor. When you have your VMDKs on virtual volumes, right? Remember, these are not RDMs, but this is an RDM. This is a LUN at the end of the day, for crying out loud, right? The only difference being, with RDMs, you have a SCSI ID, a UUID that you can see. With vVols, you don't have a SCSI ID or you don't have a UUID. It does, right? When you start looking at it, it's basically an SLU, a subsidiary LUN unit, right? All you see is just the protocol endpoint on the ESXi server, right? Your vVol would just be 1:256 or 1:255. That's exactly what it is. So it helps with the noisy neighbor. And let me come to the meat of the matter here, right? So we basically said, okay, that's all good. Operational wise, I'm able to, provide a lot of operational efficiency to my customers, right? I don't need RDMs. I've already proved it. I've already proved that the performance difference between RDM and VMDK is probably 1%, right? Or even less than that. A lot of benefits using vVol. But I was just talking about performance, right? Does it really give me the performance that the VMware guys have been claiming that it does, right? So we just ran a test. We said, okay, why don't we just have a virtual machine running on vVol, virtual machine, same VM, running on RDM. Let's run a workload, correct? And when we run a workload, let's compare the results. Again, disclaimer here, right? The numbers you see will be completely different than what you get in your environment, because I ran a synthetic workload generator, which means if I see X, when you go back and run it in your beefier servers, you'll probably see 3, 4, or 5X, right? But back to the thing here, I used a load generator called SLOB. SLOB stands for what's known as Silly Little Oracle Benchmark. It's called Silly Little Oracle Benchmark. It's written by a guy called Kevin Clausen, right? If you guys can Google him. He's the guy who wrote the Oracle Disk Manager, ODM, right? He's a very brainy guy. So he basically came up with this load generator, right? The whole essence of this exercise was try to hit that LUN as hard as possible, correct? So I don't want to have any logical reads. Physical writes, right? I want to tax the volume, the VMDK, the vVol in question, and see how much physical writes can I get. So that's exactly what we did. From an ESXi level, from a guest operating system level, from even an Oracle level, right? We see that the metrics are far much better on the vVol side than what you have on the RDM side. And if anybody in the audience is kind of wondering what this guy is talking about when he talks about execute per SQL, anytime you guys go talk to your application owners, right? You talk to your Oracle DBA, SQL DBA, the guy would say, or he or she would say, well, you know what? My number of transactions went down. I'm not able to run as many SQLs as I was able to run 2 days ago, right? I need to increase the number of logical reads. I need to increase the number of physical reads. See, these are metrics that's very important for any application person. Oracle DBA, SQL DBA, no difference, right? What we saw was the execute SQL per second. That's a metric we use to track the performance of an Oracle database. That increased, right? So again, from an ESXi perspective, virtual machine perspective, OS perspective, database perspective, all I saw was a win-win situation when I used vVol as compared to RDMs here, right? Again, the first test was with just one VMDK, right? With one VMDK, compare. Then I said, okay, how about 2 VMDKs? Can I just scale it up, right? With 2 VMDKs, I saw similar performance as well. Well, you know what? The madness can stop here. I can probably have 3 VMDKs, 4 VMDKs, I can keep going on. But I think I've already made my point here, right? With virtual volumes, performance, you are able to get as you are able to get it, or probably a bit more, or probably a lot more, not a bit more, a lot more with RDMs. Patching made easy for you. I'm not going to go very deep into this one, right? Refreshing, but let me just come to a. All right. But even with that, even before I wrap it up, and I know that we do have some time for questions as well, right? So I just want to get a couple of poll questions out, right? How many people are still using RDMs? RDMs, right? Is there a need for you to use RDMs? I just want to understand the use cases here. Good. Let's talk about that use case. The gentleman here said, well, I had an Oracle database sitting on a bare metal server, correct me if I'm wrong, and I had to move it over to VMware, and hence I use RDM. Great. You should only be using that as a cutover. Once you cut over, you really don't need an RDM because you could then do that as a vWall. See, in fact, there's a guy called Cody Hosterman. He's very popular. You guys know who Cody is. I don't have to introduce Cody to him, right? His blog site, awesome. I read his blog sites, right? His blog site basically talks about how an RDM can be converted to vWall and vice versa. So if you have an RDM, for example, your use case could be, I have physical Oracle rack sitting on a bare metal server or bunch of bare metal servers. I just want to move that, right, from point A to point B. Here's what you can do. If I have a 2-node Oracle rack sitting on bare metal, what I can do is then I could create 2 more virtual machines, right? And I can have VMDK sitting on vWalls, right? I can add this virtual machine over to this node, right? So I have now 3 rack nodes. I can add this virtual machine to the same rack cluster. So now I have 4 rack nodes. I shut node 1 down. I shut node 2 down. I probably should have been a magician here, I'll tell you. Right? So I have 2 rack nodes running on, and essentially the way you shut it down is you remove this instance from the rack cluster, right? I'm just trying to prove a point that you don't need Oracle RDMs, you don't need RDMs for Oracle rack cluster. Again, let me just stress, Oracle does not do SCSI 3 PR. So if you go back, and if anybody says, wake you up in the middle of the night, Oracle does SCSI 3 PR, the answer is no, it does not do that, right? No, it does not do that, right? Because all it does, it just says, stone the other node on the head, right? So when you don't have that use case, you don't need RDMs for that, right? Again, with vWalls, single instance, Oracle rack works like a charm. We spoke about cloning, we spoke about patching, refreshing. I didn't really want to bore you guys with this entire refreshing and patching thing, but yes, if you guys are interested, more than happy to go through it. The most important use case that I see from a VM admin perspective is the backup, the restores, and the cloning, right? How many times people have come to you and said, okay, clone me a virtual machine, right? Or clone me this database, and then he goes scratching your head, okay, I got to clone an entire virtual machine for this guy, right? If you are able to identify those VMDKs on vWalls, you are able to do that. And let me quickly move on to the, if there's anything that you think is useful from this session, I think this slide is the most useful thing in this session because pretty much anything that I produce, Oracle on anything, Oracle on vWall, Oracle on VMFS, iSCSI, NFS, NVMe or Fabric, right? NVMe vWall, once that's announced, or even let's say performance best practices, rack guides, business continuity, disaster recovery, Oracle and cloud, Oracle and VMC, Oracle with this, Oracle with that. Everything finds a home here, including Oracle licensing. So if you guys are interested in even that topic, feel free. Go in here, and like I said, I will be there at the Expo booth, right? Come all the way to the end, hunt me down. If you have any questions, more than happy to talk to you about it, right? Whether it's a licensing question or whether it's a technical deep dive. If it's licensing, you guys have to buy me a drink, right? I gotta be drunk enough to start talking about that. If not, it's fine. You guys don't owe me anything. But apart from that, thank you for coming. If you guys have any questions after this, please talk to me. All right? Thanks. Bye. All right, so let's get started. So this is going to be a very short session. So I probably can do this blazingly very fast if you guys are able to catch on, right? With my speed, I'm from India, so I talk very fast, right? We can either do that, or if we want to do some question and answers, we could even do that as well, right? So it's completely left to you guys. I know this is a very small audience, 2 people. So again, essentially we'll be talking about migrating, architecting Oracle workloads on VMware platform. I'm sure you must have gone to these different sessions, right, where they talk about VMC, VMware Cloud on AWS, you have GCVE, OCVS, so on and so forth. But I'm going to talk very high level on the methodology, because if I have to do a deep dive, it'll probably take me 6 to 8 hours, right? We used to run workshops in previous, VMworlds, where we used to talk about moving from, let's say, AIX, Solaris, HPUX over to x86, inculcating all these best practices, making sure you performance tune, bundling, packaging it up, moving up to the cloud, making sure that you do the same due diligence when you go to the cloud, right? So that if you have to come back or if you have to run your workloads, right, you're able to sustain the workloads. So again, like I said, 15-minute talk, not much time, but I'll try to do the best as I can, right? And again, I'm going to move here. So this is typically a slide I've been using for the last 12 years, and one may wonder why I've been doing that. Just to stress, or just to, let's say, send a point home that any process or any Oracle design methodology starts right from the top, right? So you gather requirements, sell the project to stakeholders. You got to understand your current problems, because if you don't know that, when you move to the destination, which is VMware, the same problems are going to persist, right? And when you do that, workload management or workload measurement, why? How can you control the beast if you don't know the nature of the beast? You got to know the nature of the beast, right? So you measure the workload. Then you have to move the data from point A to point B. Data moves to point B, which is VMware. You do your testing using either a synthetic workload generator, or let's say the Oracle RAT, which is the Oracle Real Application Testing. You do that, inculcate best practices. And once you're happy with that, you make sure that the vSphere cluster is good enough for Oracle support and licensing, right? And I just said that in my previous session. You guys want to talk about it? Sure. You got to get me drunk enough to do that. But I will talk about licensing as well. Considerations for sizing, you have your backup, restore, recovery, HADR, monitoring, tuning. But can anybody just raise their hand and say, oh, well, we need to do this for VMware? I mean, apart from the whole Oracle licensing nonsense, right? I don't think there's anything that you guys have to do specific for VMware. So again, case in point being, really nothing changes when one virtualizes their Oracle workloads on a VMware vSphere platform. Let me say again. Nothing changes when one virtualizes Oracle workload, because people typically, they come up to me, customers, partners, they say, well, if I'm moving my workloads from Solaris to VMware, I got to do this, I got to do that, I got to do my best practice, so on and so forth. You don't have to do it. Don't do your best practices, right? It'll work like a charm. But here's the thing. It won't do what you expect it to do. If you are expecting it to push 100,000 IOPS, no, it won't do that. See, that's the reason why one wouldn't go to the market to buy a single port HBA, right? And basically access it to one side of the fabric and say, I'm done. But nobody would do that, right? You are setting yourself up for failure. Similarly, there are best practices that needs to be inculcated in every thing of the stack. And that's typically a thing I show people, right? If you don't have a good infrastructure, no way in hell your Oracle workloads are going to scale up, right? And again, wherever I say the word Oracle, you can probably take it out, put the word SQL, put the word SAP, because this methodology is no different for any business critical application, right? How do I start doing my workload plan and design? What do I do, right? Well, you have 2 choices here. If you look to the choice on the left-hand side, essentially that's a pick and drop, which means I'm getting booted off my data center in 15 days. I don't have the essence of time. I really don't have time to do it, or I don't want to do it, I'm lazy, right? What I'm going to do is I'm going to say, this server, 2 socket, 10 cores each. Well, this virtual machine is 20 vCPUs, move it. Will it work? Yes. You know what? You've just finished your replatforming. What's the cons of it? Because there are pros and cons to every approach in life, right? What's the cons to it? You end up 6 months later, when you do your VROps or ARIA, you call it ARIA, I'll call it VROps, right? But when you do it 6 months later, you end up with this bunch of servers that you don't know what you want to do with that, right? Pick and drop, garbage in, garbage out. The approach to the right-hand side is workload plan and design. But how do I do that? What metrics do I use? What tools do I use, right? Too many. Okay, all right. Again, when you start measuring your workload, 2 ways to do it as well. You can approximate it. Goes back to the same example I gave, right? I can give you another use case. My CIO basically said, I don't want you to do this science project. Just tell me the number of servers you want so I can budget for it, right? In which case, you need to go back to your business and ask them, can you identify a peak business period? Your business could be Monday to Friday, 9 a.m. to 5 or 9 a.m. to 5 p.m. in the evening, correct? But then your workload would be very heavy from, let's say, 9 to 11 in the morning. I would pick 3 days or I would pick 5 days. I would point live optics to it. I'm sure you guys must have heard of live optics, right? It's a great tool. If not, it's free. You don't have to pay money for it. Works like a charm. Please use it, right? It gives you general utilization for those 4 quadrants: CPU, memory, disk, and network. Good? So now you can go back to your CIO and say, I think we probably might need 200 of these servers, so budget X amount of dollars. That helps you. Approximation. If you want to do a deep dive into finding exactly how many servers you want, you need a second way of doing it, wherein you use something from Specint. How many people have heard of spec.org? Specint. So spec is basically a standard that the industry has developed. They basically say, right, for this generation of servers having so many sockets, so many cores, clock speed, right, there is a peak value and there is a base value. It's just a number it throws out. Essentially what it does, it runs Fortran, Pascal, or any other language, right, compilers against the CPU, because it wants to see how much is it stressing the CPU and the L1 and the L2 cache, correct? So just go with the base number. Let's say the base number is 100. And let's say your choice for the vendor is Cisco. I'm just picking something from thin air, right? Or HP. What I would then say is these set of servers matches these set of servers. So if it is X, I probably need Y, right? That's a universal set. Zoom in. Using Oracle AWR, AWR stands for the Oracle Workload Repository. Every intelligent system in this world will take a snapshot of itself at every predetermined time. Oracle is no different. It does that as well, right? You would use the Oracle AWR, right? And that's typically what CIOs or directors would do. They will just come to you and say, you know what, can you tell me what happened at your Oracle database between 9 to 10? I knew something was going bad, but I can't pinpoint it. Oracle DBS basically use AWR. They will use that report and they'll come back and say somebody ran a bad query or a nasty query, and that's what brought the entire call center down. So what you use for triaging is also being used for performance tuning, right? So you will use the Oracle AWR along with the Linux system stat. How many people know system stat? Probably everybody. You guys are all Linux guys, right? Windows guys. So Linux systat, the utility, gives you the command, the utility, the SAR, right? When you run the SAR command, you are now able to marry the Linux statistics along with the Oracle statistics, combine that with the Specint, out pops a straw man for a virtual machine, right? And that's the approach you would use if you're moving from AIX, HPUX, Solaris, Exadata, ODA, another virtualized platform like OVM, Zen, KVM, whatever. This is the thing that you would use when you move in from that platform over to VMware. There's a bit of a nuance. There's a bit of a nuance here when you move from, let's say, AIX, HPUX, Solaris, right? There is this whole concept of big endian. How many people have heard of big endian? Not this guy, big endian. Not Indian, endian. Yeah, so the big endian essentially is this, right? You have your most significant byte and the least significant byte, right? That's how a big endian system looks like. From a little endian, which is your x86, your Linux, your Windows of the world, it's a flip, which means you cannot cut, copy, paste, or do a Control-C, Control-V, suck the data in and spit the data out. You can't do that, right? You gotta use the Oracle way of doing it. So it has to be the Oracle migration tools. Whether that's your data guard, RMAN, backup restore, create table as select, pick your favorite tool. You have to do it that way, right? So what we did here, right, in this brief 15 minutes, we designed a virtual machine based on the current utilization of network, disk, CPU, memory, correct? We suck the data in, we put the data here, but, sorry, the buck doesn't stop, because I need to make sure, I need to inculcate best practices in every level of the stack, right? So I was just telling the previous crowd here, we basically used to run these workshops for 6 to 8 hours where we used to beat the entire performance stuff to death, right? We used to talk about it in detail. I can't do justice to that in the 15 minutes that we have here, but yes, you need to inculcate every performance metrics, right? Every performance best practice. For example, people say, use 4 PV-SCSI controllers. Why? There's a reason why they say that. Load balancing, queue depth, fairness, VMX Net 3, queue depth, NUMA, right? Memory reservation, probably yes and no, right? So those are some of the key concepts you have to keep in mind. But again, I'll just give you an example here, right? If I have to design my Oracle database on VMware, this is probably how I'll do it. This is just one of the ways I would do it. This is not the way, this is just one of the ways I would do it. And what I want to highlight here is I have load balanced my VMD case across all my 4 PV-SCSI controllers for the same load balancing reason here. And if I have to do an Oracle rack, I'll just add my CRS and my vote to the last SCSI controller. Low presto, I'm done. This is important. Many customers, they fail to do this, right? Once they move it from point A to point B, they kind of assume my work is done, right? Let's just go and party. You can in Vegas, but after you do your job, you have to measure the workload, correct? You have to test it. How do you know it's going to scale? You have no idea it's going to scale up, right? Again, you have a choice here. You can either use the Oracle RAT, which is a very expensive tool from Oracle, but a great tool. It's real application testing, right? It captures all the sequels and replace it on the target. You could do that. Or if you don't have the tool, you could use your swing bench, your HammerDB, the Orion, IOmeter, DD, FIO, or even slob. I mean, I favor the slob. It's still a little Oracle benchmark. But case in point being, you are able to know exactly how much your workload is pushing. See guys, at the end of the day, it's not about benchmarking, right? If I were to tell you this architecture is going to push 1 million IOPS, what are you going to do with that, right? Because that's not how much your workload is pushing. Your workload may be pushing 1,000 or let's say 100,000 IOPS. If so what, if a system pushes a million, that's not what you're after. You're after how much my workload is pushing. So these best practices needs to be kept in mind. And I've been told I just have a minute to wrap things up. So when you spread your wings and fly to the cloud, you have a cloud of your choice, whether it's VMC, GCVE, AVS, OCVS. Every cloud vendor is different. There are pros and cons to that. Depends upon the choice of the cloud and the kind of analytics that you want. For example, if I need to go to, if I'm an Oracle guy, and if I want to go to a cloud, I'll probably go with OCVS because I have autonomous transaction, autonomous database, right? That doesn't mean OCVS is great for everybody. You can go to VMC, GCV, and OCVS. But the best practices does not change when you move from on-premise to the cloud, right? And I think, how many more minutes? Seconds? I got to wrap it up. But here's the thing. Let me just make two quick statements. I will be there at the Expo booth, right? CIBG, come find me. If you guys want to have a deep dive, we are giving sneakers away, 4 sneakers. If you don't like good shoes, you don't like sneakers, give me a ticket, I'll take it from you, right? But we're giving that away. The drawing is at 4:45. But if you guys want to talk about licensing, you got to buy me a drink. If not, everything is free. All right? Good? Thank you.
Thank you. Hey, everyone, thanks for your time today. My name is Girish Manmadkar. I'm a part of the product management team supporting and working with cloud solutions provider, or we used to call them as VCPP. Today, I'm going to talk about Kubernetes as a service powered by VCF and VCD, which basically is a foundation that you probably heard yesterday under a private AI foundation. So as a part of that, I think discussion, there was something called as a kubeflow VMware edition that was also discussed. So, we see a lot of PowerPoint. So I just thought of tweaking my session today from PowerPoint to the actual real life of running kubeflow on this architecture. So with that said, I think I just wanted to move forward with a few slides and then we'll dig into the actual demo. Have you heard about CSC or Container Service Extension? No? So this is kind of based on cluster APIs powered with Cloud Director. Cloud Director is basically my multi-tenant portal or multi-tenant application, allowing me to have another level of abstraction to really deliver various components of my infrastructure and additional services using Cloud Director. Mostly, it is consumed by VCPP or Cloud Builder or cloud providers globally. We got about 4,000 of them. But essentially, it's idea about there is a view and a control that you have as a provider, and then there is a view you as a customer, because you don't want to spend time and money on managing your infrastructure or services. These type of services can be delivered by the provider, and the provider will have everything managed for you so that you can focus on your business to run your applications on this particular platform. So there are benefits as a provider when it comes to VCD and CSC. So CSC is like a plugin of flexibility that we brought it into VCD in terms of providing these plugins. So it becomes a plugin into VCD. Essentially, I'll show you, you drop down a menu and you can deploy the tons of Kubernetes clusters seamlessly, right, as a customer. But again, for the providers, it's a simple interface. It's a simple way of delivering it as a service from a UI to the CSC server. So it's a small component that goes into the management cluster called CSC appliance. And basically what we are trying to do with the new architecture based on cluster API, decoupling from the tenant workloads and allowing tenants to do a self-management of those workloads easily. A lot of things have been talked this week about, AI, ML workloads, doing a lot of stuff around it, making sure that VCD is already enabled for the GPU as well. So it allows you to consume GPU. You can build GPU as a service as well, right? And another thing that we have done, like in terms of from the provider point of view, from the operations point of view, to do a lot of syslog forwarding and deliver those type of services. So key components of service extension in a multi-tenant view that you can think about: support server K8 clusters with the release of 1.4 to 1.5 versions and onwards. So a lot of flexibility, and we keep on reinventing the wheel to make sure that we are able to deliver an ability for you to deploy latest and greatest versions of Kubernetes clusters. If you have a customer who wants to be an air gap, absolutely, we have a way to support that, and maybe using proxy or without proxy, you can download those various templates that you want to and deploy it into your VMware Cloud Director and make it available to your customers. High availability is already there, and we can talk about it as we move forward. It is based on VCD and CSC architecture. VCD is already allowing you to have an availability maybe in a multi-site or multi-zones. You can build that availability. Cluster auto-scaling is a key feature. We don't want to have upfront any of your infrastructure to be consumed. You want to make sure that cluster can auto-scale. A cluster is basically my Kubernetes cluster. It is not the infrastructure cluster that we are familiar with. Again, automated health checks are being built, and in-place upgrades are the key aspects of these clusters. So we want to make sure that we work with you as a customer, as a provider, and we bring those functionality into this kind of products. Let us have a look in terms of what container service extension looks like as a provider view and as a tenant view. may not be clear, but I think if you really look at it, the blue one is basically where I'm hosting all my components in my management cluster, and the light blue colors are basically where I'm consuming it as a tenant. Little bit difficult to interpret this, but I think I'll show you in a demo quickly what it means. As a part of my extensions in VMware Cloud Director, we are able to also deliver various data services. A lot of time, database administrator comes and say, hey, I would like to have a database instance and things like that. So we want to make sure that through VCD, you can deliver a database as a service or various data services that we have. It could be a VMware SQL, NoSQL, RabbitMQ, or Gemfire. We are kind of announcing as well as we move forward with the new additions. If you have a customer who wants to run large language models with NVIDIA, absolutely, you can definitely do it. Greenplum and as well as Kafka. So we are adding more and more features to container service extensions to make sure that the complexity is taken out of your customers or out of your developers' mind. It is all done through delivering it as a service to your end customers. Could be a developer, right? And these are the benefits as a provider. And being an IT could be a provider to your business units, right? Depending on how you do it. So MongoDB, recently we announced it, and definitely you can have an easy way to deploy your MongoDB based on all the automation that we have built in. And again, it has its own open API support, so we are not debating anything. So there is easy way for you to deploy these services using container service extension, which works with VMware Cloud Director, and it's a TKGM flavor that you can think about. With that said, I'm going to go and switch quickly into my demo. Thank God it's not disconnected. So what you see here, a typical view of a virtual center server, right? And if I click here, that I have a small 4-node cluster deployed. Oh, sorry. Okay, I think, hold on a second. Okay, now I think you can see it. Okay, can you see it? Thank you, thank you. Just want to make sure that I'm completed in 15 minutes with demo. If you look at the screen, which is typically a vCenter server screen that you probably are familiar with, I have a 4-node cluster that I've deployed, and using my TKGM CSC flavor, I'm able to deploy various workloads or clusters. So if you look at it here, I have a cluster deployed as, let me go double click here more. Yeah, so under VMware Cloud, I have ECS large cluster deployed, which has a control plane, and I have worker nodes deployed. Being a small environment is a nested environment for me, so I have to play with those resources, right? So I was able to deploy a Tanzu Kubernetes cluster as a large model, and then using that large model, that cluster, I was able to deploy the kubeflow, which is the MLOps application that you heard about it yesterday. Do I have GPUs on this? No, this is nested. But the point here is that kubeflow that you saw yesterday, it is not a paperware. It is actual thing, it is there, and that's the reason I wanted to make sure that you see it to believe it, right? So what I have is a provider view. So provider will have access to a virtual center server. Let me go and show you another view, maybe an application that I wanted to run. I may have it already running here. Yeah. So I'm running it as a tenant, and in the tenant, I was able to deploy a Tanzu Kubernetes cluster. So I am actually what you are seeing on the screen as a tenant, as a customer, as a DevOps engineer with the UI that allows me to deploy a Kubernetes cluster seamlessly. It's taking time because network connectivity is a little bit shaky. Hopefully it goes fine. But until it pops up, what I'm showing it to you on the screen is that I was able to deploy ECS3 large cluster. It's a Kubernetes cluster, there is no application on it, right? So once you deploy this cluster, you can go and configure by downloading the kubeconfig file. Once you download kubeconfig file, you can attach to this cluster using PowerCLI, we're using all the standard commands. and then you can deploy an application as a Kubeflow. So I was given a warning of 2 minutes, so I'm just going to show you what I've done. So what you see here is an application that I was able to run with some use cases here actually. And the execution, if I want to show it to you how it is, yeah, so here you go. So this application is deployed on that cluster, ECS3 large cluster that was deployed. One control plane with 2 worker nodes. I was able to get this Kubeflow deployed within few minutes, less than half an hour actually. If you are familiar with all those kubectl commands and everything, you just have to follow the documentation and you can get it running very, very quickly. So that's a point that the platform that I was talking about is ready for you to deploy and manage AI ML type of workloads seamlessly. As long as you have the GPUs behind the scene, you can expose them to your Tanzu Kubernetes cluster and deploy the applications very, very quickly. If you have any questions, I will take it offline, but thank you for your time and I hope you are able to get something out of this session. Thank you.
All right, so let's get started. Can you guys hear me in the back? Louder? More louder? That's good enough? Okay, great, good. And you guys have to put up with me for the next 7.5 minutes or 8 minutes. I'm going to talk real fast because I got another session, but I'll have Arvind cover the nuances of memory tiering, right? So welcome to today's session where we talk about capacity and providing capacity and TCO, right? To applications using the VMware software memory architecture of the framework, right? So my name is Sudhir and I have my compadre, my colleague in crime here, Arvind, right? And he's going to bring up the rear and he's the product manager for memory tiering. So if you guys have those questions, save it for later. Hound him, ask him everything, right? Don't ask me any questions, but if you do want to talk to me, come to the exhibition hall, right? There is a draw at 4:45 for a pair of, I think there was 4 sneakers. Beautiful. If you don't want it, just give me a ticket. I'll take it. I love free stuff, okay? Good, done. All right, so we talk about the motivation, right? And let me start with the motivation as to why one should even go with memory tiers, right? I mean, you guys are VMware. You've been using VMware technology for so many years. I'm not going to insult you by talking about vMotion, DRS, and so on and so forth. But let's just assume things works, right? And we can take it for granted. And I'm going to move to the VMware memory tiering aspect of this discussion where, and there's a reason why the memory tiering is so important. See, what happens is, with the advent of Intel DC opt-in, and I get it, right? Intel DC opt-in is gone, right? At some point of time, we're looking at CXL, and Arvind will be talking about CXL use cases here as well, right? But the value proposition of tier 2 memory is very important, right? If you want to solve this problem using hardware, of course, Intel had that memory mode where you have the hardware, the tier 2 memory, you had DRAM, and you had some kind of caching happening there, right? What happens is if you were to defer that kind of mapping, the cold and the hot blocks to the VMware layer, we do a much better job at doing it. Reason being, we know your workloads much better than any hardware will know your workloads, right? So by throwing a blanket of abstraction between these disaggregated components of memory tiers, we are able to provide a much bigger contiguous memory chunk which comprises of DRAM and tier 2 memory. So from a application perspective, that's what an application guy needs to know at the end of the day. I need so much amount of vCPU, I need so much IOPS, I need so much network, and just give me some chunk of RAM. I really don't care where it comes from, but make sure that my hot blocks and the cold blocks are taken care of by VMware. And VMware says, absolutely, let me throw the blanket around for you and let me do that, right? Again, I'm going to come up with a use case here, and you can extend this use case to the SQL of the world, the SAP of the world, the Java of the world, or whatever you have running, right? Simply search and replace Oracle, and that's it, your problem is solved, right? But I was joking about it. So I'm going to give you a bit of a use case here. Essentially what happens, and I did speak to it, right? VMware vSphere has that intelligence to map that cold and the hot tier and do that mapping, right? So let me cut to the chase. Let me cut to this. What we did was, we did a lab study, right? It was a lab, it was a controlled environment. So we had 2 ESXi servers, right? The server on the left-hand side here, right? And the server on the right-hand side, set up exactly the same. 4 socket, 24 cores per socket, which means 4 NUMA nodes. Every NUMA node having 24 cores. Every NUMA node has 384 gigs of DRAM, 768 gigs of tier 2 memory, which means 1.5 terabyte DRAM, 3 terabyte persistent memory. Good. So we have this server here on the left hand side. Server to the right hand side, set up exactly the same. ESXi patch, version, everything. 24 cores per socket, 4 sockets, 1.5 DRAM. But hey, it doesn't have tier 2 memory, right? So no tier 2 memory, yes tier 2 memory. Let the games begin. And what we did was, and this is a bit of an illustration as to how NUMA looks from an ESXi perspective. Back to the point here, you had 4 sockets, like I said. Every socket had 384 gigs of DRAM, 768 gigs of tier 2 memory, and you will see where I'm going with this entire illustration here, right? In the next slide. What we did was, and again remember, this is to prove that you are able to increase the capacity and achieve good TCO, lower TCO, when you start piling on tier 2 memory to that memory bank. So where you don't have to dip into your pocket when you go to the market and buy expensive DRAM, right? I mean, how many times you have to go back to the IT department saying, well, you know, you guys gave me 512, that's great, I need a terabyte. Well, you guys gave me a terabyte, I need a 2 TB. And the guy says, why don't you come back and talk to me a month from now? Let me just open up a PO or a requisition order, and you got to pay so much of money, right? What if I had tier 2? What if I simply had tier 2 memory, which is slower, which has a higher latency, but when you look at the overall picture, I am able to run more workload. See, at the end of the day, it's workload, workload, workload. Run more workload, run more aggregated workload. If I'm able to do that, my problem is solved, correct? And that's what we're trying to do here. So 2 virtual machines on the software memory tiering side, correct? 1 such virtual machine on the non-software memory tiering side. And what we did was we pinned this virtual machine to NUMA node 0. One may ask, why did you pin it? Because I don't like the NUMA affinity and all that stuff. I wanted to dispel with the NUMA noise, right? So 2 virtual machines pinned to NUMA node 0, 1 virtual machine pinned to NUMA node 0 for the DRAM as well, right? 2 on one side, 1 on this side. And this is exactly how it looks if I look for the entire stack. Oracle, virtual machine, vSphere level, if I look at it, this is how it looks like, right? And basically, my goal here is to see if I'm able to get aggregate throughput, if I'm able to get aggregate performance, right? If I'm able to run more workload, more transactions, more SQL. See, what happens is, the world that I come from, the Oracle world, if you guys talk to the SQL DBAs, right? Or MongoDB, Cassandra DB, they'll basically throw things at you like, I was able to run more transactions per second. I want to run more SQLs per second. I want more logical IOs. I want more physical IOs. Or I want a lot of stuff, right? As well. But that's basically what your SQL or your Oracle guys will tell you that. And that's exactly what we wanted to find out. Can we get more execute per SQL when I start piling all this virtual machine? And the answer is yes. The load, the synthetic load generator that we use here, it's called SLOB, stands for Silly Little Oracle Benchmark. The only thing it does is stresses IO, whether it's memory or whether it's to the disk, right? Again, this is the read-only test that we did here. If you look at the aggregate software tier, which means you're putting virtual machine 1, virtual machine 2, the metrics come out much higher than what you would on the DRAM case. And probably one of you would stand up and say, oh, it's so obvious, man. You're piling up virtual machines, right? You will get more SQLs per second. Exactly. That's what I want to do. That's exactly what I want to do. I don't want to spend money to go buy expensive DRAM. I'm cheap. I want to buy cheaper tier 2 memory. I want to have more aggregate memory. I want to pile on more virtual machine. Let's say it's a dev test use case or a functional or a non-prod use case. Run a lot of VMs, right? I don't have to go back to my manager and say, give me more servers, give me more RAM. That guy is happy and I'm happy, right? So that's the whole thing for today. Again, the ball doesn't stop here. If you just look at the Oracle from an Oracle perspective, you also have to look from a guest operating system perspective, right? Most of you guys are Linux guys, Windows guys, right? So you know the percentage idle. You know what percentage idle stands for, which means I'm doing nothing from a guest operating system perspective. Give me something to do. When we ran virtual machines on the software memory tiering, because the hypervisor took care of the memory block, the shifting back and forth, the guest operating system had more idle cycles, which means if I was able to run X, I can probably run X plus 2, right? Or even 2x or 3x or 4x. So case in point being, with the intelligent tiering handled by the hypervisor, now the guest operating system, the Oracle database, can basically do what it is born and bred to do. Run workloads, right? I don't have to worry about thinking, oh, where are the cold blocks? Oh, where are the hot blocks? Maybe I need to do this, maybe I need to do that. That's what Arvind, his team, the memory tiering team does, and me as an Oracle guy, I just have to worry about saying, I just need so much amount of VRAM, and that's it, I'm done. Arvind, you worry about the memory tiering aspect, right? And this is where I'm going to hand off to him. He is the SME on memory tiering, and he'll talk about that. Thanks, Arvind.
Thanks. How are you all doing? I lead some of the product management efforts. I think I'll have to scream a little more because I can hear the guy next to me talking louder. So I'll have to really use a higher voice. I'll have to outcompete him. And I think this is the best time to do a session like this because, you know, this is Vegas. Everybody is, you know, there is a hangover time in the morning and then everybody starts waking up really, you know, at this point of time. So this is perfect. So thanks for attending this session. And, you know, I'll be talking a bit about, you know, what is the motivation, right? So if you look across the board at some of the VMware customers, a lot of our customers actually end up overcommitting memory, right? I mean, because they want security. I mean, they want some insurance. They don't want to be in a position where they see that their workloads are, you know, actively using a lot of their memory and then they run into performance issues. So what they end up doing is, for the worst case scenarios, they actually end up overcommitting their memory and over provision it, right? So now we have a situation where, maybe 90% of the time the memory is just sitting idle, right? Because what we have seen from most of our customers is that most of your workloads active memory, which is, actively being used, is just about 50 to 60% of your overall capacity, which means that at any point, if you look at your workloads, it's only using 50% of the overall memory actively. So, which leads to the point that, we can really make use of a memory tier, which is slower, less expensive, and which can save costs for you, right? I mean, I don't know how many of you know DRAM is expensive. Show of hands, did you all know that DRAM is the most expensive components in your server infrastructure? Okay, so that's good. Actually, a lot of you know that DRAM is very expensive, right? So now this brings me to the point why we need like a memory tier, right? And VMware is the right platform because, it virtualizes everything. Like Sudhir mentioned, you basically, don't even have to bother looking underneath, right? I mean, ESX as an operating system, as a hypervisor, manages all the tiers, and it makes sure that it just gives you a big memory, right? And which you can allocate to your VMs. And for each of the VMs, we monitor closely what kind of workloads are running, how they are using the memory pages, and how you can actually tier the cold pages to a slower tier, right? And then bring the hot pages to the faster DRAM, right? So that's what we do. And if you see, the other point in this is that, for a lot of you, we have found that, across our customer base, CPU is actually, you have spare CPU capacities, right? So what that means is that, there is a memory CPU imbalance, right? And memory tiering can bring that imbalance and and correct it, right? In the sense that now with the second tier, you could actually bring that imbalance and correct it, and then now you have CPUs being utilized really well, right? So that's the other benefit. You not only save costs, but you are now utilizing your CPUs really well, right? So that's the main benefit here. Now, this is, a sample cost reduction, right, with memory tiering, right? What we see here is and this is a real configuration that we used from one of our OEM partners, right? On the left-hand side, you see that there isn't a tier, and this is pure DRAM, right? And it's simple math. I mean, you see that if you remove half of some of the DRAM capacity, half of the DRAM capacity on the right, you see that, now you are ending up saving a lot of costs, right? And we can see that with, we actually started seeing that with, when we did Intel Optane. But unfortunately, Optane is gone, and, now we are coming up with new schemes for doing memory tiering. So I'll definitely mention a few things, a few upcoming, products that we are launching with memory tiering. So the other thing that VMware is working on, CXL, right? CXL actually is just perfect for us because, it gives us direct access to the device, right? So no more DMA, no more physical, PCI transactions, right? So now with CXL protocol, the CPU can directly access memory within your device, even if it's external, even if it's PCI-like connection oriented, right? So now you have CXL devices that look like PCI devices, but that the CPU can directly access, right? So now you don't have the additional latency of doing DMA and transferring the data and all that. So now CXL gives you that ability. And on the right, you see some of the reasons why VMware is good for this, right? Is because we have a extensive experience. We have dealt with vMotion because vMotion is all about page tracking, etc., right? And we don't require any configuration changes. So what that means is that you just plug in this device, and one of the ESX versions will support memory tiering, the upcoming version, and you are all set. All you need to invest on is this additional device and enable memory tiering, and that's it. No additional license costs. It's available with ESX, right? So all you need to do is enable memory tiering and you get this extra capacity, right? But one caveat, right, is there will be some performance degradation. Nothing is free, right? I mean, it's probably obvious, right? But VMware will do its best. It will do memory tiering. It will make sure that the pages are swapped appropriately, and you get the hotter pages in the DRAM and colder are moved. So we will actively do that and ensure that the application's performance don't suffer, right? So we are doing a lot in the CXL ecosystem, and we are working very closely with all major memory vendors, right, including some of the big names. So some of the core improvements that we are getting with, or some of the value that we are getting with software memory tiering and CXL, right, is we are looking into TCO. Obviously, I mentioned costs, and so TCO is a big benefit, right? And increased capacity and bandwidth. So what happens is, for a lot of the applications workloads, customers are limited by how much they can expand on their bandwidth, right? Because if you look at an AMD server, for example, AMD has limited memory channels and limited DIMM capacity. So if you want to use lower capacity DIMMs and you need additional bandwidth, CXL can provide that additional bandwidth. It's similar to a PCI 5. You also can improve the CPU core utilization, which I demonstrated with the graphs. And you can improve OpEx. So there is one other product that is coming with CXL. It's based on an accelerator. So with the accelerator, what we are hoping to do is introduce some programmability so that we can do things like vMotion, right? vMotion is important for a lot of customers. So the acceleration can speed up vMotion. And as the product evolves, as the accelerator evolves, because it is programmable, we can start putting more value into that accelerator, like things like, how do you do compression and dedupe, or offload encryption, some of the security features, etc. And it reduces failure probability. And I mentioned, memory tracking, scrubbing. So a lot of our customers talk about, how they encountered memory failures, right? So this can help with that. So, some of the deployment options I want to talk about is, the first case is about memory expanders, and then we have something with slower, inexpensive tier, which is similar to the NVMe tier, but it's CXL. The next release, which is 80U3, we are coming out with NVMe based tiering. So NVMe is higher latency, right? I mean, it won't give the same performance as CXL, but for a lot of the customers, if you offload, just 20% of your memory, you will still get good savings, right? And then we will be using software tiering. So again, absolutely zero changes, but you will still see memory benefits, cost benefits. And then we'll be looking into pooling also, right? And memory disaggregation, etc. So in summary, right, we have been working closely with Intel. So there is one more vendor I want to mention, Samsung. So we have been working very closely with Samsung too, right? And Samsung is the vendor that is actually working with us very closely on the accelerator solution. So we are using, they are going to be providing the FPGA and the entire card that will actually provide the memory acceleration. And one of the core value is I mean, your workloads are changing. The nature of your workloads are changing because of some of the transformations that are happening, the new type of workloads that you are running. So memory tiering will help with that. And then some of the performance results, even Sudhir shared some of them. They show that memory tiering can result in consistent performance. I mean, we won't let you suffer with your application performance, right? So memory tiering will bring the scale, right? And the whole goal is to not introduce newer operations and newer configurations and make it really hard and painful for customers, right? The idea is to make it seamless. Idea is to integrate it and make it part of the core ESX. So these changes are part of the ESX kernel, and all you need to do is invest on the hardware and configure and just say that you enable memory tiering, and the rest will be taken care of behind the scenes. And you just keep doing the same things you have been doing. Run the same applications you have been running 3 years ago. And that's it. Thanks. Any questions? Yes. Thank you. Thank you. Yeah.
All right, well, everyone, thanks for kind of joining this afternoon. So what we got here is something a little bit different than your traditional VMTN Tech Talk. Joining me up on stage is a couple of our EUC V experts. And hey, Alistair, we got the wrong deck loaded. So this is not hybrid and multi-cloud desktops, your questions answered. That was this morning. This is actually our EUC panel. And let's see if, how do we want to do this? Okay, so while we get the deck sorted out, I've got 3 of our panelists up here on stage. So Jens, if you'd like to start by introducing yourself.
Yes.
Lower, a little bit lower, it's on.
Yes. So, can you hear me? Good. So, my name is Jens Hennig. I'm a partner at Comdivision, and they are working there as a head of digital workspaces, and I'm VCDX in EUC.
I'm Stephen Wagner. I own Digitally Accurate, the expert EUC, NVIDIA NGCA. EUC's been a passion of mine for the last 6 or 7 years, but I've been doing IT and virtualization all my life, even before I could actually do it as an adult for work. So,
and I'm the one that he points the squeaky toy after. So if I talk too much, he has to squeak me off, just like that. Yeah. So I'm Dane Young. I've been doing end user computing VDI products with all of the leading vendors for about 15 years or so, since the early days of what we now affectionately call poor man's VDI, where you have a Windows XP desktop that's on an ESX box. They use RDP to connect to. That was like the early days of VDI for me. So I've been doing end user computing for a long time. I own and run my own business. We do consulting and professional services, and I love talking about end user computing. So that's why he has to squeak me off, because I'll keep talking about this stuff all day long.
Is it really a chicken to yell at us for talking too much, Sean Massey?
Just introduce yourself.
What do I get? Oh, hi, I'm John Tolles, aka Mobile John. I am an expert in Workspace ONE most of the time. I'm also a Microsoft Windows 365 MVP. Been in EUC for probably over 10 years, not as much as some of these guys. But I'm expert on most EUC-facing technologies, not as much VDI, but pretty much everything else, Office 365, blah, 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 blah.
All right, so our first question for the panel is, what are the key trends that you're seeing in end user computing when you talk with your customers? And so, John, if you'd like to start us off with that, and let's, maybe 30 seconds to a minute.
So I have been very vocal that I think the next frontier in EUC is digital employee experience management, or DEAM, or DEX, or whatever term you want to use. I think the most important thing was we're doing more or less, and it's very, very important that we start automating and innovating at that point, like capturing when people are having issues, opening tickets, delivering automation APIs to kind of get the job done.
All right, so if you want to pass it over to Dane.
We're not going to do this in any order.
No, we're just going to pass it
Okay, that's fine, that's fine. For me, the last couple of years has really been focused on hybrid everything, so multi-cloud and virtual desktops in a multi-cloud environment creates a lot of opportunities, challenges equal opportunities, so I see it as opportunities. So for me, that's where a lot of our time is spent on design, deployment, troubleshooting when things are working well, when they're not working so well. And when you look at hybrid multi-cloud, it's all about the applications and the data. So that creates complexity around how do I make sure that all the stuff is there when the user needs it, where they're going to log into, and making sure that all that stuff is working behind the scenes.
I would have to say that I see a lot of stuff with vGPU. A lot of organizations are trying to implement for AEC. They're struggling to do so, optimizing base images, optimizing their workloads. And of course, when organizations get into the GPUs, we start, of course, it starts the conversation about AI and implementing some of those workloads. So that's a little bit away from EUC, but it's something that I always see pop up, and we kind of have to know about that with everything we do with GPUs. I know Dane can probably attest to that too. So,
yeah, what I see is huge movement to the cloud. So with all the supply chain issues we have right now during pandemic, so getting a server takes up to a couple of months and so on. And the things you have to maintain them, update them. So a lot of companies are right now considering the cloud and having the desktops in the cloud. That's something I definitely see. And then additionally to VDIs, creating a VDI, running in a VDI is not longer rocket science. So when you get it up and running, so what's the next challenge is apps. So getting the apps automated, and what we heard this Explore here about app volumes, the new innovations that are coming out, that's something that really is driving the VDI adoption quite massively, and that will be the next challenge over the next couple of months.
All right. So that actually segues nicely into the next question, which comes from one of our community members. And that I'd like Jens to actually start that question.
Give it back.
So that question has to do with image management. And how does that change when you go from like an on-premises Horizon environment to Horizon Cloud? And what is some of the advice that you give your customers as they make that transition?
So when you want to go to the cloud, so you have to think about, do I really want to migrate my old image that I'm running on-prem on Horizon in the cloud? Because in the cloud, you want to have everything new and shiny and not the bloated thing that's running somewhere on your on-prem environment. So when you go to cloud, probably Horizon Cloud and Azure, you can import a nice and shiny new updated Windows image all the time from Azure Marketplace and then build on top of that. And as I said before, it's not the operating system that's going to be the challenge, it's the apps. And the apps can easily follow you. So if you are on app volumes already, then basically it's the same. You just upload them, convert them to VHD, upload them to Horizon Cloud and Azure, and then you can run the same apps again. You do have DM support, so it's basically the same stuff as well. Just make sure that the user profiles and the apps are there. The rest is simply very easy. Who wants to?
Anyone else have anything to add on that? Dane?
I'm glad you gave the mic to him and not me. So.
All right. Steven, do you have anything to add? Dane?
So I mostly deal with on-prem, but with everything that we've learned at Explore, I think you've seen some of the demonstration that kind of backs up exactly what Jens was saying, is that all the new platforms that are available simplifies the management of images, pre-made images, app volumes. I'm pretty much just repeating what Jens says, but it's I'd say that it's probably the way to go moving forward. So
I'll take a slightly different approach and say it's all about documentation, and once it's fully documented, you have a really good understanding of what the heck is in your images, then you can automate it. Trying to jump straight to automation without having documentation, you're just going to waste a whole bunch of cycles. Just trust me, you're better to document it first, get your entire procedure down for how you're going to build and manage your images going forward. Then you can automate it. And then once you're automated, then you can slip in new OS builds. Then you can go from 22H2 to 23H, whatever, right? You can slip in those new layers into your automation work streams instead of having to build everything from scratch every single time. So for me, it's about documentation and automation, which then gives you that portability to be able to go to any cloud at that point.
I do have one comment. I actually do know one or two things about VDI. I will say the nice thing with Horizon Cloud is a lot of it translates. So if you have a good strategy for a transition as far as, capturing and pulling out your app stacks, because you can import them, and they actually have done a really nice job with Horizon Cloud as far as spinning up and actually importing those apps. It's actually great. You go in and it spins up the VM for you. Like they've actually come a long way now with V2 on allowing you to bring some of that stuff in. I won't comment too much on gold images, but I have been very happy with what I've seen with apps. Okay.
No, you're not in trouble. But I just want to play the ball back, basically. So, it's all about automating the apps, basically. So there are nice software out of it. So automating app volume creation and so on. But what I see as well. So, for example, take workspaces and the app volume support on it. You basically deploy dedicated machines, and a good use case for dedicated machines is to enroll them into an MDM to deploy software on it. So that's also a nice way to how to migrate from on-prem. So simply go to modern management and then simply enroll them into UEM, and bam, you have all your applications on it. And that's basically something that Boba John can talk about way too long. So that's why I'm going to give it the mic for him.
So I'm going to use that as a time to go to our next question. And this one I want to start with you, Steven. You mentioned in your trends that you're seeing a lot of GPUs these days. And, GPU and VDI has been a topic that has been challenging for a lot of organizations. So the question I have, and I'm going to start with you, and then I'm going to go to Dane because I know he's already champing at the bit to answer this one. Is in today's day and age, do customers need a GPU for VDI?
There is no simple answer to that question. I get called into numerous different types of environments where they've spent fortunes on deploying vGPUs across their infrastructure. A lot of the time, this has been patchwork to resolve improperly deployed environments where there's other issues that are happening, and whether it's the partner or whether it's the internal staff, they just say, hey, we can optimize this by throwing in a GPU. All that does is masks problems. So it might make everything work for the specific release that you're on, but then as you upgrade to future versions, you're going to start coming up with all these other phantom issues that wouldn't even make you consider, or you'd be on a different troubleshooting trail trying to find out what's going on, just because you're compounding the issue by adding something that's not needed. Proper deployment of applications, proper optimizations, as long as all of these get put into place, technically, the only time that you should actually need a GPU is if you have some type of 3D accelerated workload, if you have developers that need a GPU to do some type of development, compiling, AEC workloads, anything that needs 3D acceleration. There are some benefits to having hardware encoding. That's a nice to have if you don't actually have the requirement on the application. But I see a lot of organizations deploy when they don't need them. So that's...
All right, anyone want to take a guess what the #1 application is in any VDI or end user computing environment? #1 application. Browsers. Every single operating system deployed, modern environments has a browser. In fact, most environments have multiple browsers. You've got Chrome, you've got Firefox, you've got Edge, you've got Opera or other things, right? Depending on the organization's requirements. And every release of the browser is unaware that you're running in a virtualized environment. So the companies that develop browsers just are like, yeah, everything's a modern endpoint. It's got all these hardware capabilities. Just kick everything to the endpoint and have all the rendering and acceleration of the browser apps do all the stuff. So my personal experience has shown that when we've done endpoint assessments, when we've done virtual desktop assessments, when we've looked at the resource utilization, the #1 app for GPU consumption is actually the browsers. I know it sounds shocking, but if your users are in a virtual desktop all day, every day, they've got their browser tabs open right alongside their Microsoft Office apps, and they're chewing all kinds of multimedia-rich applications all day, every day that are web apps. Those web apps sometimes can offload to the endpoint through multimedia redirection and other things. But if they can't, or if there's a new browser release that breaks some of that functionality, all of a sudden it's back in your virtual desktop environment, causing your CPUs to spike and cause a lot of additional load on your infrastructure. So my experience has always been, it depends, because I'm a consultant, that's what I get paid to say, right? It depends. But if you look at your environment and you run endpoint assessment tools against your environment, you'll see that you actually have a high utilization of GPU resources in the form of browsers. So do we have specialized applications like Autodesk products, Adobe products, those types of things? Yes, we do. And we obviously recommend GPUs in those instances. But the general purpose desktop that has a lot of browser-rich web apps can benefit from a GPU as well. So.
Can I actually add into that?
Yeah.
And make sure that you use the OSOT tool. Okay. I can't tell you how many times I get called into environments where the first question I ask is, when was the last time that the image was optimized? The answer is, we don't know. 6 months ago. You should be optimizing the image every time you seal it. You should be using the tool to actually seal your images. Going to Dane's point, if you have a workload where you don't need a GPU, the OSOT tool will actually disable hardware rendering for Chrome and some of the other applications. And you run this for them, they look at you like you're a pro, and it's like, no, you're just following best practices. So,
that's what defines a pro.
Yeah. Yeah. So use the OSOT tool.
All right. John had a comment.
Just a single comment. I don't know GPU like these two rocket scientists, but what I will say is that doing GPU more often than not is causing more problems than not doing GPU. I've had a few clients where they just gave GPU to everybody. Everyone have GPU. And we had situations like they're running 4K monitors, black screens all over the place, and then because I mean a lot of times people just do it because they think they have to do it, and we all know how hard it is to unring the bell once you ring the bell. We had like literally like a 9-month case in a financial firm because they gave everybody 1 gig GPUs, which is not enough GPUs for 4K monitors, and they basically refused to do anything, and they spent 9 months fighting with VMware engineering over it. Because like I said, less is more, at least in my experience.
Yeah, you know, you might notice I'm a huge cloud fan, but the benefit of the cloud is, you know, you can test it. So if you're going to Horizon Cloud on Azure, there are lots of different VM types you can use over there. So you can testify with AMD CPUs, NVIDIA GPUs, different sizes, and then you can figure out, hey, is it really giving me a benefit having an NVIDIA GPU or not? And that can basically, affect or, that can basically be used for an investment. So do I ever really want to invest something in graphic cards and on-prem? Or am I going to stay into the cloud because cloud is simply cool? Yeah, but that's something that you should consider, even just maybe if it's just a very small test environment to figure that one out.
All right, so this last question that I have, I'm going to start with John on. Don't look scared to get the mic.
So it's not a VDI question. Go ahead.
No, it's not. And this is kind of more of a general purpose question. When you're onboarding a new customer or working with a customer who's doing a new system or an upgrade, you know, what are some of the, and this could be across, you know, Horizon Cloud, Horizon 8 on-prem, or Workspace ONE, you know, what are some key things that you tell them, you know, to ensure that they're going to be successful?
I mean, honestly, when I onboard a new customer, chances are we're onboarding new customers because somebody already screwed something up. So I mean, to be very blunt, what I typically do, I know I'm not often blunt, but I'm going to be blunt here, is I won't even touch anything until I do a health check. So I health check them, and then, because I mean, I'm all about like, let's prove our worth, right? Health check it, and then literally show them, because the proof is in the pudding. If you literally show them, okay, this is what you're doing, this is what you could be doing, this is what you're going to get out of it. Because I think at the end of the day, right, we all want to show the value. Like Steven said, sometimes it's just as easy as some utility or some tool you can run to just show, like literally show them why. Because I always teach people, ask why. Don't care who it is, ask why. Because at the end of the day, no matter what we do, no matter how smart the person is that's supporting you, it's inevitably your fault if they screw up. And everybody makes mistakes. I've had some really special ones in some really bad areas, like the DoD. We all make mistakes, and you know our own hubris can sometimes be our own downfall.
Okay. We'll pass it around this way.
So the question was, what kinds of things do you set up for the customer to have success?
Yeah, what kind of advice do you give your customers to set them up for
don't
success?
set it and forget it. That's the biggest thing. Don't set it and forget it. This thing is like, it's a never-ending life cycle. So you're constantly having to make improvements. And just setting up an environment, setting up an image, setting up the version of the management infrastructure, and then saying, okay, yep, we're good for the next 3 years. You're going to fail. It's inevitable. You get through that rollout, the user issues are all resolved. Well, then you got to turn around and do the next release, next release, next release, next release. So whether it's constantly improving your images or your applications or your versions that you're running on, just don't set it and forget it. Constantly improve the environment, and you'll be successful with good consultants to help you as necessary.
Yeah, I can only second what they said. So, and follow the basic design principles. So, Sean, you know what I mean. You did this with the VCDX, but that's, software has become so easy, and cloud as well. So not simply sit there and start deploying everything, click, 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 done. Sit back, lean back, and first think about what you're going to do. So make a proper design. Start with an assessment, then doing a conceptual design, logical design, physical design, and then simply only then start implementing it, because otherwise you're going to figure out later on, so why did I actually do this? Oh, I have no idea. Was there a design decision made? Were there design choices? Oh, I don't know. And that's basically, it's going to cover your, in a lot of situations, yeah.
Build repeatable processes.
So,
John, it's...
So this is the key to success?
Yeah, keys to success, things you tell your customers to set them up.
Key to success, 100% simplicity. Okay. A key example is the GPUs. If you don't need it, don't deploy it. I have a lot of smaller customers that end up self-implementing the entire solution stack when it's not even required. There's many different products to achieve your goal. You need to make sure that you factor them all in and keep the environment as simple as possible. Every component that you add to your infrastructure adds complexity. It adds more components that you have to manage, maintain, secure. And as Dane mentioned, some of this stuff, like a lot of organizations, they set it and forget it. And even if you remember 75% of the stack and forget the other 25%, that other 25% can topple the entire environment. So keep it simple, keep it sweet, know what you're running, maintain it, and take care of it.
All right. Well, that is our last question that we have for the panelists. Are there any quick closing thoughts that you have? Quick?
No, because it's not going to be quick.
My closing thought is that all of us love carrying on conversations around EUC. So if you have questions you want to talk privately, just corner any one of us. We'll be around. There's also receptions and then the party tonight. So seek us out, find us. We love having conversations. There's no unimportant question or no question that can't be asked. Just come and find us, corner us, and we'll carry on the conversations.
All right, so with that, I'd like to thank all of you for coming, and I'd like to thank all of our panelists for coming up here today to share their expertise and knowledge. So thank you, and thank you.
So, good afternoon, everybody. Hope everyone's enjoying their time at Explore. Thank you for joining our session on Ask the Multi-Cloud vExperts. We'll do a quick round of introductions, and then we'll get started with our discussion panel. Starting with myself, my name is Justin Brandon. I'm a multi-cloud solutions architect, a part of the worldwide multi-cloud architecture group at VMware. I've been at VMware for 2 years now, helping one of our key GSI partners execute their go-to-market multi-cloud strategy. My areas of expertise are around multi-cloud networking design and implementation from a VMware Cloud perspective, and Tanzu from a multi-cloud context. I have over 17 years of IT industry experience, and I live in Southern California with my wife and my dog, Luna. And the panelists, I don't have everyone's picture here because Reinhard joined last minute, but we have 3 panelists here, and I'll hand it off to him. First, we have Ken Nalbone, Senior SDDC Pre-Sales Specialist at Ahead. Ken, want to introduce yourself?
Sure. Hello, everybody. Ken Nalbone, Senior Solutions Architect at Ahead. We are a VMware partner that provides solutions design, professional services, managed services, and even consulting services. So for the breadth of IT solutions across the enterprise, I'm within our practice that focuses on the VMware portfolio, and I design cloud solutions both on-prem with VCF and in the hyperscalers with the various VMware on hyperscaler solutions.
Thanks, Ken. And next we have Waldemar Pera, Staff Solution Engineer at VMware.
Hi. In this short way, the NSX guy is more, but the truth today is lead architecture network security for VMware Latam, and an official vExpert multi-cloud for my team. So it's not my duty, but this word is multi-cloud.
Thank you.
Hi guys, so my name is Reinhard Partmann. As you have seen, I'm not here on the slides because I joined last minute. I'm a partner at COM Division. You have seen my colleague Jens Henning before. I'm a partner at COM Division. We do, well, managed services, architecture, education, and operations. We're a long-standing VMware partner. I have a strong EUC background too. And nowadays it's, well, like Jens, a fan of cloud. So I do AWS, Azure, SD-WAN, whatever comes along.
Awesome. Thanks, Reinhard. Okay, so this is our round robin panel discussion. I'll start with Ken, and I'll do it in reverse order. And so just throw them questions, and they're going to answer the best they can. So, Ken, the first question is, why would customers come to you for multi-cloud services?
Sure. So I would say customers would come not specifically to me, but to my employer for multi-cloud services and solution design because of the breadth and depth of expertise that we can bring to the entire solution set. So it's not just about like which cloud you're going to run and doing things along the lines of consulting services to get a view of your business needs and your applications to understand what's suited to run where, to make that recommendation first, then to actually provide the solution design to optimize that, and then to maybe even run it in day 2 operations to provide that managed service. So we offer the full gamut of services necessary to enable multi-cloud for our customers from top to bottom, from strategy and vision to design to execution.
Right. Waldemar?
I think it's the big challenge now for several customers starting in the several years ago, only thinking running in one place. But now when you see application, personal application, what is running the application? Doesn't care, you don't know. But in the end, in the back end, yeah, the customers try what is the best way or the best place to run in the career. It's not thinking now in the infrastructure below because you have service for that. You need consume. And this multi-cloud open the idea for go directly to the consume because you have option to run it. And the customer move it between maybe for governance, maybe for money, whatever, but you have cost option and multi-cloud need thinking in that way.
Awesome. Thanks, Waldemar. Reinhard, what do you think?
So, why do customers come to, well, us or to COM Division for multi-cloud solutions? Well, number one, we put always the customer first. Because at the end of the day, we have a saying in Austria, we say, everyone is basically cooking with the same water, right? So you have many flavors of cloud. So, but when you put the customer's needs first, you need to analyze what is actually his pain point. You go back, like you said, you do the design, you do your due diligence. Sorry, non-native speaker. And when you lean back, listen to your customer first. What does have he to say? What are his needs, business needs, relevance? And then you choose where to go. Because at the end of the day, you have multiple services at multiple cloud providers, which are more or less nearly the same. Like I said, they are all cooking with water, different versions, different user interface, but at the end, there is the same. But then we also say, what does the customer already have? Because as I am a VCI too, throwing away knowledge is, well, let's put it that way, one of the most expensive things you can do and do badly for your customer.
Right.
Because if he knows already some sort of interface, for example, VMC on AWS, it's easy for him to adopt that service because it's the interface from on-prem. So listen, and guide the customer where his needs are.
Makes sense. Yeah, I saw some synergy there. We're all thinking about the customer first, identifying what they are, their needs, and then providing what's best fit for them, essentially.
And not only that, I think that we're focused on helping the customer figure out what they need. A lot of times, they don't really understand what it means to adopt cloud, much less multi-cloud.
Yes.
And they're saying, put me in AWS. You have to say why.
Right.
Like, tell me about your application, about your business needs, and let's work backwards from there rather than start with the solution to design up from there.
Right. Couldn't agree more.
Yeah, like you said, because sometimes the customer has already a vision, and maybe that's the wrong vision. So maybe he also needs to do a step back and say, well, why? Are you sure?
Sure. The first question for every customer is, what means cloud for you?
Right,
because
exactly.
My vision for cloud maybe is not the same for the customer. So let's again, thinking, ask. We have to
put your ears on.
Only one to more hear and talk.
Awesome, guys. Okay, I think we're gonna get through all these questions, maybe. Okay, Reinhard, you're next. Okay, so start with Reinhard first. So what is your customer's view of multi-cloud, and what would you say their maturity level is in that space? How far along are they on the multi-cloud journey? Are they just, what is your sense from that?
To be honest, I am from Austria, so what does that say? Austria and Europe is not that, I wouldn't say cloud friendly. It's sometimes a little bit harder to convince customers in Europe going to cloud, especially small ones. And don't even get me started on governmental institutions. I wouldn't say they are cloud haters, but it's incredibly harder to convince them. So from a multi-cloud perspective now, I would say it's like the multi-vendor approach when you were working on-prem. So don't have all of your eggs in one basket. So we all stand on 2 feet, right? And tables. My father was a carpenter. Do you have a table with 2 feet? No. If you have a table with 3 feet, it never wobbles, I think is the correct word.
Right.
So, like I said, you have to be a little bit like a candy store. Give out a couple of candies here and there, tell them, show how does it run, how does it work, and they need to get the taste of that on their own.
Yes.
And then they figure out how actually nice it is to consume a service.
Right.
From our own personal vision, I've never run an own email server for myself, for my company.
Right.
I always used a hosted email service. And in the past, it was called hosted service. Now it's called cloud. It's very similar, right? So,
right.
Ken?
So if you asked me this question like 4 or 5 years ago, you get a much different answer. Because when the term multi-cloud first came about, I think the vision was, wait a minute, are we going to use multiple clouds for our one application and spread the services and make it distributed and somehow fault tolerant and live in some utopia where the fact is that didn't exist. and it never would have. It's not practical. And I think that there were a lot of analysts trying to project that would be the future that we would live in, and that has not turned out to be the case at all. But when you look at multi-cloud as putting the correct application in the correct place, leveraging a hyperscaler or a SaaS provider or a PaaS provider or whatever the case may be, and then it's a completely different story. And when it comes to my customers' maturity level, they probably wouldn't call themselves multi-cloud because they might not even think about it that way right now. But they are a multi-cloud customer because everybody's consuming SaaS and PaaS and a little bit of IaaS at the very least, even the ones that say, we're not in the cloud. But we also have Office 365 and we have Salesforce and we have a little bit in AWS and on and on and on, right? And then when they say we're not ready to migrate to the cloud, I'm like, you're already there, so let's just move all the other workloads that are kind of ready. But we can help you out with that.
At the point is, Office 365 is basically the the entry step into the cloud because they don't think about it that it's actually cloud because they think, oh, cloud, all of my servers, my storage, that is in the cloud. They don't, like I said, email always was in the cloud at the host or whatever, right? And from that perspective, it's exactly what you're saying.
Okay. All right, Waldemar.
Okay. Okay.
Skip Waldemar. It's okay.
No worry. No, it's okay. I think for Latam, maybe the more two parts of the problem. The first part is too much people talking about cloud, but I don't understand who or what is cloud. Because you had a lot of customers say, I want to go to the cloud, but it still has a lot bare metal servers. If the people doesn't understand move it to the cloud, it's virtualization, first stage, that missing the part. And the second part is what is maybe the no hater for the cloud, but the idea is when the people say, okay, I have my question, my doubts, what the cost, what it is, because sometimes the customer don't understand what is cost perspective for the on-premise and what is the unit cost in the cloud, especially in the public cloud. So sometimes you need, it's a maturity the customer, okay, in a slow transition, especially in the focus in the finance. The people like it, cloud, until see, okay, the bill. That is a need cost, okay, and stop. And it's very common, it's very common problem.
We see that. Yeah, we see that, yeah, the inherent cost savings in the cloud is usually not, you don't see it a lot of times. So yeah, thanks. That was good response from all of you. We even had a candy metaphor there. I like that. Comparing the cloud to candy, give them a taste, they like it.
I like the furniture metaphor.
Yeah.
the three legs on the table.
Yeah, it's awesome. It's awesome.
Coming from a background of hardcore electrical engineering and stuff like that, so.
Yeah. Okay, Waldemar. Okay, so. Okay, so this is difficult. Waldemar, you work for VMware. So from the reverse side, looking out, I'm sorry. So how would you say our partnership with our clients and our partners, how does it help them on their multi-cloud journey from the customers you've worked with? Like, how's the relationship with VMware and the partners help them on that multi-cloud journey?
I think it's the big problem with talking the cloud is what you have several kind of clouds, different what the private, multi-cloud, hybrid cloud, public, whatever, and you need to simplify it to the customer. Simplify maybe what you select is you have legacy application as running okay in vSphere. Okay, it's possible to run in vSphere in every place, in every scaler. If the customer need create a new application and that application is okay running in Kubernetes, whatever, in native, yes, it's okay. But then you need a holistic view for every point. If you're thinking cloud is no place, it's an operational model in the end. And you need collecting what is the traditional and the modern app, doesn't care on the running. You need to prepare the environment to the application, in on-premise, in whatever, and a single way deployment. And the management part, cross multi-cloud, is critical. Gotcha. I believe I am employee VMware, but I have something to help to the customer.
Right. Okay, Ken?
I mean, really, I can answer that question very simply with one word: consistency, right? Because I think I already talked about the challenges and trepidation a lot of customers have in adopting multi-cloud. They think they're not multi-cloud even if they already are. but when they want to move a lot of their applications into some new platform and some new environment, they're scared about operating on a day-to-day basis, picking up the new skills, or just having to do a lot of context switching with different interfaces and different modes of operation. And that's the value that VMware has brought, right? Now we don't have to be tied to a specific location anymore, a specific data center, a specific hyperscaler. But we can do things in a very similar fashion. We can operate in a similar fashion. We can use the same tooling to monitor day two operations, use the same utilities to migrate applications into an environment or out of an environment. And we can use the same tools to secure it, to connect it, to enable the mobility. Essentially, we're talking consistency, the same story over and over, thanks to the tools that VMware has been coming out with the past several years and continues to iterate on and improve, essentially. That's the way it comes down to.
Right. Reinhard.
So, I would phrase in that way. Number one, as Microsoft is working with a lot of partners in the ecosystem, there is an easy and paved way already that you can go to different clouds. Simplicity first, because if you remember, like in the past, VMFS was one of the first cluster file systems that came without that thick in a manual.
Yeah.
Well, and if you put that idea now onto multi-cloud, like we have VMC and AWS, we have AVS, we simply move workloads with HCX. It's again crazy simple.
Right.
What you have to do, your design, your intelligence first, simplification first. Talk to your customer first. Well, there are a lot of firsts. They are the prerequisites. That's why they are there, right? Yeah. But afterwards, there are always, let's say, challenges, issues. Well, let's say we expect the unexpected.
Expect the unexpected. Always. Yeah? Always. Yes. Always.
Only one thing. When they're talking about prepare things, we are stay first, walking before run.
Right.
So the preparation, when he says, is more important time.
Sure.
You very good prepare that thing. This is go answer.
Correctly, and
right.
And again, okay, now I lost the thread a little bit. Simplification and preparation is the key to solving more or less any problems. Like 2,000 years ago, divide and conquer by Julius Caesar. It's basically the same thing.
Right. Yeah, exactly. Yeah, good points, guys. Good points. So, question 4. Where do you see opportunities in multi-cloud space, dealing with your clients, our clients?
Yeah, of course.
Yeah.
The world is multi-cloud.
Right.
Doesn't matter. Sometimes the organization say, I don't have multi-cloud. Yes, you have some Microsoft service. Yes, you have multi-cloud. Right. It's not infrastructure service. Maybe platform service, SaaS service, whatever. It's multi-cloud world. And that is the group. The challenger, especially, is put together the things, globe everything.
Right.
And the partners and the VMware has a hard work to transfer that awareness to the customer, and that is key.
Right. A lot of education there, for the customer. Ken?
I would say the greatest opportunity is to modernize, right? Because most of these companies have been running the same model for decades. They've been in their data center, and it's all about compute, storage, and network. And they don't really think beyond just like the bare metal machine or the VM that runs on top of it.
Right.
But now they have the ability to adopt the right cloud for the right application that we've been saying over and over again. And if we start by saying, okay, these applications, maybe they're going to stay in the data center in their current form, but other applications, they're going to move. And maybe they're going to move in their current form, but now we have the opportunity to take advantage of a lot of native services, break this out into a more distributed fashion.
Right.
Maybe we're not even running the application anymore. We're just consuming it as a service, and we're just taking a load off of our teams.
Yeah.
Getting back to just delivering the business value by using the application, not maintaining it.
Yeah.
Essentially, we have a lot more choice than we used to.
Yes.
A lot more flexibility. I'm not going to talk about cost. I think the cost savings of multi-cloud is a myth. I think the revenue generation potential of multi-cloud is the reality.
Yes.
Essentially, we're talking about leveraging the best-in-breed technologies across the entire state of IaaS, PaaS, SaaS services to build a differentiated business offering, thanks to multi-cloud.
Yeah, great. Thanks. Reinhard?
Well, the greatest opportunities. In the past, we said do right sizing. Now it's basically right fitting. because, like you said, let's say application A runs better on hyperscaler 1, application B on hyperscaler 2. So the only thing what we really need to get solved is inter-hyperscaler connectivity, because all the you don't want to mention the cost, but there are transit costs. We know them. But again, it's simplicity, drive adoption, and these are the opportunities, because you can, with going to cloud, you can reduce the, well, let's say, manual labor running an own data center. It's a service where you put your own service on top of it, and that will help the customers.
What short thing? Too much people thinking HCX like a migration tool, but it's possible to use HCX for more long time to create that connection between hyperscaler.
Absolutely.
It's create the mesh between hyperscaler, like in the old data center interconnect. So that is
Awesome.
the
Thanks.
idea.
Okay, Waldemar, keep the mic. So, what do you see the role of hyperscaler public cloud versus private clouds in a multi-cloud context? As these IT decision makers are looking for a more cloud-first strategy, and now they're switching to a cloud-smart strategy. So what do you see the role of hyperscalers compared to private cloud space, private cloud?
Okay, I taken yesterday in my session resilience about the multi-cloud world.
Right.
The problem is not private versus public cloud. That is not there. You have kind application difference. We have legacy application and modern application.
Right.
And that application needs for the multi-cloud different requirements.
Right.
That is true. No, it's private versus public cloud. And in that case, for example, for the traditional application, it's possible to use, again, I say the VMware bubble inside private, hyperscaler, wherever, so that move it. And the Kubernetes is the same. It's possible to use Kubernetes platform, whatever. Maybe in on-premise use, it's VMware Tanzu, or maybe in the hyperscaler, what kind? You provide that, it's changing the idea, is doesn't matter what is running. You have an environment to run application. That is important. And for example, talking about resilience and DR, I'm thinking use the capability to create an extreme powerful DR for different applications in the same way. And you have the tools, yeah. The problem sometimes is to change the mind of the people. That is more challenging for me.
Yes, yep.
The technology is an enablement, but you need to change the mind. The human
That's
being
the hard
is the
part.
problem.
That's the hard part.
Yeah.
All right.
Yeah, honestly, I need to second that, because there is. It doesn't matter if it's running on your own cloud. It's called a private cloud.
Right.
Before it was our virtual data center, or in a public cloud on a hyperscaler or whatnot. You need to have availability, flexibility, and most of it, sustainability, because if you cannot sustain the business, you will go under. So it doesn't matter if it's running in a public cloud, in a private cloud, on a cloud service provider or whatever,
right.
As long as it doesn't, you don't make money out of it at some point. Right. Because what's the core definition of a business? Making money, paying your employees.
Yes.
So whatever you do, you need to do it efficiently, safe, and don't get hacked.
Right, I like it. Awesome. So that's it for the questions, and I'll give you guys opportunity. Have any closing statements? Any multi-cloud wisdom or anything you want to say?
Okay, I started. Open the mind. That is the first thing. I starting close to, oh my God, I go to in my 18 starting with the coaxial cable and installing network. And then starting with the OTP cable, and then starting to create VLAN, and now create overlay.
Right,
But I am saying, so taking the opportunity, it's the most challenging the opportunity change us.
Right.
But you pass to see the future, the multi-cloud is great.
It's great. Awesome.
Well, use it or you lose it, because
I like it.
just those simple words, because at the end of the day, you will see more and more cloud adoption. We want to drive the adoption, but like you said, it doesn't matter where the information flows. If it's on a coax cable, STP, UTP, or token ring, even a little bit older.
Awesome. Thank you, Reinhard. All right. So I want to thank you guys for your time and being panelists and being
Thank you so much
experts
for having
in the
us.
community. I want to share a few links with everyone in case they want to learn more about becoming a V-expert and participating in this community. There's also a link to our multi-cloud tech zone site where you get more information about multi-cloud VMware services. So thank you all for listening and hope you enjoy the session.
Thank you.
Hey, hello everybody. Welcome to my session. My name is Caio Oliveira. I'm based in São Paulo, Brazil. I'm Brazilian. And I'm part of the global worldwide multi-cloud architecture and strategy team. Right, so this session here, I'll be talking about connectivity in the multi-cloud era. So pretty much what I do on my day-to-day is go towards our customers and partners and try to help them on their multi-cloud journey. And I would say that like, typically, networking is one of the most challenging points, right? So just a quick overview before what we're seeing, especially with I'm trying to get like our cloud smart approach to in a view of a networking or security specialist, right? So a few years ago, we saw a lot of that trend to go to the cloud, so for cloud first as a first approach, and with that, all the networking engineers, all the security engineers need to learn a new skill, right? Because now, before they are used to do like VLANs, things like that, and now they are going towards like VPCs, VNets, all kind of new constructs that, of course, the concepts are the same, like networking concepts are the same, but they are new tools that they need to learn, right? And with that, especially going towards more clouds, more than one single cloud, we got into cloud chaos, right? So a lot of different skills needed for the engineer, a lot of applications spread all over, a lot of networks spread all over. So VMware's approach is really to try to solve that with the cloud smart approach, right? I'm talking about a little bit about the challenges, and here again, about challenges in the multi-cloud networking, right? So normally, when you go towards a cloud, if you're going in a single cloud, normally you have the vendor lock-in, right? So if you select one cloud, potentially you are losing the benefits of going towards the others, right? So when you have more flexibility. As well, what we see before in the data center that we have siloed teams with different areas, we see nowadays the same with the cloud. So we have like an AWS team, an Azure team, a Google Cloud team. So normally like that, and that actually increase the number of staff and also the staff training. You have to get new people normally to solve that, right? So also security, how I get my posture all over my environments. I have my on-prem environment, I have my different clouds, how I can have like the same security all over. And of course, management cost, optimization, how I would do that in a multi-cloud environment. And of course, if I need to migrate one workload to another cloud, how I would do that, the interoperability, right? So those are the most common challenges that we see. And here I'm trying to bring the most challenging points I see in security, right? I think the first one is actually something that when customers start their journey to the cloud, what they do, they have normally their private data center, and for example, here in the example, in this slide, they start with AWS, right? So they have a connectivity, they normally tend to have a direct connect, tie it directly to that data center. That's good so far if you have one cloud, that's worked well, but now, for example, Microsoft brings a good licensing deal, so you have the opportunity to play with AVS, for example. Now you have to have another private connectivity, right? So you hook up like with an express route. And the same with Google Cloud Interconnect, the name of the private connectivity, Oracle as well with Fast Connect and others. In that moment, what you see, since you are connecting everything to your data center kind of becomes a bottleneck. Because something happens, for example, you have an application that's communicating between AWS and Azure, all the traffic needs to go to your data center and coming back. So the first point that we normally try to talk in when we are planning an architecture is to think about having what we call a cloud exchange provider. And there are a few over there. The most known are kind of Equinix or even Megaport. We have a program that we run. We rely a lot on Megaport because with that, you have now a way for optimize your traffic and also have availability. So depending on where your clouds are, if you are different parts of the world, potentially having a cloud exchange will make a lot of sense for you. So I think that's I would say that when I start working with my customers and partners, that's kind of the thing that I try to envision for the beginning. As well, this This is something that should be trivial, but normally it's not. So please don't use overlapping IPs on your environments, right? I know that makes it kind of simple, but sometimes we see a lot, especially because normally there are some companies that passes through merger and acquisitions, and sometimes they have overlapping IPs. They have challenges right that. But if you are building and creating an environment from the beginning, try to make each environment different. And of course, you can, at the future, have like HCX, you extend your network, that's not a problem. But if, in your global environment, if those those networks aren't the same, it will be a good way for you to do, right? Third one is the traffic optimization, right? A lot of my customers, they have a security posture as well, their exit to the internet, normally on their data center, because potentially they might have a proxy or other components. So with that, now you have all your traffic from all those clouds going to your data center to live. So that's not efficiency, and potentially you are having more cost on that. So with that, and especially this can also increase the latency between the applications and your customers, wherever they are, right? So think about using and relying on the internet of those providers have, because normally they have a lot of bandwidth, and that will be a great benefit for you to have. Third point, I think really similar to fourth point, actually. Really similar to the last one, right? Normally we have those big boxes, those big Palo Alto checkpoint boxes that customers like to have on their data center. And okay, I have my security posture here. Okay, all the traffic goes to my data center. Again, not efficiency, right? Because, for example, if like you have an application that you have like the front end on AWS and the application tier or the database tier on any of the other clouds, like Oracle, for example, the traffic will go towards your data center, get inspected there, and go towards there. So that's not efficiency, because this is using like what we call a centralized approach. You have to move towards a more distributed firewall approach, right? When you have all distributed. And of course, when you rely on an abstraction layer, like for example, relying on VMware Cloud on top of all your clouds, you might have a good way to simplify and have the same way that you implement a firewall rule on AVS, the same way you implement on GCVE, OCVS, and all the others, right? So really important to try to rely on those. I know that's kind of simple here. Normally when you're creating a design, especially regarding security, will be much more complex. But I think the general concept is, instead of like thinking about a centralized security posture, think about the distributed security posture, right? Another important point, and this is helped me in a few of environments, like leveraging BGP filtering. I know that's kind of like a really, I would say, feature that normally people don't tend to use, but especially when you have this cloud exchange provider in the middle of your environment, putting what will be allowed between each environment will be helpful as well, because sometimes you have dedicated teams in each of those clouds, and or you have an IPAN, but if you don't, potentially people will be creating networks all over, right? So having the allowed list will potentially avoid a serious problem on your data center. Imagine if you have like VMC or wherever, and a team here create a network that will conflict with your OCVS environment. If you have all the networks distributed, advertised, potentially you have a problem there. So creating allowed lists and all the networks inside this cloud exchange provider would be a good thing, right? One last point is think about the cost efficiency. Like the egress charges are different between all those clouds. So potentially depending if you have an application that relies a lot and will expose a lot of the traffic to the customers, try to understand which cloud will be the best for you, right? There's a few customers that normally try, depending on their traffic posture, go towards a specific cloud, especially on the front end, right? Not normally on the back ends or on the mid layer, but think about that, because potentially you might have an efficiency. And normally we we tend to help customers to first understand. And normally the question is how I will understand the traffic, how I will know how much traffic I will, right? So relying on tools like area operations for networks will help that, because now, of course, you have those entire environment. You have traffic coming from one place, from one customer to another, going to one cloud, entering my cloud exchange. So how I'll get visibility to that, right? How I will potentially, if I have a problem, how I will tackle that. So understanding the traffic, understanding the path will be really important. And area operations have this complete visibility. Doesn't matter if you are running on your on-prem environment, if you are running a vSphere environment or a non-vSphere environment, area operations can give you that. I don't have time enough to talk about operations. Area operations will be an entire session, and there are lots at Explore this year. Definitely recommend for you to look on that. And to talk about a real case that we build in our team, we developed a class that actually is running right now called the Multi-Cloud Expert class, that we have created an environment for 20 students to use, to have a dedicated environment with one on-prem environment and a connectivity to 3 clouds. So here we have a data center. In each data center, you also have a VDIs for the students to connect. And you have, this is a nested environment inside the data center, and you have a connectivity to the Megaport. Megaport will be playing the customer, the cloud exchange in the middle of your environment, and each student will have a dedicated MCR. MCR is a Megaport Cloud Router, and that MCR have connectivity to all the clouds. So each student will have a dedicated one. So with the principles that I showed you here, we created this cloud. Soon, like potentially in the next week or two, in the tech zone, we're gonna have all the architecture, all the slides related to this class here, right? So my time is almost over, so thank you guys for, I know that was a quick, short session. I tried to bring the most challenging points when you are implementing an architecture, and if you have any other question, I'll be around here. Thank you very much.
We're on.
Greetings, everyone. Welcome to our session today on Quantum Leap, the ever-changing virtual state of quantum computing. This is a new session that I think there's only been one other quantum computing area, but it's an area that we see as growing. It's coming fast, and especially with large language models, Gen AI, this seems to be the very next logical progression. My name's John Arashi. I work at VMware now. I'm a Boomerang. I work in the sales field right now.
I'm Tony Foster. I'm a technical marketing engineer at Dell and do all sorts of fun, crazy stuff, just in case you couldn't guess from the cape.
Cool. Now, this is a quick overview. We're not going to run through the details of the agenda, but just to give you an idea, especially for those who want to take a picture or who are watching it later on, this is what we're going to cover. We're going to get started on this. So, why quantum? There are a number of different areas that we've already identified use cases for. We're going to talk about that in a second. There's mining, navigation, secure communications, agriculture, edge, quantum imaging, and logistics. And as part of what we're seeing on the AI space with customers, we see the same thing on the other areas. So we've got an example that
One of my favorite examples on this is actually the agriculture one. So the population of the world is growing. We've got to be able to feed them. And with quantum computing, we can actually figure out how to optimize some of our growth patterns and stuff with food production to actually be able to continue to support the world's population.
Great. So what is quantum physics? So we're going to cover two things. I'm not going to read through all the details, but the key is quantum is a share or a portion. That's the definition. Quantum theory is around the theory of matter and energy. So there is a connection with compute, and you'll see in a moment. Quantum mechanics is actually applying the quantum theory and the approach in going forward with that.
So what we have with quantum computing is real interesting because you actually start with a single atom that's spinning really fast, and we have to slow it down. So we supercool it, and right now the most common way to do that is as a single solitary system, and we have that here. And we'll take those solitary systems that you can see in the little diagram, and we'll keep building those out, and we'll put a collection of those individual systems into, go ahead and click, a much larger system so that we actually get a quantum computer. And it's super cool. It's got what's called a chandelier that holds all of the different qubits in place so that the processing can happen. And then you have a actual Google quantum computer here where you can see the chandelier and the QPU at the bottom of the system. And with those qubits, basically what we get is an awesome little spinning atom that's near absolute zero, so we've slowed it down so we can look at the state of it, and it's sort of like a coin flip. We don't know where that coin flip is, so when the coin is spinning in the air, it's in an unknown state. It's sort of like Schrodinger's cat from the previous slide. We don't know until we open the box what the state of the cat is.
Now let's talk a little bit more on the terms and concepts. So in this area of quantum computing, as well as in quantum physics, there's this concept called superposition, where there are quantum particles that can be in all these different states as just described. That's the Schrodinger cat or the coin flip comparison. There's entanglement. This is where you have quantum particles that interact with each other, and they can influence each other for different final outcomes. And then finally, there's a quantum interface, quantum interference, where that interaction can be both good and potentially bad. It all depends on how we use this and how we're looking at what's called the probability outcome. So for example, when we look at how this process works on the next slide, we basically have the ability to actually look at all these different combinations of ways of doing things. There's a probability, the highest probability is the answer that gets conveyed. And that's something similar to what happens with Gen AI and large language models as well. Let's see, go to the next one. Yeah, I'll let you go ahead.
Okay, so really if you think about it, let's start with the classical model. The classical compute model, everything's done in ones and zeros. Everything comes in binary, and you have inputs and outputs. go ahead and click again for me. Yep. And with quantum computing, it doesn't quite work that way. We have inputs that we feed into our quantum computing. They go through a bunch of gates and everything to try and take care of the noise and everything that John just discussed. And what comes out on the other side, the outputs, is going to be the highest probability item of what was calculated. So it's not going to be 2 plus 2. It's going to be what's the highest probability that the coin is a heads up.
Yep. So I want to talk about the use case in financial, or the set of use cases in financial. There's risk profiling, there's trading optimization, there's targeting and prediction, there's security. And I will tell you right now, as you can see, the definitions of these areas and the use cases, we use ChatGPT for this as an experiment because our ability to do this has some similarities to what you do in the OpenAI space. So this gives you, I'll let you read this later on just for time's sake, but we did validate all the info we got back from ChatGPT and agree with what we have on these definitions here. So who's in this space? We have a number of different companies that are working on the actual physical hardware. We have some that are working on simulators so they can start preparing and developing the hardware aspects. We also have companies like NVIDIA that have their DG platform series that is being used, although it's GPU based, it's not quantum based. But it's an area to start moving the bar forward with research. And again, all of these companies are working towards having simulators so that they can start learning more while the hardware technology is getting developed.
Absolutely. And you'll see with a lot of these, a lot of them are building physical quantum computers. You still have to figure out how to program them, and that's where the simulators come in. They're not running full things through there. They're simulating the likelihood that something will happen while they still get their hardware developed.
So this is from IBM from I think it was about 2 years ago. And this is kind of their prediction on how the path is going. I've heard similar results from Intel and others based on the research we've done. They're looking at maybe just like what we've seen with development of GPUs in working with cloud and multi-cloud and obviously virtualization. The same thing they see as applying, and it's expected that it's within the next 10 years that we'll see full evolution in this area. But the thing is, there's a starting point now. I do encourage those of you who are pursuing ongoing development in cloud and working with AI and potentially some of these other verticals and the use cases that we mentioned, this is something you should start getting to be more familiar with.
So this actually starts getting us into the meat of this, probably why many of you are here. When are we going to see quantum computers in our data centers? And the answer is probably not super soon. It's probably going to be a little bit before we actually see them in our data centers. And if you think back to the first computer, the ENAC that we have here on the screen, it had hundreds of miles of cables and took tons of people to operate. And if you look at a modern supercomputer, it has hundreds of miles of cable, liquid cooling, and takes tons of people to operate. So there are very, very similar instances there between the two. So we're still in that developmental phase where quantum computers are starting to become available, but they are not readily available and probably won't be for 10 years. After 10 years, we will probably see them. Now, let's apply this to virtualization. This is a virtualization conference after all. So how do we see those being consumed? Obviously, they're going to be the most expensive processors out there. So you're going to put that towards the most expensive thing you can. GPUs are a little bit more expensive than standard processors. So it's just going to follow that curve right on up. Your most expensive thing gets it. And what we see is those most expensive items in terms of risk, in terms of rewards, are things that require high-speed operations, such as stock market and trading events, and security events. They contain the most risk. Now, the way that's going to probably be consumed in a virtual environment is through a cloud. You're probably going to have some sort of cloud provider who's going to deliver quantum computing for you so that you can actually get the benefits of quantum in your environment as opposed to having a super cooled environment in your data center.
And we're seeing something like this with, obviously GPUs and current AI. NVIDIA's doing this, offering cloud. You can see on the VMware stack, we're supporting virtualization of GPU and working with different service providers to make that more available. We expect the same thing is going to happen in this area. We don't expect companies to buy quantum computers to run on-prem because of the cost. They're going to take advantage of this partnership with different cloud providers and the vendors. And our last slide, I'll let you go.
Awesome. So obviously with stuff virtualized, with containers, with all the wonderful stuff that we are developing now, what could you do with a quantum computer if you start putting it in a large language model? You could do some very, very interesting things. It could become very interesting adding it as a hidden layer inside of a large language model. You could get very close to a sentient system at that point if you really thought about how many qubits you put in there and what they were able to do. So the possibilities really start becoming interesting the further out we go with this. And go ahead.
So I was going to say, in summary, this again is what we've tried to cover today. If you have questions afterwards, you can reach out to us. Also, I wanted to share that we have a number of references on there you'll be able to get once this recording is up, which I think is probably going to be later today. And we also wanted to give you our contact info if you want to have follow-up or questions or anything. We'll stick around for a little bit after this, and we'll probably go out outside of interference area, so we'll be over on the left side. So thank you so much for joining us today. Well, thank you. Okay.
Hi everyone, thank you for coming to my session. Speed up your slow Horizon logons. Who here has slow logons in their environment? Or who here wishes their logons would be better? All right, perfect. So I'm going to tell you a little bit about myself. So my name's Trent Tai. I used to work in healthcare, so these were my people. These are doctors, right? And their time is really valuable. It's really valuable in two ways. One way is money, financial, of course. The other way is patient care. When you can have more time for the doctors to look at patients, then they can actually be more effective in patient care. So that's something that slow logons takes away from them when they need to launch their desktops or applications and wait and wait and wait. So when I was working in this, what I found was slow logons cost a lot of money. In the environment that I was in, when we had 30-second logons, 1-minute logons, we would have the doctors log on maybe 4 or 5 times a day to their published applications, and that would be 5 minutes a day times 1,000 doctors times 365 days a year. And when they're getting paid $400,000 or something like that, it's really expensive. And then you take away the patient care aspect of it, not something that's conducive to a good environment. So that's the time that they lost when they were waiting. That's what it looked like. So when we got the logons down to 30 seconds, they got really excited. You used to have to sit beside them. They would sit there and be like, all right, I want you to actually witness what I have to go through. They'd click on the icon, they'd start their stopwatch. They'd be like, 30 seconds, this was the best logon I had today. And you'd be sitting there like stressed out as you're waiting for that Windows screen to eventually get to the desktop. So I made it my mission to make logons as low as possible in my environment, and we accomplished that. Back in those days, I think we got down to about 6 or 7 seconds for logon time. So we did a really great job at the time. So that's where my journey began. This is going to be a really information-dense session, so I hope you have your pens and papers ready, because here we go. So first thing you want to do when you want to talk about your logons is you want to essentially establish a baseline. But what you need to do is you need to understand the capabilities of your environment. So the first thing I experienced was that megahertz matters. It matters more than core counts. At least this has been my experience. Logon duration is a single-threaded process. Multiple cores doesn't help it as much as faster processors does. And this was borne out in Meltdown Inspector. When Meltdown Inspector came out, I did some testing. We had 2 different hosts in our environment, 2 different ESXi hosts, one running an E5 2680 2.7 gigahertz, and a brand new one running a 2660 V4 at 2 gigahertz. And what we found was the performance degradation of the 2660 was way more significant than the 2680 that was 4 generations older. So what we needed to do is we needed to change how we were architecting our future platforms to make sure that we were megahertz first over top of core counts. That meant more money had to be spent on hosts, unfortunately, but when it came down to patient care, it was important that the doctors got to their applications as fast as possible. Next, I found that CPU host utilization. Once you started exceeding about 30 to 40%, we would actually see logon performance degrade, and this is what it looked like. So after 30 to 40%, logon times are pretty consistent at any CPU utilization for the host level before that, but once we started to exceed that, we started to see that number ramp up. So I actually work for ControlUp. We've got tools here that can help you monitor and show this kind of information, but this was really valuable. So we set a threshold on our hosts. We did not want them to exceed 30 to 40% utilization. So we set that as our standard, and that's what we did going forward to make sure we had optimal performance. Next, keep NUMA vertical alignment. So if you don't know what NUMA is, it's non-uniform memory access. And so here's actually what it looks like. And Antec put this picture out, and it's a great picture. And it shows you how the memory is accessed across NUMA. So what you want to do is you want to keep in that green space. If you have to go out from one socket to another to access main memory on a different processor, you're going to hit an order of magnitude slower memory process. So that is going to slow down your logons. That's going to slow down the performance of your systems. ESXi, at least the guidance from what I recall last, was that you should not go over an 8V CPU core machine. Otherwise, you lose that NUMA capability. So you want to keep under 8 cores if possible in order to make sure that you're NUMA aligned. Next is to maximize performance, you want to make sure that your power management is set to maximum performance, whether that's in the BIOS at the ESXi level and on the virtual machine level. If you can set all those, you're going to stop the processor from turboing up and ideally sitting at its fastest possible speed. That essentially is what you purchased when you bought it out of the box. And the reason for this is because the changing of the frequency actually pauses execution until the frequency is switched to its new speed. And so when you have turbo boosting, when you have speed shift, when you have all these C states and stuff like that, execution of the CPU will actually pause until that frequency gets shifted. Intel has done a much better job on recent CPUs on actually how quickly they can change the processor frequency. But you can see that in the old days, it used to be around 120 milliseconds. They've got it down to about 60 milliseconds, but these are still milliseconds, not nanoseconds. This still takes time. So ideally, if you can, try to reduce your power management by keeping it at max performance if possible. Last is using vSAN or similar technologies. Obviously, having local storage, this has been my experience, has been much better than shared storage. When you have local storage, the traces in the wires are faster to your storage, so they actually operate a lot better. vSAN is a great technology, especially with the new ESA architecture and flash storage and NVMe for making sure at optimal performance. All right, so to understand your logons, where to begin? So the most important part is to enable proper data collection. Enabling proper data collection gives you the information you need in order to accurately assess your environment. If you don't have proper data collection, if you don't have the proper data, then you're not going to be knowing what you don't know. You're going to be flying blind. So the first thing I recommend doing is enable command line auditing. This is a group policy setting that you set within your group policy, apply to all your VDAs, all your VDI machines, and make sure it's there. This will actually enable some additional settings in the Windows security dialog, and this is what that looks like. So it enables this particular feature here, process command line. And we use that particular marker in various scripts that we have in order to understand when a process starts and ends. Because if you have 5 cmd.exe processes, without that command line string, you don't know which process is related to what. Next, enable print service logging. So by default, for whatever reason, Windows decided that this feature is disabled in logging. Make sure you just check that little box that says enable logging. There's various features in various applications and technologies that impact the logon duration, so they can make your logon wait until the printers are mapped before it actually proceeds to allow you to log on to a machine. When we enable this, we can actually track this within some of the scripts that we have that can help you identify that printers are what's causing you to have slow logons. Next, increase your event log sizes. This is insane. Windows 2000 came out in 2000 or 1999. The event log sizes back then were 20 megabytes. Does anyone know what they are today? 20 megabytes. It's 23 years later. Increase your Windows event log sizes. The sizes that I set is about 500 megabytes today, but really it's going to be based on your storage. Windows has exploded the number of event logs that you have. You don't need to increase necessarily all of them, but definitely the major primary ones, security log, application log, system log, and then some of these tertiary ones like WinLogon and stuff like that. Next, enable process creation and termination logging. So this is really important because this allows us to track when that CMD process has started and when it executed. There's different processes during the logon phase that directly correlate to certain technologies or certain phases. If we can track when that process started and when it stopped, we can tell you how long that phase was. So this is what enables tracking things like logon scripts, print driver installations, third-party CSEs, more, determining the duration of these by the start and stop events of those processes. So there's two methods to enable it. There's a legacy method and the advanced audit policies. This is what they look like. This is what the legacy method looks like. Microsoft strongly recommends you enable it on just one and make sure you stick to just one. Ideally, you'll be using the advanced audit policy, but if you're an old organization that has grandfathered in and you're using the legacy policy, that's fine. But just make sure you stick to one and don't have both enabled. Otherwise, you might get inconsistency in your environment. This is what the advanced audit policy looks like. So you can see it's under detailed tracking. Audit process and creation are now broken out into separate policies. Just enable success for both of them. This is what the event looks like. So you kind of had a screenshot of that earlier, but now with this event created, you can see at the top there's 4689, that's process termination. 4688 is process creation. Once we have that, we now have the ability to track how long a process took. Group policy preferences logging. So this is the client-side extensions that actually run when you're logging into Windows. So group policy preferences, how they operate, at least for the native Windows ones out of the box, is they're all set through group policy. And the real unfortunate thing here is that they were designed back in like Windows 2000. So you need to go and you need to enable this for each policy. I've actually written a script that you can use to just enable them or disable them en masse. But there are some caveats here. So the first one is, again, this was written way back in the day and it hasn't been updated yet. So in my testing, I found this to be safe for single session machines. Multi-session machines, I would not enable this for. And the reason for that is the assumptions they had back then are no longer applicable today. So when they write to the log files, you can actually lock that log file mid-logon by opening it in Notepad. And then what ends up happening is the user just sits there with that logon, applying group policy registry or whatever. And that's because if that log file is locked, it will not proceed logon until it can continue writing it. So make sure you have AV exclusions for these files because AV will lock it, especially if it's getting written to constantly. And that's also why you don't want to enable it in multi-session because they can trade locks during that contention period. Last, and this one is a tough one. Use the newest operating systems. And there are challenges with the newest operating systems, but there are some positives. Especially with Server 2016, the WinLogon log was completely broken. Wasn't logging anything. Server 2012 was fine. Server 2008 was fine. Server 2019 is fine. Server 2016 was not. As well, they've made more detailed logging available in Server 2019 and 2022 that we can use to identify these logon phases. But the challenge with using newer operating systems is Microsoft is adding these new features and using technologies that they had no consideration for the performance or impact on the logons. So if you have AppX packages, which all new operating systems come with and newer operating systems come with more, they tend to negate these benefits. But it's something that I strongly recommend just because the more information that the operating system provides, we can actually give you more information as to what those phases and what's consuming your time. So understanding your logons. So next, the tools that I use when I'm troubleshooting logons. So these are the tools I use. I use Control Up. I use a series of PowerShell scripts. I use Process Monitor, Xperf, and WPA and log files. Unfortunately, I don't have enough time here to go into how to use these tools, but I will try to do my best as quickly as possible here. So first one, Control Up, and I do have one caveat here, and that is I do work for Control Up. So conflict disclosure for sure, but what Control Up does is it allows you to see out of the box the high-level logon stages, and then all of the scripts that I'm going to show you, you can execute through Control Up without having to know the parameters that you need to feed into them. So this is what it looks like in Control Up. You've got your logon duration along with your profile load time, group policy load time, desktop load time, and logon duration other. I always get lots of questions, what is logon duration other? And it's any time that's consumed in your logon that's not a part of the other phases. It just gets dumped into there. We might know your logon takes 1 minute, and profile load time takes 5 seconds, group policy load time takes 5 seconds, desktop load time takes 5 seconds. That's 15 seconds of time. 45 seconds, I don't know, so we dump it into logon duration other. But we have tools to actually identify what logon duration other is and what was consuming time there. So this is the fun part. I want to get into the PowerShell scripts. So I'll flip here and I'll let you take a picture of this because these PowerShell scripts, I highly recommend you download, check them out. All the parameters and stuff are listed in the header so you can actually see what you need to input to get the best data out of them. Ideally, just use Control Up, right click on an object and execute, but if not, it's open source, you can check it out for yourself. So I'm going to get into the first one. This one I have a lot of help, a lot of contribution for, the Analyze Logon Duration script. And so in my humble opinion, this is the best tool for understanding your logon durations. It was originally written by a gentleman named Niran Korin. And Guy Leach then, if you haven't heard of the great Guy Leach, he's a great guy on Twitter. He does lots of dad jokes. He took the script and he optimized the heck out of it in 2018. So he added run spaces to make it more efficient and faster. He optimized a lot of the code that I wrote and stuff of that nature. So he did a great job. The current primary contributors to this script are myself and Guy Leach. And it's commonly abbreviated to ALD. So if I refer to it as ALD, then I'm referring to the Analyze Logon Duration script. So a little bit about it. It's 5,600 lines of code. It does use dynamic C# compilation in order to get some certain information out of the system. Uses numerous run spaces for accessing the event logs. It's fully open source and it's supported by Control Up. The challenge with using C# dynamic compilation is some of you out there have like really secure environments that don't allow scripts with dynamic compilation to execute. And I'm really sorry, I don't have a workaround for that today. So if possible, if you can execute it, then it's great. But if you deny that level of execution, then unfortunately this isn't going to work. So a little bit about the features of it. It does track 9 logon phases, 27 pre-logon, or 9 pre-logon phases, 27 logon phases. We track 5 different vendor technologies today. I'm certainly interested if you have a unique piece of technology that you want to see added into it or that you think is impacting your logon, to reach out to me and I can certainly work with you on seeing if we can find markers to add into it. So these are those logon phases and pre-logon phases. You'll see for the pre-logon phases, we do a fair bit of tracking that. And the reason for that we do the pre-logon phases is when I was working with those doctors and they click on that icon, you would see it spin and then eventually you would see the Horizon client come up and then they'd start getting to the desktop. Well, when you ran Analyze Logon Duration or a lot of these other tools that track logon duration, they're only tracking it when you're connected to Windows. But there's actually a long period of time from that click to when they're eventually connected to that desktop. And if you're sitting there with the doctor doing the stopwatch, that might be 30 seconds of time. So it's really important to try to get that pre-logon phases as well so you can fully understand the experience that your users are having. So some of the features of it, some additional features of it, it also tracks Apex package load time, so you can really get you can really feel along with me the hate for Apex packages. We also track WMI filter duration, client-side extension, aggregated duration, scheduled tasks, RSOP logging state, loopback processing mode. I won't go into those and what they are, but I do have blog articles out there. If you search for Trent and Ty and RSOP or just Trent and RSOP and loopback processing mode, I will tell you why it's important to have these values set in a certain way. So some advanced features of it as well, it creates offline analysis packages. It does a do your best analysis. So if you don't have all of the prerequisites enabled, it will try to provide you as much information as possible. We try really, really hard to make it so that way it gives you something that's actionable if you don't have the prerequisites completely enabled, but highly recommend you do. So this is what it looks like. I'm using a Citrix example here, my apologies, but I'll run through it anyways. So at the top, we got the header here. So we got username, the loopback processing mode set to replace, so good for me. RSOP logging set to disabled, so good for me. We track the logon duration start and end. In ALD, if we have the pre-logon phase, then we consider that the logon start. We actually don't consider it when the Windows one begins. So in this particular case, you can see it's 196 seconds, but the actual Windows duration when it connected to the Windows machine was 172 seconds. So there would be 20 seconds that a doctor would have on his stopwatch that you would not have if you just looked at the Windows portion. Then we have the pre-logon phase itself. Next, so this is the actual meat of it when you get into the Windows logon duration. So this is when it's connected to Windows. You're seeing that please wait for Windows. This is what that's doing during that time. So we track the source from all the different technologies. So Windows, FSLogic, Citrix, VMware, Avanti, and the shell. So the shell is when Explorer starts. We look at the different phases as they occur. So the Windows logon time, load profile, RSOP, et cetera, et cetera. You can see all that here. We can see we've got the 2 Apex phases here. So interesting thing here, Microsoft had moved file associations in Server OS to be higher up. So they don't have it as part of the shell. So that actually gets removed from the shell processing. But they still have the Apex load packages actually in the shell phase. So unfortunately, in Server OS, that gets removed, but this one doesn't. So some time is saved here, but not there. I can't explain the logic. Next, the duration. So this is pretty easy. Take the end time, subtract the start time, you get the duration. So that's how long all of these phases took. Gaps. I get questions about gaps quite often. So what is the gap? Why is it there? So what a gap is, it's an unexplained time. So an unexplained amount of time. So in this one, we've got a really good view of all of these phases and there's almost no gaps between. Well, these little gaps here, these 0.1 seconds, 0.6 seconds, usually that's transition time. That's like context switching from the logon phases, from ending one phase of the logon to starting the next part of it. You know, if it's reading a file, like it's reading the CSV, it's actually stored in an XML file, so that amount of time isn't stored in any logs, but it still takes time to process it, and if it takes 0.1 seconds, unfortunately, since there's no markers, it just goes into the gap, but that's what it is. If you see a long gap, that's when I really get excited. So that's when you reach out to me and you say, hey Trent, we got a long gap, can you help me out? I'll hop on a call with you and we can actually do a procmon trace or something like that to see if we can identify it. Underneath, WMI filters. So this was an exciting feature I added last year, WMI filters. So when you have WMI, who here uses WMI filters on their GPOs? Too many people. But the challenge with WMI filters is, do you know how long the query takes? Most people don't, right? So in this particular case, it's actually SelectStar from Win32 product where it happens to be Citrix, or you can have VMware or whatever. This is the worst WMI filter you can have out there. So what this does a repair reinstall of every installed application on your system. I don't know why they designed it that way, but then it got out there that this is what you use to check to see if a program's installed. This is the worst thing you can do for your group policy performance. I was on a customer call where we originally designed this feature because they were having such long logons, and we found it was WMI that was doing it, and they were using this filter. So this filter was direct from them. Crazy. Next is the Apex package load time. So a little caveat about Apex packages too. You can see that they've got all these durations here, but it may not add up to the total time that it took to load when you saw it earlier in the analysis. And the reason for that is Apex packages are loaded both synchronously and asynchronously. So they're loaded 2 at a time. So if you've got package 1 and package 2, package 1 completes, package 3 then starts. Package 2 finishes, package 4 then starts, and so on and so on. So you're stuck with this little laddering effect here. So the more Apex packages you have on your system, the slower your logins are going to be. So 100% remove as many as you possibly can. Last is non-blocking tasks. So this, or second to last, non-blocking tasks. So what these are what I call CPU suckers. So because logon duration, logon process is a single-threaded process for the majority of it, these guys will steal the CPU that you're using to actually do your logons. So if you can, disable as many logon scheduled tasks that occur during your logon. And some of these are just really confusing. We are not an Azure Active Directory environment, but sure enough, it checks to see if it needs to join Azure Active Directory. So disable that logon task, save some CPU cycles, see if you can get some fractional performance in your logon duration. Next is client-side extensions. So these are all client-side extensions that are occurring in your environment. You can see I actually got one here, group policy shortcuts. It's got 15.2 seconds. It's just on one group policy, thankfully. If there was multiple group policies, this is an aggregate metric for your client-side extensions. So it actually becomes quite difficult when you've got like 30 or 40 client-side or group policy objects to identify which one was the cause. But don't worry, I have a solution for you there. Last is just a little informational message. So I did just add, I believe just a couple months ago, some support for DEM within Analyze Logon Duration. We did find that these two features, path-based import and async actions, were causing delays for a particular customer. So I did add that into Analyze Logon Duration. So we are doing some DEM event there, which does cause some delays. So if we wanted to understand the group policy object that was actually causing the delays, we can use analyze detailed GPO duration. So this is a PowerShell script that I wrote. It breaks down the individual group policy object performance for the client-side extensions that are processed within. You can identify the individual GPO that's causing the lag. It does require that logging to be enabled because without that information, I can't help you out. I built a little feature within that script. You do dash enable, boom, all of the logging's enabled for every CSC on there. Set it to dash disable, all the CSCs are now disabled for logging. This is what it looks like. So we got the user header at the top, logon time, and then when the group policy preferences policy event time started, there's an initialization time. It's negligible most of the time, about 150 milliseconds or so per group policy client-side extension. Now I've got two outputs. One is GPO processing breakdown per client-side extension per GPO. So here we can see EUC common settings took 1500 milliseconds for the group policy registry, and it also took 2 seconds for group policy registry processing as well. So if I go down further, I can actually get it broken down per group policy object. So I can see the majority of my time is spent in this one particular group policy object. It spent 17 seconds there. So now if I wanted to optimize it, I could target just this specific group policy object to see what I can do to make this better. All right, next is a remote event log tailor. So this is a really cool script by Guy Leach. It aggregates events across multiple machines. It leverages the out-grid view for the events. This is what it looks like. So once you start executing it, this is all in real time. So if you do this during a logon, you'll see pauses in it, and that's when processing is occurring. So it's actually really cool for watching the events, and as they flow through, seeing a pause, and if you can check what that last event was, then you get an idea for where it's being delayed, and then you can start targeting that particular piece of information or that particular technology for optimization. Next, Procmon, trace system activity. So Procmon is a beast in and of itself, and the biggest challenge with Process Monitor when you're talking VDI is how do you execute it in a single session machine? And that's where Control Up comes into play. You can right-click on your VDI machine and run this particular script action, and then it starts logging, and away you go. So it does have some advanced features. It will auto-download Procmon if you don't have it in your environment. It can drop filtered events, so that way it reduces your CPU load. You can specify additional custom filters, and it can save the log file to custom locations. So these are what the parameters look like in Control Up. You can look at the header of the script for them and actually look at the examples as well, so you can do that manually if you so choose. So just some hints. Try to reduce the data set. Run analyze logon duration on the Procmon data set that you have. Exclude events before and after so you minimize the amount of data you're going through. You saw in the ALD output, they had the start event and end time. So if you wanted to look at a particular piece of technology, find that timestamp, exclude events after, exclude events before, and then just look at that data to see what it's doing. All right, last one is event log aggregator. So this is essentially the remote event log Taylor script, except this is post facto. So this is after the fact of a logon. So what you can do, it's a really cool script. Again, by Guy Leach, this guy is amazing. Aggregates events across multiple machines. So if you target it on a broker machine along with your VDI machine, you can actually see the information flow. Really, really neat. It'll put the events in chronological order for you. So make sure you're using NTP time and all that other stuff to make sure your time is in sync. This is what it looks like. So it looks very similar to the remote event log Taylor. So again, you run analyze logon duration, you start looking at those timestamps, you go down to the timestamps, you can see what's happening. So this is AppX. This is what the AppX packages are doing, or some portion of it. One portion of AppX is it loads into the start menu, and so that's where you see the start layout population. So we run this script and we start looking at those timestamps and we start understanding what those packages are doing, what it's doing during this time. So this is an example of that. So as I said, I did have a lot of resources. You can come check me out at the Control Up booth as well. I can share these resources for you, but I've done a lot of work on analyzing logon durations, helping a lot of customers, helping a lot of people like yourselves who want to do better in your environment. And you know, a rising tide raises all boats. So if we can do that for you, then, and we can make your environment more efficient, we can make the doctor care and the patient care better, that's like a personal goal of mine. So it doesn't have to be a doctor's office. You could be in finance or technology or anywhere else in the industry, but if we can reduce these logon performance to get people as productive as possible, as fast as possible, I want to make that happen for you. So, and those people who want to make it happen for themselves, these resources hopefully will help you out. Right, and thank you so much.